welcome back to the tutorial series. In this part of the tutorial, we will be modifying the Unreal Engine game server code so that the server can interact with the GameLift service. For example, we will make the server accept player sessions upon authenticating incoming player connections, terminate the game session once the game is over, and handle backfill in order to get new players into existing matches. The server will also make an HTTP request to an Amazon API Gateway endpoint that will invoke an AWS Lambda function that will update player stats and match results in DynamoDB. This will be the last part of the tutorial that involves coding, so after this video we should have the finished tutorial project. So let's get started. And I just want to quickly thank everyone who has donated to us, whether it would be through PayPal or Patreon. Link to those will be in the description below. We appreciate every single donation, no matter the amount, because it supports us so much. But before we start coding the server, I want to begin this video by going over some minor corrections and potential suggestions that I would recommend for the client and client service that we have been working on for the last few parts of the tutorial. These changes are technically not necessary, meaning that your client and client service code will still work without these changes. The very first thing I want to do is look at our project in Visual Studio. So go to File Explorer where your project is located and open up your project's Visual Studio solution file. And in the last few parts of the tutorial, I sort of misunderstood the meaning of the content type application/JSON header, and I ended up adding it to HTTP requests that didn't need it. For example, let me find an HTTP request that did not need this header inside this main menu widget C++ class. So let's scroll up to the onExchange code for tokens response receive function, because in there we make an HTTP request to the get player data API endpoint. Now, in this HTTP request, we don't need the content type application/JSON header because we don't have any request content. Essentially, you should only add this HTTP header when you are sending a request that has content that you want to be encoded in JSON UTF-8 format. For example, if I scroll down to the onMatchmaking onClicked function and look at the HTTP request that we make to the stop matchmaking endpoint, we have some request content. So in this case, it makes sense to set the content type header to application/JSON because we want that request body to be encoded in JSON format. Now, if we go back to the onExchange code for tokens response receive function, as you can see, there's no response content. There is an authorization header for the access token, but that has nothing to do with the request content. So this content type application/JSON header for this HTTP request, where we set it on this line, we can comment that out. Now let's go to the other HTTP requests that also don't need this header and comment out the exact same line. So there's another instance where we made a request to the get player data API endpoint in this main menu widget C++ class, specifically in the native construct method, when we checked if the access token length was greater than 0. So let's comment out that line where we set the content type header to application/JSON. And the last HTTP request that didn't need this is when we made an HTTP request to the invalidate tokens API endpoint in the GameLiftTutorial game instance C++ class, specifically in the shutdown method towards the bottom of it. So let's comment out that line where we set the content type header to application/JSON. Now again, the request header won't break anything if your HTTP request didn't have any content or a body. It's just redundant to include it when your request doesn't have content or a body. But I think it's good to know that this line of code is not always required for every single HTTP request you make. Go ahead and make sure Development Editor is selected for the solution configuration. Win64 is selected for the solution platform. Right-click your project in the Solution Explorer and select Build. Keep in mind that we will most likely not be repackaging the client for Windows, so these 3 lines of code that were just commented out will not make a difference if the client doesn't get repackaged. Like I just mentioned, the extra headers won't prevent the client from functioning correctly. This was just a quick explanation on the purpose of the content type application/JSON header, so I will not be repackaging the client anyways. Once the project is finished building, the next thing that I want to address is related to the client service. So in the web browser of your choice, let's have both the API gateway and Lambda dashboards opened up. So throughout the tutorial series, in the Lambda functions we wrote, we coded the request validation ourselves. For example, let's open up the poll matchmaking Lambda function. Scroll down and press Ctrl+ a few times inside the window editor to zoom in. At the beginning of this function, right here on lines 8 through 13, we check if the event object passed in has a body, parse the body, and then check if the body has a ticket ID property. Now you can actually perform the same validation, checking if the incoming request has a body with a ticket ID property inside of it through API Gateway. And in that scenario, you could have actually removed these if checks and just assume that the event object has a property called body that is a JSON formatted string. And once that string is formatted, the resulting object will have a ticket ID property. Also, if you did use API Gateway to perform the request validation for you, you wouldn't need lines 15 through 23 down here, because API Gateway will actually create a negative response for you and return it when the request body does not have the necessary fields that you specified. Now in this tutorial, we won't be going back and modifying all of our Lambda functions, because I don't think it's worth changing our client service at this point. But in case you guys are interested, let me go to API Gateway so that I can just show you guys how you would go about doing this. From here, let's click on the name of our API. Make sure you have the resource selected here on the left side. And let's just click on a method under one of our resources for this API. Let's just do poll matchmaking. So under where it says poll matchmaking, click on post, and then click on where it says method request. And notice under the settings section that there is a field called request validator that is currently set to a value of none. Now if we click this pencil icon here to edit this value and we click on this drop down menu, you will see 3 options. Now usually you would choose the middle option that says validate body, query string parameters, and headers, because not only do you want to validate the request body, but also you want to validate the request headers to make sure that the request contains a content type application/JSON header. For those who may be wondering about the authorization header that we pass the access token through, you can also add validation for that, but the Cognito authorizer that you already added up here should already take care of that. And let's click the X button by the request validator, because again, I'm just showing how you would add request validation via API Gateway, but not actually doing it for this tutorial. And then underneath the settings is where you specify what you want to validate. So starting with the URL query string parameters, if you click on this section to expand it, you'll see a couple things here. You'll see a button that says add query string. Now if you did click this button, you would get a new row in this table with 3 columns, name, required, and caching. And in there you can specify the name of each query string parameter that you want to be passed in request to this API method, and whether or not you want those query string parameters to be required or not. Moving on to the HTTP request header section, if we go ahead and click on that to expand that section, it works similarly to the URL query string parameter section. You have a button here labeled add header, and if you click that, you will get a new row in this table that has the exact same columns as the table underneath URL query string parameters. You can add headers that you want requests to this API method to contain and specify whether or not they are required or not. But for the request body section, if we expand this section, it works a little differently. You don't add body parameters one by one here like you would do for the URL query string parameters and the HTTP request headers, but rather you would create what is called a JSON schema model by going to where it says models on the left side. And once you have a model, you can then use that for the request body for validation purposes. Again, in this tutorial, I'm not going to do any of this in the tutorial series. These are just useful features of API Gateway that I recently discovered that I recommend everyone to check out. And for those who are interested, I will have a couple useful articles about request validation through API Gateway in the description below. Lastly, as for why anyone would be interested in these API Gateway features, there are a couple of reasons. One, they reduce boilerplate code in your Lambda functions. For instance, extra if statements and forming custom responses for improperly formatted requests. and 2, it can theoretically save money by slightly reducing the number of times that Lambda functions would have been invoked. Because if a request can't pass API Gateway's validation, then the Lambda function will never be called in that case. With the free tier, you probably won't even notice the cost savings, but for a bigger project that gets hundreds of thousands to millions of API Gateway requests and Lambda function in the invocations, this could make a difference. And one more point I want to make before going into the server is that I know we have been using Postman for testing our API, but in addition to that, you can also use the API Gateway Tester. I'm just going to simply show you guys where this is located. So for each API method, if we go back to the resources section, let's go to poll matchmaking. And you'll see when you click on the method under any one of these resources that there is a button called test with a lightning bolt underneath it. So if you click on that button, here you can specify all you need for a sample test request, including the query string parameters, the request headers, as well as the request body. However, Postman should still be used to confirm the API routes. Now with all of that finally said, let's go back to the Lambda dashboard by going back up here and clicking on where it says functions so that we can see all the functions, and let's go ahead and create a new function. Now this function will be invoked by the server and will be responsible for recording match result data in DynamoDB after a match is finished. So let's go ahead and call this function record match result and then create the function. Before we start coding this function, let's make a new table in DynamoDB to store match result data. So go to the DynamoDB dashboard and click on where it says create table. And then for the table name, let's call this table match results. And for the primary key of this table, let's have a partition key called ID and keep it as type string. And also make sure that you are using the default settings, and then go ahead and click on create. Once the table is created, let's go back to the record match result Lambda function, and let's start by adding a Lambda layer. So click on where it says layers, and then you should see a button called add a layer appear, so click on that button. Now since the last few videos that we made involving making Lambda functions, AWS has kind of changed how you add a layer. So by default it will have AWS layer selected out of these 3 options here at the top. Make sure you select custom layers so that now when you click on this drop down menu under where it says custom layers, you will see your custom layer that we've been using throughout this tutorial series. And for the version, just use 1 and then click on add. And then let's scroll down to the inline code editor and press Ctrl+ a few times inside of here to zoom in. And the very first thing we are going to code is outside of the handler function, and we are going to import some node modules. So type out const AWS equal require in parentheses and in quotes AWS-SDK, and then const GameLift equal new AWS.GameLift, and then in parentheses and in squiggly brackets region colon, and then in quotes the code of the region that you're operating in. So for me it's going to be US-East-1, and then const DynamoDB equal new AWS.DynamoDB, and then in parentheses and in squiggly brackets region colon in quotes the code of the region that you are operating in. And I just realized I made a typo here. This should be a capital B in DynamoDB in AWS.DynamoDB. Now going back inside the handler function, let's make some local variables. So get rid of everything inside of here and type in let response, let raised error, let game session ID, and let winning team. Now the game session ID and winning team local variables will come in from the incoming request body. So let's check if the event object passed in has a body property by typing if in parentheses event.body and then squiggly brackets. Let's parse the body by typing const body equal json.parse and then in parentheses pass an event.body. And let's check if the body object has a game session ID property by typing if in parentheses body.game session ID squiggly brackets. And if it does, let's set our local game session ID variable to that game session ID value in the body object. And then let's do the exact same thing for the winning team. So check if it exists in the body by typing if in parentheses body.winning team, and then squiggly brackets, set the winning team local variable equal to that body, or equal to that value in the body object. And then let's do some validation on the winning team variable to make sure that the incoming request body had a winning team value of either cowboys or aliens, because in our rule set the teams were called cowboys and aliens. Otherwise we will send a negative response back. So type out if in parentheses winning team not equal in quotes cowboys double ampersand winning team not equal in quotes aliens, and then in squiggly brackets, hold on here, I made a typo, winning team with 2 N's. In here we'll set response equal to in squiggly brackets status code colon 400 comma body colon JSON not stringify in parentheses and in squiggly brackets error colon in quotes incoming request did not have a valid winning team. And then add a semicolon here and return the response. And if we know that we have a valid winning team value of either cowboys or aliens, then let's perform a couple of functions asynchronously. The first function will be checking if there's already a match result recorded for the game session ID passing through the request body. This is to prevent double posting so that once we have the result recorded for a game session, we can't record another result for that very same game session. The other function will be checking if the game session ID is valid and getting the details about the game session associated with the game session ID. And the reason we are going to be calling both of these functions asynchronously is that neither of these two functions depend on each other. If we learn that either a match result has already been recorded for the game session or there is no game session associated with the game session ID passed in, then we can end this lambda function and return a negative response. But remember that only one of these conditions have to be met, not both. Let's first make the request parameters for the call to DynamoDB get item so that we can tell whether or not a match result was already recorded for this game session ID by typing const DynamoDB get request params, and we'll set this equal to squiggly brackets, and this object will contain 3 properties. The first one will be called table name, and the value for this will be in quotes the name of the table in DynamoDB, which in this case is match results. And the second property will be called key, and this property will be an object with a property called ID, since that is the name of the partition key of the match results table. And then the value for the ID property will be an object, so type out some squiggly brackets with a property called S, because the ID is of type string, and then for this we'll pass in the game session ID as the value. Now the last property will be called projection expression, and we'll set this to a value of in quotes ID. The reason that we are adding a projection expression property is to make this call to get item faster, because we don't care about all the data in the item in the match results table, but rather we only care about whether or not an item even exists for the game session ID. And don't forget to add a semicolon at the end. And unlike past lambda functions, we are going to make a variable of type const and call it DynamoDB get match result promise, and we're going to set it equal to DynamoDB.get item in parentheses DynamoDB get request params, and then .promise parentheses, but no .then or .catch just yet, because we are later going to be calling promise.all to run multiple promise functions asynchronously and wait until the call to DynamoDB get item and the call to GameLift describe game sessions finish. With that said, let's now make the request parameters for GameLift describe game sessions. So type out const GameLift request params and set that equal to an object that will have one property called game session ID, and then the value for that property will just be our game session ID local parameter. our local variable. Now let's get a promise for the call to GameLift describe game session. So just like before, let's make a const variable and we'll call it GameLift describe game session promise, and we'll set it equal to GameLift.describe game sessions, and then we'll pass in parentheses GameLift request params, and then dot promise parentheses. And the game session object returned from GameLift describe game sessions will contain matchmaker data, which is a JSON formatted string that contains information about all the players involved in the match, such as their skill attributes and which teams they belong to. So let's make a local variable called game session to store this game session object. Also, sorry about this guys, I just realized this, but earlier when I was typing on line 39, I forgot the I in promise when naming this const variable. It should be called DynamoDB-getMatchResult_promise with an I. Now we are going to execute these functions asynchronously and wait for both of them to finish by invoking the promise.all function. Promise.all takes multiple promise objects as input and returns one promise as an output. And then we can use the await keyword on that promise return to wait for both the DynamoDB-getItem function and GameLift describe game sessions function to finish. Or, because we are using promise.all, we will wait until one of those functions throws an error if that even happens. And that makes sense because again, only one of those functions have to throw an error for us to know that we should stop this lambda function. Also, I want to repeat that we are letting both of these functions run asynchronously because it will be faster. Neither one of these function calls depend on one another, and one of the factors that affect AWS Lambda costs is the duration of each Lambda function execution. So let's actually call these functions now and wait on them by typing out await promise.all and then in parentheses type in a pair of squiggly brackets, and in this array pass in DynamoDB-getMatchResult_promise, comma, GameLift describe game session promise. And then on the next line, let's add a .then, and then in parentheses pass in values, arrow, squiggly brackets, and then underneath the then type out .catch, and then in parentheses error, arrow, squiggly brackets, and then we'll end this off with a semicolon. So in the case of when both of the functions are finished and each of their respective callback functions get called, the data returned from those callback functions will be stored in this values parameter in this then function, which is an array that has a size equal to the number of promises passed into promise.all. And each entry in this values array contains the data returned from the callback function of the corresponding promise. So for example, at index 0 of the values array, there will be the data returned from the DynamoDB-getItem function. And at index 1 of the values array, there will be the data returned from the GameLift describe game sessions function. And if any of these functions throw an error, the other function will stop executing and the catch function down here will be called, containing the error thrown by that function. Hence why the parameter in the catch function is singular as opposed to the parameter in the then function being plural. So going back to the then function, let's first check if there is already an item in the match results table corresponding to the game session ID by typing if in parentheses values square brackets 0 double ampersand values square brackets 0 dot item, and then a pair of squiggly brackets. And if there already is a item in the match results table for this game session ID, then we shouldn't double post. So let's set the erased error local variable equal to, in quotes, the result of this match has already been recorded. Now, if there hasn't been a match result recorded for that game session ID, then let's store the game session object returned from the GameLift describe game sessions function by typing else, and then in squiggly brackets, if in parentheses values square bracket 1 double ampersand values square bracket 1 dot game sessions double ampersand values square bracket dot game sessions dot length, and then greater than 0, and then squiggly brackets. Now, I made a typo here. This should be values with 1U, but the GameLift describe game sessions function will return a data object containing an array called game sessions. The reason why it's an array sometimes is because sometimes, depending on the request parameters you pass in, you may get multiple game session objects returned. Now in our case, because we only specified a game session ID in the request parameters, we will usually get back one game session at most. Now you could also sometimes in the request parameters specify a fleet ID, and as a result you would get multiple game session objects in the game sessions array. But in our case, we only specified a game session ID, so we can set our local game session variable equal to values at index 1 dot game sessions at index 0, because if there is a game session associated with that game session ID, then there will only be one, as the game session ID is a unique identifier for the game session. Now, if there is no game session object, or the game sessions array is empty, in the else case, so type out else squiggly bracket, let's set raised error equal to, in quotes, unable to retrieve game session data. And of course, if the catch function gets invoked, then let's set raised error equal to error. Now after promise.all is finished, let's check if the raised error local parameter was set to some value, because if it was, then we should return a negative response. So type out if in parentheses raised error squiggly brackets and then response equal in squiggly brackets status code :400 comma body JSON dot stringify, and then in parentheses and in squiggly brackets error raised error, and then semicolon, and then return response. And if there was no error while calling those two functions, let's parse the matchmaker data in the game session object, because once again the game session object should contain the matchmaker data associated with that game session in the form of a JSON string. So let's make a const variable called matchmaker data and set that equal to JSON.parse, and then in parentheses passing game session.matchmaker data. And sorry about that, this should be a capital M in the first M in matchmaker data in game session.matchmaker data. And using the matchmaker data, we will make an item to put into the match results table, but also we are going to update the individual player wins and losses for all the players involved in that match. So we're going to need a quick way to reference which team each player was on later on in this function. So we're going to make a const variable called player ID to team map, and we're going to set it equal to an empty object, because this will be populated later once we look at the matchmaker data in depth. Now let's make the request parameters for a call to DynamoDB put item. So type out const DynamoDB put request params, and we'll set this equal to an object with a couple properties. The first one will be table name. The value for this will be in quotes match results, because we're going to put an item into the match results table eventually. And then the second property will be called item, because this will be the actual item that we're going to put into that table. So that is going to be an object as well, and we can define one property in the item ahead of time. So let's define the ID, since that was the name of the partition key in the match results table, and that will be an object with a property called s, since the ID is of type string. And for the ID in each item of the match results table, we are going to use game session ID. So type out the game session ID local parameter, and then let's end this off with a semicolon. Note that the put request parameters will be modified later on, so that the item we put into the table will also contain individual players. Now, like I said before, we also have to update individual items in the players table by incrementing the amount of wins or losses they have, but we don't know how many wins and losses they have, so we have to perform a batch get item operation on the table. let's make the request parameters for that function by typing const DynamoDB batch get request params, and we'll set that equal to an object with a property called request items, and this will be an object containing a property called players, and this will also be an object with a property called keys, and this will be an array. So type in some square brackets there, as well as a semicolon at the end. And note that these keys will be populated as we traverse the matchmaker data. Now let's look at the matchmaker data by looping through each object in the teams array inside the matchmaker data object. Now before we move on, just to give you guys an idea of what I'm talking about, let me show you guys an example of the structure of the matchmaker data, what it looks like after being parsed into a JSON object. By the way, this article I'm showing you guys right now in the GameLift documentation, we will have a link to this in the description below. So at the top level here, you have three properties: match ID, matchmaking configuration ARN, and teams. And the only one we really care about is the teams property, because this teams array will contain an object for each team in your matchmaker. In our case, instead of attacker and defender, it would be cowboys and aliens. And each team object will contain a field called players, which is an array of player objects that include an object called attributes, which is a map from attribute name to attribute value. So in this case, the only attribute in this case is called skills. In our case, it's called skill singular without an S, so not plural. Now, I want to take the useful information from this matchmaker data object, specify which team was the winning team, and store it in an item in the match results table. So let's iterate the teams array by typing for, in parentheses, const team of matchmaker data dot teams squiggly brackets. And first, let's get the name of the team that we are iterating on. So type const team name and set it equal to team dot name. And let's set a flag to denote whether or not this is the winning team. So type let is winning team, and by default set it equal to true. Now if the team we are iterating on is indeed the winning team specified by the request body parameter, let's initialize the winning team property of this new match result item. So let's type if, in parentheses, team name double equals winning team, and then squiggly brackets, DynamoDB put request params dot item dot winning team equals, in squiggly brackets, M, because this winning team attribute will be of type map, and then colon, squiggly brackets again, and then this winning team attribute will contain two attributes itself. So the first one will be called name, and this name will be of type string. So we're gonna have squiggly brackets S colon, and then the value of the name will be the team name. And then comma, we're gonna have players colon, and then this players attribute in this winning team attribute will be a list. So we're gonna have squiggly brackets L for list colon, and then the value for this attribute will be, for now, an empty array. So type out a pair of square brackets, and then let's add a semicolon here at the end. But if the team that we are iterating on is not the winning team, then let's initialize the losing team property of the new match result item. So let's type out underneath this if statement here, else squiggly brackets DynamoDB put request params dot item dot losing team equal, in squiggly brackets, M colon, in squiggly brackets, name colon, in squiggly brackets, S colon, team name, then squiggly brackets, and then let's add a comma, and then players colon, in squiggly brackets, L colon, square brackets, and then a squiggly bracket, and then let's add a semicolon here at the end. And in this case, let's also set the is winning team flag equal to false. Now let's iterate through all the player objects in the team object that we are currently iterating on. So type out for, in parentheses, const player of team.players and then squiggly brackets. Let's extract some information from this player object that we are currently iterating on and put it in some local variables. So type out const player ID, set that equal to player.player ID, and then also type out const player skill and set that equal to player.attributes.skill.value attribute. Now the first thing I want to do is add the player ID to the list of primary keys that we will use in our call to DynamoDB batch get item later to retrieve a bunch of items from the players table. So let's write DynamoDB batch get request params dot request items dot players dot keys dot push, and then in parentheses and in squiggly brackets let's type in ID colon and then in squiggly brackets s colon player ID, and then let's add a semicolon here. And then let's make a player item to add to the players array in either the winning team or the losing team attribute of the new item that we're going to put in the match results table. So type out const player item and set that equal to in squiggly brackets m colon then a empty pair of squiggly brackets as well as a closing squiggly bracket and then player item.m.id. We'll set that equal to in squiggly brackets s colon player ID, then a closing squiggly bracket. And just a reminder here, this is still an attribute within DynamoDB, so that's why we have to specify the type here as m, because this player object in this list of players is an attribute of type map, and then the attributes inside this map object will also have to be typed as well. So for example, the ID attribute in this player map will be of type string, so that's why the property is called s. And if we do player item.m.skill, we're going to set that equal to in squiggly brackets n, because this attribute will be of type number, and then colon player skill dot toString parentheses and then a closing squiggly bracket. And the toString method is being called here because again in DynamoDB it only accepts string input for even attributes of type number. It's weird. I don't know why they do this. But then which players list do we add this player map object to? The one in the winning team attribute or the one in the losing team attribute? That's why we created that is winning team local variable earlier, to tell us whether or not we are currently iterating on the winning team. So let's check if is winning team is true. So type out if in parentheses is winning team and then a pair of squiggly brackets. And if it is, then let's add this player item to the match result items winning teams player list attribute by typing DynamoDB put request params.item.winning team.m.players.l.push and then in parentheses passing player item. However, if we are not currently iterating on the winning team, then let's add this player item to the match result items losing team's player list attribute. So type out else and in squiggly brackets DynamoDB put request params.item.losing team.m.players.l.push and then in parentheses passing player item. And lastly, because we will need a quick way to know which team a player belonged to later on in this function, let's write player ID to team map and then in square brackets player ID, and we'll set that equal to team name. Now let's call DynamoDB batch get item to get all the items of the players in this match. So first, outside of both of these for loops, let's make a local variable called player array to eventually store all of those player items that we get back from that call to batch get item. And then let's actually call the batch get item function by typing await dynamodb.batch get item and then in parentheses passing the DynamoDB batch get request params. Then underneath that have .promise parentheses .then and then in parentheses data arrow squiggly brackets, and then underneath that have dot catch, and then in parentheses error, arrow, and then squiggly brackets, and add a semicolon here at the end. If the call to batch get item was successful, then the then function up here will be invoked. So in here, let's check if we got any player items back. So type out if in parentheses data double ampersand data dot responses double ampersand data dot responses dot players double ampersand data dot responses dot players dot length greater than 0, and then squiggly brackets. Let's set the player array local variable that we defined earlier equal to data dot responses dot players, which is basically just an array that will contain all the items returned from our batch get item operation. But if no player items were returned, then let's set our raised error local variable to a value that indicates that. So type out else in squiggly brackets raised error equal in quotes no player data found. And then of course, if the batch get item function threw an error, this catch function will be invoked. And in here, let's set raised error equal to error. And after this batch get item function is finished executing, let's check if anything went wrong during that DynamoDB operation by typing if in parentheses raised error, and then in squiggly brackets, if something did go wrong, then let's return a negative response. So type out response equal in squiggly brackets status code colon 400 comma body colon JSON dot stringify, and then in parentheses and in squiggly brackets error colon raised error, and then add a semicolon here and then return the response. Now we have to use the player items returned to configure a DynamoDB batch write item request so that we can update individual players' wins and losses. So let's initialize our request parameters for that operation by typing const DynamoDB batch write request params equal in squiggly brackets request items colon squiggly brackets players, because that's the name of the table, and then colon square brackets, and then add a semicolon here at the end. Now let's iterate through the player items by typing for in parentheses const player of player array, and then squiggly brackets, and in here let's initialize a variable for the item to be added to the players table. Keep in mind that these items technically already exist in the table, so they're going to be overwritten with the new number of wins and losses. This is synonymous to what is called an upsert operation. So let's type out const player item and set that equal to an empty object. Now let's retrieve the player ID from the player item that we are currently iterating on by typing const player ID equal player.id.s, and let's set the ID attribute in the new player item that will replace the old one by typing player item.id equal in squiggly brackets and then in s colon player ID. Now if this player item belonged to the winning team, let's increase the number of wins by 1, but keep the original value for the number of losses. So to do that, let's type out if in parentheses player ID to team map, and then in square brackets player ID, and then check if that value from the map is equal to winning team by using the double equals operator, and then add some squiggly brackets here, and then let's again increment the number of wins. So type out player item dot wins and set that equal to in squiggly brackets and colon, and then in parentheses parse int, and then in parentheses player dot wins dot n comma 10. We're calling the parse in function because the player item coming in that we got from the response from the batch get item request will come in as a string variable, and then so we have to convert it to an integer, and then once we have the integer value, we're going to add 1 to it, and then we have to actually convert that number back to a string. So do .toString here, because again, when you're writing items to DynamoDB, all the attributes, at least when they're numbers or strings, they have to be of type string. And then we're going to keep the same amount of losses, so type out player item dot losses and set that equal to, in squiggly brackets, n colon player dot losses dot n. And of course, if the player does not belong to the winning team, then they belong to the losing team. And we will keep the same amount of wins, but increase the number of losses by 1. So type out else, and then in squiggly brackets, player item dot wins equal, in squiggly brackets, n colon player dot wins dot n. And player item dot losses equal, in squiggly brackets, n colon, in parentheses, parse int, and then in parentheses, player dot losses dot n, comma 10, and then plus 1, and then dot to string. And then that should be it for the updated player item. So let's add it to our batch write request params by typing dynamodb batch write request params dot request items dot players dot push, and then in parentheses and in squiggly brackets put request colon, and then in squiggly brackets item colon player item, and then let's add a semicolon here. Now, like the last time we called promise.all, let's get the promises for both the call to DynamoDB put item as well as the call to DynamoDB batch write items, and store them in a couple of variables, because these DynamoDB operations are independent of each other. They are being performed on separate tables. Put item will be for the match results table, and batch write items will be for the players table. Therefore, we can execute them together asynchronously. So let's add this for loop const dynamo db write match result promise. I'm just going to make this a capital M in match, and we're going to set this variable equal to dynamo db dot put item, and then in parentheses let's pass in dynamo db put request params, and then do a dot promise after that. And then we'll also make another variable, a const variable called dynamodb update player stats promise, and we'll set this equal to dynamodb dot batch write item, and then in parentheses pass in dynamodb batch write request params, and then dot promise. Then let's actually execute these functions by typing await promise.all, and then in parentheses, and then in square brackets, dynamodb write match result promise, comma, dynamodb update player stats promise. And then underneath this, we'll do a dot then, and then in parentheses, values, arrow, squiggly brackets, and then underneath the dot then, add a dot catch, and then in parentheses, arrow, and then squiggly brackets, and we'll add a semicolon. And if those two functions ran successfully, then we should be in this then callback function, and if that is the case, let's make the response to return positive. So type out response equal, and then in squiggly brackets, status code colon 200 comma body colon json dot stringify, and then in parentheses and in squiggly brackets, let's type out success, and then colon in quotes, match result has been reported. And then let's add a semicolon here at the end. But of course, if an error was thrown by either of these functions, let's make the response to return negative by typing inside the catch function response equal, and then in squiggly brackets, status code colon 400 comma body colon json dot stringify, and then in parentheses and in squiggly brackets, error colon error. And then let's end the function off by returning the response. And then click on the save button on the top right of the page to save your changes. Okay, now before we test this Lambda function, let's modify this Lambda function's roles policy so that it has permission to call certain AWS services on specific resources. So let's scroll up. Let's go to the permissions tab here on the top left and click on under where it says role name, under where it says execution role, the Lambda functions role. And that'll take you to this IAM management console page where you'll see the permissions policies here, and click on this policy under where it says policy name. And then from here, click on the edit policy button and then go to the JSON tab. And from here, we're going to add 3 new objects in this statement array. So the first one will be for granting access to call GameLift describe game session. So after this last closing squiggly bracket, right before the closing square bracket, type out a comma, and then type after that on the next line, a squiggly bracket. Press enter to get the closing squiggly bracket automatically generated. And then in here, let's type out in quotes effect, colon, and then in quotes allow, and then comma, in quotes action, and then colon, in quotes GameLift, colon, describe game sessions, and then comma, and then in quotes resource, colon, and then in quotes star. The next statement object that we will add will grant the function permission to call DynamoDB getItem and putItem on the match results table. So make sure you have the DynamoDB dashboard open up in a separate tab. But on the next line, let's type out a comma, and then on the next line after that, type out a pair of squiggly brackets, and then in quotes, let's type out effect, colon, in quotes allow, and then comma, and then in quotes action, colon, and then this time we're actually going to type out a pair of square brackets here, and then inside these square brackets we're going to type out in quotes DynamoDB DynamoDB colon getItem, all of that in quotes, and then comma, in quotes DynamoDB colon putItem, and then add a comma after this closing square bracket, and then in quotes type out resource, and then colon, in quotes, let's go to the DynamoDB dashboard, specifically the tables page, and from here select the match results table, and then in this overview tab here, scroll to the very bottom, and by where it says Amazon resource name, just copy the value to the right of where it says that, and then go back to the IAM management console page where you were editing the policy and just paste that value in the quotes there. And the third and final statement object that we will be adding will grant the Lambda function permission to call DynamoDB batch getItem and batch writeItem on the players table. So type out after this closing squiggly bracket a comma, and then on the next line type out a pair of squiggly brackets, and in there type out in quotes effect, colon, in quotes allow, and then comma, in quotes action, colon, and then in square brackets, and in quotes, in square brackets, and in quotes DynamoDB colon batch getItem, and then comma, in quotes DynamoDB colon batch writeItem. And then after the closing square bracket, type out a comma, and then in quotes resource, colon, in quotes, go back to the DynamoDB dashboard, and this time go to the players table, and then same thing we did as before, go down in the overview section to where it says Amazon resource name, and just copy the value to the right of where it says that, and then go back to this IAM management console page where you're editing the policy and just paste that ARN value inside the quotes. And then once you've done all of that, click on review policy, click on save changes, and let's go back to the Lambda function. Now remember that all of the Lambda function code along with test events for each function from this tutorial series is in a GitHub repository that is linked in the description below. But let's look at the test events for the record match result function, specifically the first test event here, which is called aliens1 event.text. And then let's just copy the text inside of here. Go back to Lambda and let's make a test event by clicking on this drop down that says select a test event, click on configure test events, make sure you have create new test event selected, and then for the event name, let's name it aliens1 event, and then inside this text box here, just get rid of everything inside and then just paste in that text that you copied from earlier. Now, as you can see, this test event relies on a valid game session ID. It doesn't have to be the ID of an active game session, just a game session. So let's go to the GameLift dashboard, and hopefully you didn't terminate your fleet. Otherwise, to test this Lambda function, you will have to spin up a new fleet and get your clients to make a match so that another game session gets created. From here, click on your fleet under where it says fleets, And then from here, click on the Game Sessions tab. And then you should see a list of game sessions show up. And then from here, click on under the ID column, just click on this ID hyperlink here. So this whole piece of text here after game session colon, not including that space, is the game session ID. So it's going to be a little long, so copy all of that, go back to Lambda, and then where it says insert valid game session ID here, just get rid of all of that, and then paste that value that you just copied inside of there, and then click on create to finish creating your test event, and then click on the test event to run that test event on this function. So let's now expand the details under where it says execution results succeeded, and we see a positive response with a with a message of match result has been recorded, which is good. But let's go to DynamoDB and check the players and match results table. So right now I'm currently selected on the players table. Click on the items tab here, and you should see 2 items here, because, or at least in my case, I only have 2 player items because I've only signed up 2 player accounts. But if you do have more player items, that's okay. The main thing here is after running that Lambda function, you should see 1 player item with 1 win and 0 losses, and another player item with 1 loss and 0 wins. And if we go to the match results table here, and we look at the items here, you'll notice that we now have a new entry. We have an entry with a game session ID as the item's ID. And then if I actually click on this here, if I click on the ID value, you'll see everything a little more spaced out better. So we have the ID, the losing team, and the winning team. So the losing team, if we expand that, and also if we expand the winning team, they both of these attributes have the same structure. They have the name of the team as well as an array containing all the players that were a part of that team. So in this case, the losing team was the Cowboys. That makes sense because in that test event, we specifically designated the aliens as the winning team. And as I expand both of these players arrays, you'll see that the structure is very similar because each item in this player array on both the losing team and winning team contain a ID attribute as well as a skill attribute. So if you just kind of quickly try to remember the ID of the player on the losing team as well as the ID of the player on the winning team, click on cancel here, go back to the players table, look at those items, just make sure everything checks out, that the player on the losing team as well as the player on the winning team reflects accordingly in both that item in the match results table as well as in the items in the players table. And in this case, that does look to be the case. Now, if we go back to Lambda and try to test this same event by clicking on the test button again, we'll get an error response because we wrote this Lambda function to prevent double posting. So once a match result is recorded, it's final. So if we went back to DynamoDB and we refresh the items in the players table, you'll notice that there's no changes. If you go to the match results table and refresh the items in this table, you'll notice that nothing has changed here as well. It's still the exact same item as it was before. But just for testing purposes, to make sure that the function works when the Cowboys team wins, because that last test event we did test when the aliens team has won, let's cancel out of here, and let's actually, since we have this item selected right now, let's actually delete it by going to actions and click on delete, and then click on delete again. And then let's go back to Lambda and let's actually make a new test event for when the Cowboys win. So click on this drop down menu, click on configure test events, and make sure that you have create new test event selected, as well as for the event template field, make sure you have the aliens 1 event template, so that for this new event we're currently using the same exact test event text as we were before for that aliens 1 event. So for the event name, let's call this Cowboys 1 event, and then go to the right side here, and then at the very end where it says winning team, to the right of it you'll have a colon, and to the right of the colon you'll have where it says aliens. Just replace where it says aliens with Cowboys, and then click on create here, and then click on test to test this new test event. The response looks good. The body says success, match result has been recorded. Let's go back to DynamoDB to make sure that everything looks good there. In the match results table, let's refresh the items in here. You'll see that there's a new item in here. So if we click on the ID of this new item, and then we expand the losing team as well as the winning team attributes, you'll notice that now the winning team is the Cowboys, which makes sense because in that test event we specified the Cowboys as the winning team, which means by default the aliens is the losing team. And then as you can see, I don't know if you noticed, but the players have kind of flip-flopped. Now this player that was on the losing team before is now on the winning team, and vice versa for the other players. So let's get out of here, and if everything was done correctly, when we go back to the players table, you should see that both players that were involved in the match are now 1-1, meaning they each have 1 loss and 1 win because we ran 2 test events on them. Basically, we had one event where the Cowboys won and another event where the aliens won, and the teams never really changed, you know, so one player was always on the Cowboys, and then the other player was always on the aliens, so everything seems to check out here. Now we actually have to create one more Lambda function. Since the record match result function will be added to a public API, we should add an extra authorization check to help the API verify that the entity calling this Lambda function is indeed the server. Now this will be a very basic way to do this that I don't necessarily recommend that this is the only authorization check you add for API methods meant to only be invoked by the server. I won't go over other ways to do this, but those ways include Amazon Virtual Private Cloud Networking. So for those who are interested, I will have links to articles that talk about that in the description below. For now, let's go back to Lambda, specifically the functions. And then from here, let's go ahead and create a new function. And like I just mentioned, this Lambda function will be used for checking if a request has a certain value for its authorization header to confirm that the request is coming from the server. Basically, this will be the function used in what is called an API Gateway Lambda authorizer. So let's go ahead and call this function verify server identity, and then click on create function. And we won't need a layer for this function, so let's scroll straight down, click inside this window editor, and press Ctrl+ a few times to zoom in. So like I mentioned earlier, the way that we are going to be checking if the server is making requests is by checking if the authorization header is a certain value. For those who are wondering, yes, this is not the strongest way to secure an API only meant for a server. However, consider the fact that if someone wanted to mess with your DynamoDB data through this record match result endpoint, that person would not only have to guess what we will call the server authentication code correctly, but also that person would need a valid game session ID to actually be able to use the record match result API endpoint, which is pretty hard to get. So my advice would be, again, look at the articles in the description below about more advanced concepts like virtual private cloud and private APIs, and always try to make it harder for potential hackers by providing as many obstacles for them as possible. So the first thing we are going to do is get rid of the code already inside of this function and modify the parameters passed into this function. So because this will be a Lambda authorizer function, we will have to add after the event parameter, comma, context, comma, callback. The context parameter isn't really that important in our use case, but the callback parameter will be used instead of returning a response like we usually do in our other Lambda functions. And because this will be a Lambda authorizer function, the authorization header value will be stored in a property called authorization token in the event object passed into this function. So let's retrieve that value and store it in a variable by typing const auth code, and we'll set that equal to event.authorization token. Now for this tutorial, we are going to check if this authorization token is equal to the word dummy. Feel free to make this server code value whatever you want to. Just keep in mind that anywhere else I use the word dummy, you would have to replace that with your custom value. So I'm going to type if in parentheses auth code double equals in quotes dummy, and then a pair of squiggly brackets. And this to us essentially means that we're going to authorize this incoming request because it checked our authorization code check. And we are going to allow this request to invoke the API method, which in turn will invoke the Lambda function authorized by the Lambda authorizer. So to give this request permission, we have to make a policy JSON document, similar to the ones that we have been editing for our Lambda functions throughout this tutorial. So type out const policy equal in squiggly brackets version colon and then in quotes 2012-10-07 and then comma statement colon square brackets and then a semicolon at the end. And then as you can see, the statement property of this policy is currently an empty array, but we have to add an object to that statement array, and that object will grant the identity calling this API method access to invoke this API method. So type out const statement 1 and set it equal to in squiggly brackets action colon and then in quotes execute dash API colon invoke and then comma effect colon in quotes allow and then comma resource colon event dot method ARM and then add a semicolon at the end. And then let's add the statement object to the array by typing policy dot statement dot push and then in parentheses statement 1. Now let's make an object that will pass to the callback function. So type out const response and set that equal to in squiggly brackets principal ID colon in quotes user and then comma policy document colon policy and then we'll add a semicolon here at the end. And let's grant access to the API request by typing callback in parentheses null comma response. Now in the case where the request fails the identity check, meaning that the authorization header value passed was not equal to dummy, then let's use the callback function to send back an error message. So type out else and then in squiggly brackets callback and then in parentheses and in quotes unauthorized and a semicolon. Once you're done, go ahead and save your changes. Remember that this Lambda code will be in a GitHub repository linked in the description below. Unlike the past Lambda functions that we wrote, we will not be testing this function in the Lambda console using test events because I think that testing with Postman should be good enough. So let's go back to the API Gateway dashboard, specifically in the API that we have been using throughout the entire tutorial series, and on the left hand side, click on where it says authorizers. And before we add a Lambda authorizer, just to avoid confusion between multiple authorizers, I want to rename the authorizer that we have already been using throughout the tutorial series to verify the identity of clients calling the API. So click on the edit button for the GameLift tutorial authorizer. And let's rename this to GameLift Tutorial Cognito Authorizer. And then click on the save button to save your changes. Again, this is because when we make a Lambda authorizer, I want to be able to differentiate between the Cognito authorizer and the new Lambda authorizer. So once you have done that, let's refresh the page because this UI is not reflective or reactive. So you won't see this name page if you don't refresh. Now let's make the Lambda authorizer, so click on the button that says create new authorizer, and then for the name, let's call this GameLift Tutorial Lambda Authorizer. And then for the type, for me, Lambda is selected by default. If it's not selected for you, by default, just make sure that the checkbox by where it says Lambda is selected. And then for the Lambda function, just type out the name or select from the drop-down menu the name of the function that we just wrote. So in our case, it's verify server identity. And then I'm going to select that. Lambda invoke role, we can keep that field blank. For the Lambda event payload, make sure that you have token selected. For me, it's selected by default. And then for the token source, because we want to examine the authorization request header, let's type out authorization for the token source. And then for the authorization caching settings, I'm just going to leave it at its default settings. Once you've done all that, go ahead and click on create. And then API Gateway is going to ask you for permission to invoke your Lambda function. Just go ahead and click on Grant and Create. And again, this UI is not reactive, so refresh the page again if you want to be able to see this new Lambda authorizer and other parts of the API dashboard, API Gateway dashboard. Now let's go ahead and add a new resource and method to this API for the record match result Lambda function. So go to where it says resources, make sure the root topmost directory is selected, click on actions, and then click on create resource. And then for the resource name, let's just name this after the Lambda function, record match result. Click on create resource, and then making sure that the newly made record match result resource is selected. Go back to actions, and this time select on create method. And then click on this drop down menu and select post, since requests to this API method should contain information in the request body. And then click on the check mark. And then that'll take you to this page. Make sure the integration type, you have Lambda function selected, and then make sure that the checkbox by where it says use Lambda proxy integration is selected. For the Lambda region, make sure that you have the code of the region that you are operating selected. And then for the Lambda function, just go ahead and start typing the name of the Lambda function. In our case, it's record match result. And then click on save, and then click on OK. And since we only want the server to call this method, let's add a Lambda authorizer to this method in order to control who has access to this resource. So click on where it says method request, and then by where it says authorization to right of where it says none, click on this pencil icon, and then you should see a drop down menu appear. Click on this drop down menu, and from here underneath where it says token authorizer, select GameLiftTutorial Lambda authorizer, and then click on the checkmark button. And for those who are wondering, do we have to go back to all of those old API methods and re-add the Cognito authorizer because we renamed that authorizer? The answer is no. So I can show you, for example, if we go back to the post method underneath the poll matchmaking resource, click on method request. Actually, you don't have to even click on method request. You can see that the authorization from this box labeled method request, that the authorization is the authorization is set to the GameLiftTutorial Cognito authorizer. So like all the other methods with the Cognito authorizer, it's still there, just the name changed. Also, just an important fact about API Gateway authorizers: if a request fails the authorization check, whether it is through a Cognito or Lambda authorizer, then that request to API Gateway does not count in terms of pricing. So not only do you save money on preventing the Lambda function from getting invoked, but also the API method invocation doesn't get charged. However, keep in mind that if you have a Lambda authorizer, then you will still be charged for the Lambda function that was invoked for the authorizer, even in the case that the request fails the authorization check. Now, for those wondering, why don't we add an authorizer to all the API methods? Because we do have two API methods that don't have an authorizer. So anyone with the endpoint can invoke them. So for the first one that doesn't have an authorizer, that is the get sign-in result method used for the callback URL for our Cognito hosted UI and our Cognito user pool. This Cognito hosted UI is already public, so I didn't see a point in making a custom authorizer for that method. The second method that doesn't have an authorizer is the exchange code for tokens method. This one is a little tricky because you can't really use a Cognito authorizer for this method since clients don't have a token yet, hence why they are calling this API method. So then the question becomes, could we make a custom Lambda authorizer for this? According to the AWS documentation, Lambda authorizers are used either to authenticate a third-party bearer token or use request parameters to check the caller's identity. And neither of those scenarios apply in this situation because, again, the caller won't have a token at this point. They'll have a code that can be exchanged for a token, and since any client can retrieve a code, there isn't really a set of request parameters that can uniquely identify the group of possible clients who can call this API endpoint. With that said, let's go ahead and deploy this API with the new updates. So click on, make sure the root directory is selected again in the resources, or I guess the root resources selected. Click on actions and click on deploy API. For the deployment stage, click on the drop down menu, select test or whatever stage you've been using, and then click on deploy. Now expand the stage that you deployed to underneath where it says stages. For me it's called test, so click on that to expand the stage, and click on the post method underneath the record match result resource, and then copy the value by where it says invoke URL. We will need that for later. Now open up Postman. So I'm just going to go ahead and open it up. And once Postman opens, we are going to make a new request to test out this newly made record match result API method. So click on the plus new button, select request, and then for the request name, I'm just going to name it after the Lambda function, so record match result. And then just use the collection that we've been using throughout this tutorial, and then click on save to GameLift tutorial collection. And then for the request URL, just go ahead and paste in that URL that you copied from earlier in API gateway. And this isn't a get request, so click on this get value. Well, you'll get this drop down menu and select post, because this is going to be a post request. And I am really sorry guys, but I just realized I made a typo in the Lambda authorizer function code. So let's go back to AWS Lambda, specifically the verify server identity function. And the typo occurred on line 6. So in the version property of this policy object, the version property is equal to a string value of 2012-10-07. The typo is that instead of 07 here at the end of the string, it should be 17. So the version property of the policy object here should have a value of 2012-10-17, all in quotes. So once you made that change, that correction, click on the save button to save your changes. Go back to Postman, and now let's actually test this endpoint. So we're going to just add an authorization header to make sure that 1, the Lambda authorizer is working, and that 2, the API method points to the record match result Lambda function. So go to the headers tab, and at the bottom of this table, in this blank row here, for the key, let's type in authorization, and then for the value, first, let's test that the authorizer is working. So don't pass in the value that the authorizer is expecting. So in our case, do not type dummy. Type in just any word. So I'm going to type in random. I'm going to click send, and you should see message unauthorized, because in this case, this request failed the authorization check because the authorization header in this request was not the expected value of dummy in our case. But if I do replace the word random with dummy and then click send, you'll get a response that kind of tells you that the record match result Lambda function was indeed invoked, because this custom error message here, incoming request did not have a valid winning team, in our case only belongs to our record match result function. So that's all we need to do in terms of testing in Postman, because again, we're just testing if the record match result function is tied to this API endpoint, and it clearly does. And finally, just press Ctrl S to save the request in Postman, and now we can go back to our Unreal Engine project and modify that. So let's go to File Explorer, where our projects directory is located, and double click the Unreal Engine project file to open up our project in the Unreal Engine editor. And in the meantime, you can also open up your project's Visual Studio solution file and Visual Studio if you were like me and closed it since the last time we opened it. So let's first start with a couple of quick changes that I want to make in the Unreal Engine editor, specifically to the third person example map. Make sure you have it open. If not, go down to the content browser tab, find where the map is located. For example, for me, it's in the maps folder in the third person CPP folder. And once you have found the UMap file, just double click it to open it up. Again, in the case where you don't already have it open. And once you have it open up, as we saw in the last tutorial, we don't need this default pawn here on the bottom right. At least in my case, the default pawn is currently located on the bottom right of the play editor window. And this default pawn that comes with newly made projects, the character that's already in the map, it's just an extra idle pawn that the clients will never possess in our case, so it will never move and it will always stay in the same place throughout the lifespan of a server process. So go ahead and select it by clicking on it in the play window and press delete. And the next change that I want to do with regards to the map is that if you notice in the last part of the tutorial, the players currently spawn in the same spot. That is because we only have one player start object in this map. Now, since we have about 4 players in the game, I don't necessarily want them to spawn in the same spot, only because in Unreal Engine, occasionally what can happen is that when an object is trying to spawn in a specific spot on the map, the object may fail to spawn if there is a collision issue. This does not happen that often, but it definitely can happen if 4 pawns are trying to spawn in the same spot. So let's just add a few more spawn points by going to the World Outliner tab on the top right of the editor. Select the object of type player start and labeled network player start. And then press Ctrl C to copy it, and then press Ctrl V to paste it 3 times. Now we have 4 spawn points, but of course they are currently all in the same location, so let's scroll out of this player editor viewport to zoom out of the map. See these 3 arrows on the player start object. They represent the location of the object in 3 directions, X, Y, and Z. These arrows actually correspond with these red, green, and blue arrows on the bottom left of this viewport window. So what we're going to do, and feel free to play around with this, is I'm going to just drag these arrows left and right, up and down to move the player start object to a different spot on the map. And then once you're done with that one, select another player start object in the World Outliner section and do the exact same thing. Use the arrows to kind of change the location of this player start object. Feel free to even zoom in if you're unclear of where these objects are located currently. And of course, feel free to right click using your mouse as well. And of course, you can move around this map viewport window by actually double clicking your mouse and just dragging it. So right now I'm selecting both the left and right mouse keys. Use the scroll bar on your mouse to zoom in and out. And of course, if you only hold the right mouse key on your mouse, or if you hold the right key on your mouse only and drag around your mouse, and you kind of change the orientation of your view of the map. So this one I think is good. And then let's go to the last one and do the exact same thing. Let's just take these arrows and just move them around. And that should be about good. Let's save our changes to this map by going to File, Save All. And now you may notice that some of your player start objects are labeled with bad size. That usually means that the player start capsule is too far below the ground, so just grab the blue Z arrow for those player start objects and drag it up just a little bit so that the bad size indicator goes away. And let me do it for the other one as well. I believe for me it was my network player start number 4. So again, I'm just going to take the blue 0 here, just drag it up a little bit so that that bad size indicator goes away. It usually only goes away when you let go of the arrow. So if I go back to network player start 2, I believe, I think this one I maybe see. So when I let go of it, I'm just trying to show you guys that the bad size indicator will only appear or disappear when you let go of any of these arrows of the player start object. So I'm just going to raise it back up again so that it's gone. I'm going to go to File and then click on Save All. And then let's just test our new spawn points by playing the game in the editor, but this time let's launch the game in dedicated server mode with 4 clients. So to do that, click on this triangle button to the right of the play button. By where it says number of players, underneath where it says multiplayer options, let's increase this number from 1 to 4, and then click on the checkbox underneath that by where it says run dedicated server to enable that option. Because if you don't leave that option enabled, then the default is a listen server, but we're trying to emulate GameLift as much as possible, which hosts dedicated servers. So click out of that and then click the play button, and you'll notice right away that multiple preview client windows open up outside the editor, but we're just going to stay for now in the main editor viewport. So as you can see, players are now spawning to different spots. Now, as you can see, there's still a likelihood that there will be multiple players spawning in one spawn point. Now, if I press escape and click play again, you'll notice that it's a little different sometimes, so it's kind of hard to see, but now those 2 players that spawn behind this spawn in the spawn point way further back. So as you can see, I press escape to stop playing the game, the players spawn to one of the 4 player start objects at random. It's not deterministic. So if I play the game again for a 3rd time, you'll notice now at this spawn point there's only 1 player. And if I look behind me, to the right you have 2 players spawn there, and to the left you only have 1 player spawn there. So if we press escape again, I just want to say that if we wanted to prevent spawn collisions in general, you could do one of 2 things. You could either write extra logic, or you could just simply reduce the chances of multiple players spawning in the same spot by adding more spawn points. And I think that's actually what I want to do in this case, just to keep this tutorial simple, since I don't really want to write some logic right now. So let's select one of the network player start objects in the world outliner section. Press Ctrl C to copy it, and I'm going to press Ctrl V actually 4 more times to paste 4 more player start objects. Now double click on one of these new player start objects in the world outliner section to focus on it in the main main editor viewport, so that we can easily find it, and use the red, green and blue arrows, as well as both mouse keys, right mouse key only, as well as the scroll bar on your mouse to help you navigate this main editor viewport. So I'm just going to move this, as well as all the player start objects, to kind of a random spot on the map. And then once again, I'm going to double click on one of the other new ones, and I'm going to move that one as well, again to a completely random spot on the map. And of course, don't forget the bad size marker just indicates that that player start object is just a little too far below the ground. So that is okay. So I'm going to move that as well. Again, feel free to once again use the keys on your mouse, scroll bar, both mouse keys, and of course right mouse key only, to help you navigate this editor window. And then the last one, the last player start object, and do the exact same thing, nothing much different. So this one I think I'm going to put kind of on the right corner of the map here. Gotta raise it up a little bit to get rid of the bad size indicator marker. And again, I'm just going to move it there, and that should be good. Don't forget to save your changes by going to File, Save All. Note that the keyboard shortcut for this is Ctrl-Shift-S. I'll probably just start using that keyboard shortcut instead from now on. And then let's go ahead and click on the play button. Now if I look behind me, I'll see, so it looks like every single player actually spawned in their own spawn point. Now again, we didn't write any logic to kind of ensure this from happening. So there is still a chance that you will have multiple players at one spawn point. So if I press escape, press play again. So in this case, it didn't happen either, right? Because again, like I said earlier, the more spawn points, the more likely it is that each player will spawn to their own spawn point. And feel free to just keep doing this, play around. You know, so again, like in this case, we have 2 players at the same spawn point. That's generally okay, I think. I don't think I've had a spawn collision issue when there's only 2 players at one spawn point. It's really only when there's usually like 3 or 4. But again, for this tutorial, I want to keep it simple and shorter by not having to write that extra logic. If you guys want to write extra logic to prevent players from spawning in the same spot, feel free to do so, but we won't be doing that in this tutorial. We're just going to be complacent with multiple spawn points to try to reduce our chances of that happening as much as possible. Actually, let me quickly move this one player start object a little forward. And let me just press Ctrl Shift S to save the changes again. Now what I want to do is actually create some new C++ classes, because before we get back into writing code directly related to GameLift functionalities such as accepting player sessions and terminating game sessions, I want to slightly modify what the client sees when they join the server, as well as how the server progresses once a game session starts. So let's start with a new HUD class. I'm going to click on the Add New button here on the bottom left. I'm going to select New C++ class, and then if I scroll down to the HUD option, I'm going to click on Next, and then I'm going to name this GameLift Tutorial HUD, and then I'm going to click on Create Class. And this HUD will need a widget, so let's go ahead and create a new widget class as well by going to Add New and then New C++ class, and this time click on Show All Classes. And then from here you'll see a search bar appear. In that search bar, just type in user widget and then select the user widget option, click on Next, and then we'll name this class GameLift Tutorial Widget, and then click on Create Class. Next, we will need a way to keep track of game-related events in the server. So for example, how much time is left in the game, when is the game over, which team won the game, and have that event information be shared with the client. So let's make a game state class. So click on Add New again, select New C++ class, scroll down to the game state based option, select that, click on Next, and then for the name, let's call this GameLift Tutorial Game State, and then click on Create Class. Lastly, we need to keep track of information related to each client connected to the server, such as their player session ID, player ID, and which team they belong on. So let's make a player state class by clicking on Add New once again, select New C++ class, scroll down to the option labeled Player State, click on Next, and call this class GameLift Tutorial Player State, and then click on Create Class. Okay, so now that we have made all the new C++ classes that we need, let's create a new widget blueprint for our new widget and HUD classes that we just made. This widget blueprint will be responsible for displaying some text blocks containing information such as which team the client belongs to, how many clients currently are connected to the server that belong on that same team, and the client's ping. So let's go to our projects UI folder in the content browser, and then the widgets folder, and then inside here just right click anywhere and select user interface under where it says at the bottom of create advanced ad set, and select on widget blueprint, and let's call this widget blueprint UI_game. And then let's double click this new widget blueprint to open it up in the editor. And all that we are going to do here is add some text block widgets. But before we do that, let's quickly set the parent of this widget blueprint to the new widget C++ class that we just made. To do that, go to File, Reparent Blueprint, and then in here just type in the name of that widget class that we just made. So in our case, it was called GameLift Tutorial Widget, and then just select it from the drop down menu search results. Now let's go ahead and add those text block widgets. So click and hold on the widget labeled text under the comment section in this palette window on the left and drag it onto the main viewport, specifically inside the canvas panel that's outlined by these dotted lines, and then just let go of your mouse. Then go to the details window on the right side here for this newly added text block widget, and this widget will be responsible for displaying the team name. So let's rename this widget in the text box right under where it says details to text block underscore team name. And then let's anchor this widget to the top left corner of the canvas panel by clicking on the drop down menu labeled anchors under the slot section, and then hold both the Control and Shift keys and select this top left option that looks to have a little gray square on the top left corner of a larger square. And then let's slightly adjust the positioning of this widget so that it's not scrunched up tightly in the corner. So let's change the value to the right of where it says position X to +20 to shift the widget to the right a little bit. And let's change the value to the right of where it says position Y to +20 as well to shift the widget a little down. And after that, let's adjust the size of the widget. So let's set the value to the right of where it says size X to 470 to make the widget wider. And let's set the value to the right of where it says size Y to 55 to make the widget a little taller. And for the default text value, we can modify this in the text box to the right of where it says text under the content section. So replace the default text block text with team space name : and let's also make the text font size bigger by going to the text box to the right of where it says size under where it says font in the appearance section and changing the number 24 to 36. Now let's make a new text block widget for displaying how many people in the server currently belong to the same team. So let's go back to the comment section in the palette window and drag and drop another text block widget onto the canvas panel. And let's go ahead and name this widget text block underscore teammate count. And for the anchors, let's anchor this widget to the top right corner of the canvas panel. So let's select the drop down menu labeled anchors, and while holding Control and the Shift keys, select the option that looks like it has a small gray square in the top right corner of a larger square. And as for the positioning of this widget, let's set position X to -20 to shift the widget a little bit to the left, and let's set position Y to +20 to shift the widget a little downwards. As for the sizing of this widget, let's set size X to 420 to make the widget wider, and let's set size Y to 55 to make the widget a little taller. As for the default text, let's make it teammate space count : and for the text size, let's make that 36, and then scroll down this appearance section inside the details window to where it says justification and choose the rightmost option for this field so that the text gets aligned to the right side of the text block widget. Now let's add a text block widget for displaying information related to the game state. So in our case, for instance, how much time is left in the game and which team won the game. So let's drag and drop another text block widget from the palette window into the canvas panel, and let's name this widget text block underscore event. Then let's anchor this widget to the top middle portion of the canvas panel. So scroll back up in this details window and click on where it says anchors. And then while holding the Control and Shift keys, select that option that looks like it has a small gray square in the top middle row of a larger square. And then as for the positioning of this widget, keep position X at 0, but let's set position Y to 150 to shift the widget downwards. As for the sizing of this widget, let's set size X to 1500 to make it wider, and let's set size Y to 55 to make it a little taller. As for the default text, let's just get rid of everything that's there and leave it empty for now. And then let's change the text size to 36. And as for the justification, choose the middle option so that the text is centered inside the widget. And lastly, let's add one more text block widget. So drag and drop another text block widget from the palette window onto the canvas panel. This widget will be for displaying the client's network latency, so name this widget text block underscore ping. And then this will let's anchor this widget to the bottom left corner of the canvas panel. So scroll up, click on where it says anchors, and while holding the shift and control keys, select this option that looks like it has a small gray square in the bottom left corner of a larger square. As for the positioning, set position X to +20 to shift the widget a little to the right, and set position Y to -20 to shift the widget a little upwards. And as for the sizing, set size X to 200 to make the widget a little wider, and keep the default size Y value of 40. Lastly, for the default text value, set it to ping colon. Then let's save all of our changes by pressing Ctrl-Shift-S. And don't forget to compile this widget blueprint by clicking the compile button on the top left corner of this window. Now that the widget blueprint is completed, let's go to our project in Visual Studio so that we can start modifying the HUD class to include this custom widget. So in the Solution Explorer on the right, find the GameLiftTutorial HUD header file and open it up. And the first thing we're going to do is add a for declaration at the top of this file for the user class. So type up here class user-widget. Next, we are going to define a public constructor. So in the class definition, under where it says generated body, type out public colon, and then underneath that a GameLiftTutorial HUD parentheses. And now let's override the begin play function, because that is where we are going to be creating an instance of a GameLiftTutorial widget and adding it to the viewport. So type out protected colon virtual void begin play parentheses override. And lastly, let's make a property for the specific user-widget class that will be used to instantiate this widget instance. So type out private colon uProperty parentheses and then t subclass of and carets user-widget, and we'll call this property GameWidget class. Now let's go to the GameLiftTutorial HUD C++ class so that we can implement the constructor as well as the begin play function. So find the GameLiftTutorial HUD C++ class in the Solution Explorer, open it up, and starting with the constructor, let's type out a GameLiftTutorial HUD double colon a GameLiftTutorial HUD parentheses and a pair of squiggly brackets. And then here we're going to retrieve the widget blueprint. So to do that, type out static constructor helpers double colon f class finder, and then in carets user widget, and then we're going to call this variable game obj, and then in parentheses pass in a text object, and then in parentheses that text object will take in quotes the relative game path to the widget blueprint. So in our case, it's going to be /game/UI/widgets/ the name of the widget, which in this case is UI_game. And then on the next line with the widget blueprint, now we can extract its parent class and store it in our GameWidget class member variable to be used later in the begin play function. So type out GameWidget class and set that equal to GameObj.class. And I just realized I forgot to add an include statement to the top of this class for the user-widget header file. So let's type up here #include in quotes blueprint/user-widget.h. Now let's override the begin play function by typing void a GameLiftTutorial HUD double colon begin play, and then parentheses and then squiggly brackets. The first thing we are going to do inside this overridden begin play function is called the AHUD superclasses begin play function, the original begin play function. So type out super begin play parentheses. And unlike the main menu HUD class, we will not want the mouse cursor to be shown in the server map, nor do we want any focus to be put onto the widget inside of this GameLift tutorial HUD. So let's grab the player controller by typing a player controller star player controller equal get world parentheses arrow get first player controller parentheses. And then let's do a quick null check on it by typing if in parentheses player controller not equal null pointer and squiggly brackets. And if it's not null, then let's not show the mouse cursor by typing player controller arrow b show mouse cursor equal false. Also, I just realized I made a typo on line 16. Player controller should be spelled with 2 L's. Lastly, let's create an instance of the widget blueprint, but first let's make sure that the GameWidget class member variable is not null by typing if and then in parentheses GameWidget class not equal null pointer and then squiggly brackets. If it's not null, then let's use the create widget function to create an instance of the widget blueprint by typing user widget star game widget and set that equal to create widget, and then in carets user widget, and then in parentheses this function will take in 2 parameters. The first one will be get world parentheses, and the second parameter will be the game widget class member variable. And then let's just do a quick null check on the widget by typing if in parentheses game widget not equal null ptr squiggly brackets, and if the newly made widget is not null, then let's only add it to the viewport, don't set focus on it. So type out game widget arrow add to viewport parentheses. And once you're done with that, make sure that you have development editor selected for your solution configuration, Win64 selected for your solution platform. Right click your project in the Solution Explorer and select Build to compile your project. However, I just realized I forgot that we still have to set the HUD class member variable in the GameLift Tutorial Game Mode class to our newly made GameLift Tutorial HUD class for the newly made widget to appear on the screens of clients that connect to the third-person example map on the server. So let's go to the GameLift Tutorial Game Mode C++ class, and let's scroll up to the top and let's add another include statement for the GameLift Tutorial HUD header file. So type out hashtag include and then in quotes GameLift Tutorial HUD.h. And then in the constructor, specifically in this if statement, let's set the game mode's HUD class property to our newly made HUD class. So type out HUD class equal a GameLift tutorial HUD static class parentheses, and then go ahead and build your project in Visual Studio once again. After your project has finished compiling, let's go back to the Unreal Engine editor and play the game to make sure that the newly made widget blueprint is displayed in the viewport of the clients connected to the server map. And as we can see, the text blocks that we added to the widget with the default text values, team name, teammate count, and ping are there. So the HUD class was indeed added to the third-person example maps game mode. Don't worry about the lack of values in these text blocks. For example, the actual team name, the actual teammate count, and the actual ping value, we will set those values in code later in this part of the tutorial. So go ahead and stop playing the game by pressing the escape key. Now, before we populate these text values in that widget, let's quickly implement a couple of classes that we just made that won't require much code at all, but other classes will end up using those classes. The classes I'm talking about include the new player state and game state classes. So let's go back to Visual Studio, and I'm going to open the GameLift Tutorial player state header file. Now, for those who are not familiar with the player state class, each player connected to the server will have a player state instance. This player state instance is exactly what it sounds like. It will keep track of the state of a participant in a game. So in a multiplayer game, this is where you would store network-related information such as a player's display name, a player's score, maybe a player's character, whether the player is holding a specific object, and etc. Of course, you can choose which specific pieces of information to replicate to the clients. In our case, we are going to store GameLift related information here, such as the player ID and player session ID, which will not be replicated, so only the server will know that information. But since we want to display the client's team name on the widget in their HUD, we will also store in this player state class the team that the player belongs to, and replicate that property. With that said, let's type in the class definition under where it says generate underscore body, public, colon, and then uProperty, parentheses, f-string player session ID, and then underneath that, uProperty, parentheses, f-string matchmaking player ID. Now the reason why we're calling this variable matchmaking player ID instead of just player ID is because the player state class in Unreal Engine already has a variable called player ID, so we can't redefine it. And then the last variable that we're going to make in this class is first type out uProperty, but this time in parentheses pass in replicated. And this variable will also be of type f-string, but it will be called team. Just to quickly recap what each variable is meant for, the player session ID is generated by GameLift and is a unique value for tracking a player session resulting from a successful matchmaking request. We need to keep track of this information somewhere so that when a player connects to the server can activate the player session, and when a player disconnects from the server can terminate the player session. The matchmaking player ID variable is for easily traversing the matchmaker data given to us by GameLift, because in that matchmaker data, like we saw much earlier in this tutorial, player information such as team and skill attributes are tied to the player ID value used in the matchmaking request, not the player session ID. And finally, the team variable is going to be displayed and used in the GameLiftTutorial widget class on the client side, and we want to replicate this team variable, so in addition to passing the word replicated to the uProperty macro, we have to go to the GameLiftTutorial player state C++ class and do a couple things. First is we have to add an include statement, so under the first include statement type out hashtag include, and then in parentheses, in quotes, net/unrealnetwork.h. And the reason we have to include this Unreal Network header file is that whenever you want to replicate custom properties in a class derived from the aActor class, you need to override the getLifetimeReplicated method, because this is the method that returns all the properties used for network replication. So in addition to what normally gets replicated, you would include what you want to get replicated. So override this method by typing void a GameLiftTutorial player state get lifetime replicated props, and then in parentheses this method takes in one parameter of type t-array and carets f lifetime property. Also, I made a typo here, it should be t-array with a capital A, and then after that type an ampersand, and then this parameter is called out lifetime props, and type out the word const at the end, and then on the next line type out a pair of squiggly brackets. And the first thing we're going to do here is call the superclasses version of this method by typing super get lifetime replicated props, and then in parentheses just passing out lifetime props. And then let's add our team property to the list of network replicated properties by typing do rep lifetime in all caps, and then pass in two parameters to this. First is going to be the GameLiftTutorial player state class, and then the second parameter will be our team property. And just very quickly, I know some of you guys may be confused as to why we're doing this and what replication exactly is. We have a video where we briefly introduce replication in Unreal Engine, so we will have a link to that in the description below. But essentially, all the classes that we are coding that are prefixed with the word GameLiftTutorial are part of the server, so anything that is attached to the game mode class associated with the server map, which in this case is the third person example map. So when players join the game, an instance of a GameLift tutorial character will be created on both the server and the client. But with replication, the client doesn't notice that. It's as if there's only one instance of the character, the default Unreal Engine pawn. But when you use input to control and move the character pawn, you're actually sending information to the server, and the pawn gets moved on the server first, and then that information gets replicated to the client so that the pawn also gets moved on the client side in the exact same way it did on the server. Now, with this player state class, the client will have its own copy of the player state, but so will the server. And when you define custom properties in the player state, you decide which properties get replicated, meaning when its value changes on the server's copy of the player state, that value change gets reflected and applied onto the client's copy of the player state. Because only the server has access to the GameLift generated matchmaker data, the server ultimately sets the team property in a player's player state, and the only way that the client's version of the player state has that same team property is through replication. So I hope that made sense, because we are going to do something very similar in our game state class. So let's go to the GameLift tutorial game state header file, and first let's briefly go over what the game state class is used for. The game state is typically used for tracking rule related events that happen in the game and then sharing that information with all the players through replication, similarly to how we replicate the team information in the player state class. So rule-related events in our case would include how much time is left in the game, when the game ended, which team won, when the server process was interrupted, and etc. Many people get this confused with the game mode class, even though they are very different. The game mode class defines the actual rules in the game. For example, when clients connect to the server, deciding where do they spawn, deciding whether they spawn as a player or a spectator, deciding when and how the game ends, deciding who wins the game, and etc. Essentially, the game mode class contains the underlying logic behind the game and sets variables in the game state class that help convey the state of the game back to the clients. But in this game state header file, let's define a couple of replicated properties that we want to display and use in the GameLift tutorial widget class on the client side. So underneath where it says generate_body, type out public, colon, and then uProperty in parentheses replicated. And this first variable will be of type f-string and called latest event. So essentially this variable will contain the latest information with regards to the state of the game. So for example, if there's 30 seconds left in the game, or if the game just ended and a winning team was decided. The next variable will be used to store that winning team. So type out uProperty in parentheses replicated, and then underneath that f-string winning team. Now let's add these two properties to the list of network related properties by going to the GameLift tutorial game state C++ class, and first add an include statement for net/unreal network.h, and then override the get lifetime replicated props method by typing void a GameLift tutorial game state get lifetime replicate props, and then in parentheses type in t-array and carets f lifetime property ampersand out lifetime props const, and then squiggly brackets on the next line. First thing we're going to do is call the superclasses version of this method, so type super get lifetime replicated props, and then in parentheses pass in out lifetime props, and then let's add our two properties to be replicated by typing do rep lifetime in all caps, and then in parentheses pass in the a GameLift tutorial game state class, as well as the latest event property, and then do the exact same thing for the winning team property. So exact same thing, do rep lifetime in all caps, and then in parentheses pass in a GameLift tutorial game state, but this time the second parameter will be winning team. Now let's set the player state and game state classes in our GameLift tutorial game mode class to these custom ones that we just made. So go to the GameLift tutorial game mode C++ file. And first let's add some include statements here at the top of the file. So the first one we'll do hashtag include in quotes GameLift tutorial player state .h, and then the next include statement will be for the GameLift tutorial game state header file. So GameLift tutorial game state.h in quotes. And then in the constructor of the game mode class, specifically in the if statement, in order to actually set the game mode's player state class and game state class properties, type out player state class equal a GameLift tutorial player state static class parentheses, and then game state class equal a GameLift tutorial game state static class parentheses. And once you're done with that, let's build our project so that we can confirm in the editor that our game mode class is indeed using these new player state and game state classes. After the project finished compiling, go back to the Unreal Engine editor, and on the right side you should see a tab labeled World Settings, but if you don't, then you can go up here to where it says Settings, click on that, and select the option labeled World Settings. And then that tab should now appear. Within this World Settings window towards the top underneath the section labeled Game Mode, go ahead and expand where it says Selected Game Mode. And you should now see for the player state class, the GameLift tutorial player state class is the selected value, and for the game state class, you should see that the GameLift tutorial game state class is the selected value. Assuming, of course, if your game mode override or the current game mode selected is the GameLift tutorial game mode class. Now let's go back to Visual Studio because I want to start adding some actual game logic to our game mode class. So open up the GameLift tutorial game mode header file, and the reason is that I want to make sure that the player state and game state properties are being replicated properly. And there's a method, one of many in the game mode class, called initNewPlayer that gets called when a new player connects to the server, and this method contains the newly created player controller for that player. So you can override this initNewPlayer method to customize stuff about the incoming player, such as properties in their player controller and in their player state, using information from the options passed through the client call to open level, which, as we know from the last part of the tutorial, the options in this case contain the client's player session ID and player ID. So let's go ahead and override this method. So let's go down, and underneath the begin play method, type out virtual f-string init new player, and then in parentheses this method will take 4 parameters. The first one will be of type a player controller pointer and will be called new player controller. The next parameter will be of type const f unique net ID REPL ampersand, and it will be called unique ID. And then the third parameter will be of type const f string ampersand, and it will be called options. And then the last parameter will also be of const f string ampersand, but it will be called portal. And then at the end here, add the override keyword as well as a semicolon. Now let's go to the GameLift tutorial game mode C++ class and actually implement this method. So down here, let's type out f-string a GameLift tutorial game mode init new player, and then in parentheses pass in all those parameters from before, a player controller pointer, new player controller, comma const f unique net ID REPL ampersand unique ID, comma const f string ampersand options, and then finally comma const f string ampersand portal. And then at the end, let's add a pair of squiggly brackets. And the first thing that we're going to do is call the game mode superclasses initNewPlayer method. So type out f-string initialized string equal super double colon init new player, and then in parentheses just pass in those 4 parameters: new player controller, comma, unique ID, comma, options, comma, portal. And since this method returns a variable of type fstring, let's just return this initialized string variable. So type out return initialized string. Now, normally in this method, I would perform some functions unrelated to GameLift, but for now, since I just want to test the replication of the player state and game state, again, just testing, let's hardcode some values inside the player state and game state, and make sure that we can get our clients to see those values. So, starting with the player state, let's go ahead and get that from the player controller, but first, let's do a null check on the player controller passed to this init new player method by typing if in parentheses new player controller not equal null pointer, squiggly brackets. If it's not null, let's get the player state by typing a player state pointer player state and set that equal to new player controller arrow player state. And then let's do a null pointer check on that as well by typing if in parentheses player state not equal null pointer, squiggly brackets, and if that's not null, let's do a cast on it to a pointer to an object of type GameLiftTutorial player state by typing a GameLiftTutorial player state pointer GameLiftTutorial player state, and set that equal to cast in carets a GameLiftTutorial player state, and then in parentheses this cast method will take in the player state. And then let's do one more null pointer check on that just to be extra safe by typing if in parentheses GameLiftTutorial player state not equal null pointer, and then squiggly brackets. And since this small snippet of code starting from line 110 is just for testing, let's write some very simple logic to set the team variable of the player state to either cowboys or aliens, depending on the value of a random integer between 0 and 1 inclusive. So in here type out if, and then in parentheses to generate that random integer between 0 and 1 inclusive, type out fmath double colon rand range in parentheses 0, comma 1. And then we're going to check if this random integer value is equal to 0, because if it is, then we'll set GameLiftTutorial player state arrow team equal to, in quotes, cowboys. Sorry, in double quotes, cowboys. And if it's not 0, then it's probably 1. So in the else case, we will set GameLiftTutorial player state arrow team equal to, in quotes, aliens, because that's the other team. Now moving on to the game state, let's actually set values in there in the begin play function, because this init new player function will be called every time a player connects to the server. And just for testing purposes, I'm going to simulate the end of the game and that a winning team was decided, which would only happen once, and the begin play function only gets called once for a server process. I know it sounds weird that when the game starts, the game will immediately end logically, but again, this is just for testing purposes. We're going to comment out this code that we just wrote later in the video, so go up to the begin play function, and at the end here, after this end if macro, let's get the game state and make sure that it's not null pointer by typing if in parentheses game state not equal null pointer, and then in squiggle brackets, if it's not null, then let's cast it to a pointer to an object of type GameLiftTutorial game state by typing a GameLiftTutorial game state pointer GameLiftTutorial game state, and set that equal to cast in carets a GameLiftTutorial game state, and then in parentheses pass in the game state. And of course, let's be extra safe and check that the pointer resulting from the cast is not equal to null pointer by typing if in parentheses GameLiftTutorial game state not equal to null pointer squiggly bracket. And if it's not equal to null pointer, then let's set properties in the game state. So first let's set GameLiftTutorial game state arrow latest event equal to, in quotes, game ended. And then let's set GameLiftTutorial game state arrow winning team equal to, in quotes, one of the two teams. I'm just going to choose Cowboys, but you could pick aliens if you wanted to. And before we move on to the GameLiftTutorial widget class, let's just make sure that everything that we just wrote compiles fine. So let's right click our project in the Solution Explorer and select Build. Once the project is finished compiling, let's go to the GameLiftTutorial game widget header file so that we can start adding code that will display and use those replicate player state and game state properties. So the first thing we're going to do is at the very top of this header file, we're going to add a for declaration for the uTextBlock class, so just type out class uTextBlock. The reason we need this is because we will have member variables in this widget class of type uTextBlock pointer. Next up, we need to define a few timer handle member variables because we will be running functions on a continuous loop to get the text block widgets populated with the most updated information. So in the class definition, under where it says generated body in all caps, type out public colon and then new property parentheses f timer handle set teammate count handle and then new property parentheses f timer handle set latest event handle, and then lastly uProperty parentheses f timer handle set average player latency handle. And like the main menu widget class, we are going to be overriding the native construct and native destruct methods inside the GameLiftTutorial widget class for initializing widget variables and clearing timer handles respectively. So type out protected colon virtual void native construct parentheses override and then virtual void native destruct parentheses override. Now let's define a member variable for each text block widget inside our UI game widget blueprint. So type out private colon uProperty parentheses uText block pointer team name text block and then uProperty parentheses uText block pointer teammate count text block and then uProperty parentheses uText block pointer event text block and then uProperty parentheses uText block pointer ping text block. And finally, let's define the functions responsible for getting information from the player state, game state, and game instance classes and will be run on a loop. So type out uFunction parentheses void set teammate count parentheses and then uFunction parentheses void set latest event parentheses and then uFunction parentheses void set average player latency parentheses. Now let's go to the GameLiftTutorial widget C++ class and actually initialize those properties as well as implement those functions. So at the very top, let's first add some include statements. So type out hashtag include in quotes components slash text block .h and then hashtag include in quotes game framework slash game state base and then hashtag include in quotes GameLiftTutorial player state .h and then hashtag include in quotes GameLiftTutorial game state .h and then hashtag include in quotes GameLiftTutorial game instance .h and finally hashtag include in quotes kismet slash game play statics.h. And the first method that we're going to implement is the native construct method, and here we will initialize our text block widget member variables as well as set a few timer functions to get called repeatedly on an interval. So type out void uGameLiftTutorial widget double colon native construct and then parentheses, squiggly brackets. The first thing we're going to do is call the user widget superclasses version of native construct. So type out super native construct parentheses. Next up, we are going to initialize some member variables by getting them from the widget blueprint. So starting with the team name text block, type out team name text block equal, and then in parentheses u text block pointer, because we have to cast whatever the result from the get widget from name function to a variable of type u text block pointer. So after that, type out get widget from name, and then in parentheses pass in a text object, in parentheses and in quotes the name of the widget we want to get. So in our case, it's going to be called text block underscore team name. And then moving on, let's do the teammate count text block. So type out teammate count text block equal, and then pretty much the exact same thing. In parentheses, u text block pointer for the cast, and then get widget from name, and then in parentheses and text, in parentheses, in quotes, the name of the widget, which is text block underscore teammate count in our case. And then after that, let's do the event text block. So we'll set that equal to same thing, in parentheses, u text block pointer, and then get widget from name, in parentheses text, in parentheses and in quotes, text block underscore event, because that's the name of the widget we're looking for. And then lastly, the ping text block, let's just set that equal to, in parentheses, u text block pointer, and then get widget from name, in parentheses text, and then in parentheses and in quotes, text block underscore ping. Then let's set a few timer functions by typing get world parentheses arrow get timer manager parentheses dot set timer, and then in parentheses this set timer function will take in 6 parameters. The first one will be a timer handle, an object of type f timer handle. So we're going to pass in first the set teammate count handle. This is the member variable that we defined before. The second parameter will be this. The third parameter will be the address of the function to be called on an interval. So ampersand u GameLift tutorial widget set teammate count, and then the next parameter will be essentially the initial delay of when the function is going to be called for the first time. So we're just going to do 1.0f. So the function will be called for the first time in 1 second. Next parameter is a boolean denoting whether or not this function will be called repeatedly on loop. So we're going to set that to true. And then the last parameter is how often this function will be called, if it is going to be called on an interval. So we're just going to have it get called every second. So the last parameter will be 1.0f. And we're pretty much going to do the same thing for the other two set functions that we have. So set latest event and set average player latency. So moving on to set latest event, let's do get world parentheses arrow get timer manager parentheses dot set timer, and it's very similar in terms of the parameters that we're going to pass in the set timer, with the exception of 2 parameters are going to be different. So the first one is going to be the object of type f timer handle. We're going to use set latest event handle this time, and then this, and then the address of the set latest event function. So ampersand u GameLift tutorial widget set latest event, and then 1.0f, and then true, and then lastly 1.0f again, because like the set teammate count function, we're going to have the set latest event function get called in 1 second for the first time, and then after that get called every second there on out. And then lastly, we'll do get world parentheses arrow get timer manager parentheses dot set timer again, but this time for the first parameter we're going to pass in the set average player latency handle variable, and then the next parameter is going to be this, and this time the third parameter is going to be ampersand u GameLift tutorial widget set average player latency. And then the last three parameters are the same as before. So 1.0f, true, and 1.0f. Alright, that's it for the native construct function. Let's now override the native destruct method, because in the event that the widget gets destroyed for whatever reason, we should clear those timer handles. So type out void GameLiftTutorial.widget, native destruct, parentheses, squiggly brackets. And then to clear a timer handle, you just have to call the clear timer function and pass in the timer handle that you want to clear. So type out get world, parentheses, arrow, get timer manager, parentheses, dot clear timer, and then in parentheses we'll pass in the set teammate count handle variable first. And then we're going to do the exact same thing for the other two timer handle member variables in this class. So get world, get timer manager, clear timer, and then in parentheses set latest event handle, and then finally one more time get world, parentheses, arrow, get timer manager, parentheses, dot clear timer, and then in parentheses set average player latency handle. And then finally let's call the superclass uUserWidgets version of this method. So I got super native destruct parentheses. And that is it for the native destruct method. We now have to actually write the functions that we have set to be called on a timer interval. So let's start with the set teammate count method by typing void GameLiftTutorial.widget, set teammate count, parentheses, and then squiggly brackets. The name of this method is a little incomplete because it will also be responsible for getting the team that the player belongs to and setting the team name text block, since you have to know which team that a player belongs to before tracking the number of teammates, including the player itself. So let's make a couple of local variables. First one will be of type fstring, and it will be called owning player team. So the player that owns this widget instance, what team do they belong to? And then the next variable will be of type a player state pointer. This will be called owning player state. So the player state instance associated with the player that owns this widget instance. And we're going to set that equal to get owning player state parentheses. And then let's do a null pointer check on the owning player state by typing if in parentheses owning player state arrow or not equal null pointer, and then squiggly brackets. If it's not null pointer, then let's cast the player state pointer to a GameLift tutorial player state pointer by typing a GameLift tutorial player state pointer owning GameLift tutorial player state equal cast, and then in caret a GameLift tutorial player state, and then in parentheses passing the owning player state. And just to be extra safe, let's do a null pointer check on that by typing if in parentheses owning GameLift tutorial player state not equal null pointer. And if it's not null pointer, then let's set our owning player team local variable equal to owning GameLift tutorial player state arrow team. After that, let's set the text inside the team name text block widget to reflect the player's team. So type team name text block arrow set text, and then in parentheses pass in f text from string in parentheses and in quotes team name space, and then plus owning player team, and that went off with a semicolon. And I know a few of you may be wondering that this is a little inefficient because currently a player's team won't change, so we are effectively setting this text to the same value over and over again, which is true. This is not very clean, but it does get the job done, and it's still very easy for Unreal Engine to process considering how powerful Unreal Engine is. Again, this is just a tutorial, so not everything will be perfect or optimized. Moving on, let's check if we were able to figure out what team that the player belonged to by typing if in parentheses owning player team.len parentheses greater than 0 and then squiggly brackets. And then let's actually get the number of people on the player's team by getting all of the player state instances in the game and checking their team properties. So type out t array and then in carets a player state pointer, and then we'll call this variable player states, and we'll set it equal to get world parentheses arrow get game state parentheses arrow player array. And then let's set a local counter variable to keep track of how many players that we found that are on the owning players team. So type out int teammate count and set that equal to 0. Now let's loop through the array of player state objects by typing for in parentheses a player state pointer player state colon player states squiggly brackets. And let's do a quick null pointer check on the player state that we are iterating on by typing if in parentheses player state not equal null pointer squiggly brackets, and then let's cast the player state pointer to a GameLift tutorial player state pointer by writing a GameLift tutorial player state pointer GameLift tutorial player state and set that equal to cast, and then in carets a GameLift tutorial player state and then in parentheses pass in the player state. And then let's check if it's a null pointer as well, and also whether or not if that player state instance's team matches the owning player's team by typing if in parentheses GameLift tutorial player state not equal null pointer double ampersand GameLift tutorial player state arrow team dot equals in parentheses owning player team and then squiggly brackets. If that is the case, let's increment our teammate count variable by 1 using the ++ operator. And finally, after iterating through the player state objects and determining how many players are on the owning player's team, let's set the text in the teammate count text block to reflect that by typing teammate count text block arrow set text and then in parentheses f text double colon from string in parentheses and in quotes teammate count colon space and then plus f string double colon from int in parentheses teammate count. By the way, I know that looping through the player states is not efficient, especially when it's being done in a function that gets called every second. You could always keep track of the amount of players on each team in constant time by using the game mode and game state classes together in a way that is more efficient than what we are currently doing. But once again, this tutorial is mainly for explaining concepts, so not everything will be perfect or optimized. Now that the set teammate count method is finished, let's implement the set latest event method by typing void u GameLift tutorial widget double colon set latest event and then parentheses and then squiggly brackets. The first thing that we're going to do is set a few local variables, so type out f string latest event and f string winning team. These two local variables will be used to store the replicated properties from our custom game state class. Now let's actually retrieve the game state instance by typing a game state base star game state equal get world parentheses arrow get game state parentheses. And then let's perform a null pointer check by writing if in parentheses game state not equal null pointer and squiggly brackets. If it's not null pointer, let's cast the game state pointer to a GameLift tutorial game state pointer by typing a GameLift tutorial game state star GameLift tutorial game state and set that equal to cast and then in carets a GameLift tutorial game state and then in parentheses pass in the game state. and do a null pointer check on that by typing if in parentheses GameLiftTutorial game state not equal null pointer, and then in squiggly brackets in here let's set our latest event and winning team local variable. So type latest event equal GameLiftTutorial game state arrow latest event, and winning team equal GameLiftTutorial game state arrow winning team. Now let's check if we were able to retrieve a valid string value for the game state's latest event property by typing if in parentheses latest event len parentheses greater than 0, and then let's check if the latest event was game ended by typing if in parentheses latest event equals, and then in parentheses and in quotes game ended, and then squiggly brackets, because if the game ended, then that means that a winning team was decided, and depending on what team the player was on, the text to set in the event text block could be one of two values. But if the latest event wasn't game ended, then in our case it will usually be about either how much time until the game is over or the server process being interrupted. So type down here else squiggly brackets, and we'll just set the text inside the event text block to whatever the latest event was. So write event text block arrow set text, and then in parentheses f text double colon from string in parentheses latest event. But back up to the scenario where the latest event was game ended. In this case, we have to figure out which team that the owning player belonged to, because that will help us determine whether or not the player was on the winning team, thereby determining what the text inside the event text block should be. So we actually already wrote a snippet of code that helps us retrieve which team that the owning player belongs to in the set teammate count method. So let's go up and copy a snippet of code inside of here, starting with the first line inside the method where we define owning player team, down to include the entire first if statements block of code. So copy that, and then go back down to the set latest event method inside the block inside the if latest event equals game ended statement, and paste that snippet of code in there. However, let's get rid of this line of code that sets the text inside the team name text block, since we already do that in the set teammate count method. After that, let's check if the winning team and owning player team variables contain valid string values by typing if in parentheses winning team dot len parentheses greater than 0 double ampersand owning player team dot len parentheses greater than 0 squiggly brackets, and if they do, let's initialize the game over message that will be displayed in the text block, in the event text blocks, by writing f string game over message equal in quotes u and the space quote plus owning player team. And if the player belonged to the winning team, then the text inside the event text block will be the game over message plus the word won, because in that case you and the team won. So type out if in parentheses owning player team dot equals in parentheses winning team, and then squiggly bracket event text block arrow set text in parentheses f text double colon from string in parentheses game over message plus in quotes space 1 exclamation point. Now on the flip side, if the player was on the losing team, then the text would say you and the team lost. So type out else squiggly brackets event text block arrow set text in parentheses f text double colon from string in parentheses game over message plus in quotes space lost space sad face. And finally, let's implement the last method, set average player latency. So down here, type void u GameLift tutorial widget double colon set average player latency parentheses and then squiggly brackets. Now this method will be almost exactly the same as how we implemented this exact same method in the main menu widget C++ class. So head on over to the main menu widget C++ file, find the set average player latency method, and copy everything inside that method. And then go back to the GameLiftTutorial widget class, specifically in the set average player latency method, and paste everything inside of there. Note that there will be one minor difference, which is that in the main menu widget class there was a member variable called average player latency, because we had to keep track of the client's network latency for the matchmaking request to flex match. When the client actually joins the game and connects to the server, we don't really need to keep track of the network latency anymore. Hence why we don't have a member variable for it in this widget class. So the only modification we have to make is define and initialize inside this function a average player latency float variable. So in between the if check, the if total player latency greater than 0 check, and the for loop that iterates the player latency values in the game instance, let's write float average player latency, and we'll give it a default value of 60.0f. And that's it for the GameLiftTutorial widget class. Let's go ahead and build our project now so that we can test our changes in the editor. Once the project has finished compiling, go back to the Unreal Engine editor and play the game. Now when you play the game, it may take a little bit of time, but you'll notice that all the text block widgets are populated with the right values. For example, on the bottom left we have the ping, and then on the top row we have the team name as well as the teammate count, and in the middle we have the game ended text, which again it'll depend on which team that the player is on. So for this player that you're looking at right now, it is on the aliens team, and we have 2 people on the aliens team, which we can verify by looking at the other instances of the running game. So I'm going to look at this one, for example. We'll bring that here. So this guy's on the Cowboys. So we got 1 cowboy, 1 alien, and then let's go to one of the other client windows. So this one here. Let me try to drag this guy. So we have another alien, so that's 2 aliens, and if we look at the last client window, which is this guy right here, we also have another cowboy. So in this case we have 2 cowboys and 2 aliens. Now note that since we're setting the team of each player based on chance, you may not have it as an even 2v2 like I did in this case. You may have a 3v1, you may even have a 0v4, but notice that the text in the middle depends on which team that you're on, because right now we hard code the logic so that the Cowboys would always win. So in that case, all the client windows of the players on the Cowboys team will say in the middle, the top middle of the screen, that you and the Cowboys won. Whereas if we go to any of the clients on the aliens team, it will say you and the aliens lost. So seems like everything's working, so you can go ahead and quit the game. Now, before I get into the main crux of the server functionality that needs to be written out in the game mode class, I want to quickly modify the character class so that we can set the color of the pawn based on the team that the owning player belongs to. Also, I want to give the client the ability to press a certain key event to go back to the main menu map to make testing later on easier. So let's first add a new input object, which is essentially a way to convert player input into data that actor classes like the GameLiftTutorial character class can understand and use by going to edit and then project settings, and then that's going to open up a new project settings window. And then on the left side here under the engine section where it says input, just click on that, and then under where it says bindings and where it says action mappings, just click on this little sideways triangle to expand that section. And let's go ahead and click the plus button by where it says action mapping to, create a new action mapping. And we're going to call this new action mapping return to main menu, because like I said earlier, this new action mapping is going to be responsible for allowing the client, while they're in the third person example map, to go back to the main menu map. So where it says done here in this drop down menu, underneath our new action mapping, just click on it. And let's look at the word escape, because I want to use the escape key on the keyboard to initiate this whatever actions we tie to this input object. So just select the escape word. There's no significance behind my choice. You can use really any key, any keyboard key, whatever you want. Okay, once you're done with that, let's close out this project settings window and go back to Visual Studio, but this time go to the GameLift tutorial character header file, and in here we are going to define two new methods. So the first one is we are going to define a new function to attach to that new input object we just made. So let's see, underneath the very end here, under this touch stop method, let's write out void return to main menu parentheses. And the other function we are going to define is what is known as a rep notify function, which is essentially a replication notification callback function. So the one we are going to define is an override version of the apons class's onRep player state function, which gets called on the client side whenever properties of the client's player state get updated on the server's version of that player state, and then get replicated to the client's version. And we are going to override this because, like I mentioned before, I want to set the color of the pawn so that we can better distinguish between people who are and are not on the player's team. And since we are setting the color based on the player's team, we can set the color in the function that gets called when the team property of the player state changes. So type out down here, private colon virtual void on rep underscore player state parentheses override. Alright, now let's go to the GameLift tutorial character C++ file so that we can implement these two new functions. But before we do that, let's add a few include statements at the top here. So type out hashtag include in quotes GameLift tutorial player state.h, and then hashtag include in quotes net/Unreal Network.h, and lastly hashtag include in quotes kismet/gameplay statics.h. And let's also add the return to main menu function as a delegate for the return to main menu action mapping that we just made earlier by going down to the setup player input component function, and at the very end here, let's type out player input component arrow bind action, and then in parentheses and in quotes return to main menu, and then comma IE underscore pressed, and comma this, and then comma ampersand a GameLift tutorial character double colon return to main menu. Now essentially what this line of code does is now every time someone presses the escape key, the return to main menu function gets invoked. Now let's actually implement the return to main menu function by going down and typing void a GameLift tutorial character double colon return to main menu parentheses and then squiggly brackets. First, let's make a local variable of type fstring called double name for the name of the map that we want the client to travel to. So we'll set this equal to in quotes main menu map. And then let's call the open level function that will make the client leave the server map and go back to the main menu map by typing u gameplay statics double colon open level, and then in parentheses this function will take in 4 parameters. The first one will be get world parentheses, the next parameter will be the name of the map, so type out fname in parentheses star level name. Next parameter will be a boolean to denote whether or not we want the options to be reset or not. We're not really passing options, so we're going to just set that to false anyway. And then the last parameter are the options. So I'm just going to pass in a blank string, which is denoted by a pair of quotes because we're not sending any options. And next up, let's implement the onRep player state function by typing void a GameLift tutorial character double colon onRep underscore player state parentheses squiggly brackets, and the first thing that we're going to do is call the parent classes onRep player state function by typing super double colon onRep underscore player state parentheses. And then let's get the player state associated with this character so that we can know which team that the player belongs to by typing a player state pointer owning player state and set that equal to get player state parentheses. And then let's do a null check on that player state by typing if in parentheses owning player state not equal null pointer, and if it's not null pointer, in squiggly brackets, let's cast the player state pointer to a GameLift tutorial player state pointer by typing a GameLift tutorial player state star owning GameLift tutorial player state equals cast in carets a GameLift tutorial player state, and then in parentheses owning player state. And then we'll do a null check on that as well by typing if owning GameLift tutorial player state not equal null pointer, and then in squiggly brackets we can get the name of the team by typing f string team name equal owning GameLift tutorial player state arrow team. And then let's check if the team property has a valid string value by typing if in parentheses team name dot len parentheses greater than 0 squiggly brackets. Now to change the color of the pawn, we first need to get the main body material of the mesh attached to this character. So to do that, type out u material instance dynamic star owning player material and set that equal to u material instance dynamic and double colon create, and then in parentheses passing get mesh parentheses arrow get material in parentheses 0 comma this. And then based on the team that the player belongs to, we can change the color of the pawn by setting the value of a specific parameter that the material uses. Right now that parameter is set to some kind of white grayish color, but if the player is on the Cowboys, let's change that parameter to be red, and if the player is on the Aliens, let's change that parameter to be blue. So type out if in parentheses team name that equals in parentheses and in quotes Cowboys, and then squiggly brackets owning player material arrow set vector parameter value, and then in parentheses and then in quotes a body color comma f linear color double colon red. And then underneath that type out else if in parentheses team name dot equals in parentheses and in quotes aliens, and then squiggly brackets owning player material arrow set vector parameter value in parentheses and in quotes same thing body color, but this time the second parameter will be f linear color double colon blue. And finally, reassign the material of the mesh to that new material instance we just made with that new value for the body color vector parameter by typing get mesh in parentheses arrow set material, and then in parentheses passing 0 comma owning player material. Now before I build a project, I just want to note that if you have more custom properties in your player state that you are using and replicating, then just note that this onRep player state function can get called multiple times, so you may not always want to set the color of the character's mesh. You may want to add a conditional statement based on a flag variable even, and this can also apply to a lot of the code we wrote in the GameLift tutorial widget class to avoid doing the same action over and over again redundantly. But I'm also trying to make this tutorial shorter, so as a result, I am sacrificing some best practices in the hopes that you guys watching can notice that and figure better ways to optimize this code. With that said, let's go ahead and build our project. Once your project is finished building, let's go back to the Unreal Engine editor and play the game. And you should notice now that the players on the Aliens team are blue, while the players on the Cowboys team are red. And this applies to all the clients. So if we look at any of the other client windows, for example, this one, this guy's a Cowboy, so he's red. And if we go to one of the other client windows, you know, what they see is exactly what the other players see, in the sense that there are two specific players that are aliens and there are two specific players that are Cowboys. And let me just go to the very last client window to just confirm that the same two players on all client windows are Cowboys, and the same two players on all the client windows are aliens. So everything seems to look good here, so let's press escape. Now, just a warning, in order to test if our delegate function is tied to the return to main menu action mapping, which is activated by an escape key press, we have to test the game in standalone non-multiplayer mode. So to do that, to the right of the play button, click on this, you'll get a drop down menu and select the option under modes labeled standalone game. And once you have that option selected, a standalone game should automatically launch for you. If not, you can always, re-click the play button. But once your standalone game has launched, you'll notice a few things. You'll notice that the player has no color and there's only one player. Again, in standalone mode, it's non-multiplayer mode, so things like replication won't really apply here. But the important thing is we just want to test the escape key, because if we press the escape key when testing in the editor, then we quit the game. And by the way, that doesn't have to do with the fact that we chose the escape key as the input mapping for that return to main menu action. You could have changed it to the E or R key, and you would still have to test on the standalone mode. So if I press escape, we should go back to the main menu widget, and this is exactly what we expected. Now remember that when we actually do this on a real client and they get into a match and then press escape to go back to the main menu map, they won't be going back exactly to this login screen, because they will have an access token at that point. So they'll see the actual main menu with the black background and the button on the bottom right corner. But according to what we just saw, everything seems to be working, so just exit out of this standalone game. Now let's go back to Visual Studio, specifically the GameLift Tutorial Game Mode C++ class, and let's just quickly comment out that hard-coded logic that we added for testing purposes inside the begin, play, and init new player functions by highlighting over the code and pressing Ctrl-Shift// all at the same time. And we also have to do the exact same thing in the init new player function. Basically all the code inside the init new player function besides the first and last lines that we added. And in the begin play function, as you saw, I commented out the everything after the end if macro. So after you've done all of that, just go ahead and rebuild your project in Visual Studio. And then after that's done, let's go back to the Unreal Engine editor. Don't play the game in standalone mode, so let's change that back to selected viewport. And then let's just make sure that our hard-coded logic is gone, because in the real game we want to rely on the team information given to us by GameLift, and as for the game state properties, we will handle that a little more dynamically in the game mode class rather than hard coding that information. But just looking at what I see here, we seem to have gotten rid of that hard coded logic. We don't have any values for the team name, nor teammate count, nor the latest event in the game state, and none of the players are assigned red or blue colors. So everything looks good here, so we can quit playing the game. With all that said, let's go back to Visual Studio, specifically the GameLift tutorial game mode header file, and now we are essentially going to write a lot of GameLift functionality, almost all of the core GameLift concepts that we are going to go over for the server, such as accepting player sessions, terminating game sessions, handling matchmaker data, and more. With this very next server build that we're going to upload to GameLift and test, we won't be doing backfill. We will do backfill manually for the server build after the next one we're going to upload and create a fleet for. So to get started, let's go to the top and add an include statement here. So type out hashtag include in quotes runtime /online/http/public/http.h, and make sure that this include statement comes anywhere before the include statement for the GameLift tutorial game mode.generated.h file. Now let's modify the fstart game session state struct that we defined in an earlier part of the tutorial to include a couple of more properties. The first one will be for the matchmaking configuration ARN, so the resource identifier for our matchmaker that we made in an earlier part of the tutorial. This is mainly needed for backfill, which we won't be implementing right away, but let's just add it now to save us time later by typing uProperty parentheses and then fstring matchmaking configuration ARN. And next up, let's make a map to map matchmaking player IDs to objects containing information about the player, such as their team as well as their skill attributes, because not only are we displaying the player's team on the UI, but also later we will need to use those skill attributes when making matchmaking requests for backfill later in this video. So let's type tmap and then in carets fstring, comma, AWS, GameLift, server, model, player. And then we'll call this member variable player ID to player. And we can't make this one a U property because values in this map are of a type in the AWS namespace, not a core data type in Unreal Engine. Then scrolling down, as for the fupdate game session state struct that we made in an earlier part of the tutorial, since we are not going to do backfill right away, this struct is not currently relevant since the onUpdate game session handler function only gets called when backfill requests are successfully fulfilled. So moving on to the fprocess terminate state struct, the only change I want to make here is to initialize the termination time variable with a default value so that we have a default value to refer to in the very rare instance when the get termination time method fails. So type inside this constructor termination time equals 0.0L. And then let's scroll down to the game mode classes constructor so that we can start defining methods and properties. First, let's override the pre-login function because the pre-login method is responsible for accepting or rejecting a player trying to join the server. So based on the player session ID and player ID values in the options, pass through a call to open level. The server in this pre-login function will determine whether or not this incoming connection is authorized, and if the connection looks legitimate, then we can let the player connect to the server, and the server will set the associated player session on GameLift to active. So type out virtual void pre-login, and then this function will take in 4 parameters. The first one will be of type const fstring ampersand called options. The next parameter will be of type const fstring ampersand as well, but it will be called address. The next parameter will be of type const f unique net ID REPL ampersand, and it will be called unique ID. And then the last parameter will be of type fstring ampersand, and it will be called error message. And then add the word override here at the end. And let's also override the logout method. The logout method is called whenever a player leaves the game. So this is useful for terminating player sessions on GameLift because once players associated with active player sessions are no longer connected to the server, we should no longer keep their player sessions as active on GameLift in order to let GameLift know that the server process potentially has capacity for new players, which you will see later on in the tutorial is very important for backfill. So type out virtual void logout in parentheses a controller star exiting, and then override. Now let's define some timer handle member variables, because we will have a lot of functions running on a timer, whether they are being called on a consistent interval or simply called once after a delay. And as we define these, you will start to get a better picture of the quote-unquote game logic that we will be writing. Just to note that this is a tutorial on learning GameLift and multiplayer concepts, not necessarily a tutorial on making a game. So all of our game logic really is just have the server process. Once a game session is activated on it, run for about 4 minutes, and then after that, one of the two teams is chosen at random as the winning team. Player stats and game stats get updated in DynamoDB, and then the server process is terminated. Again, later on in this tutorial, players will be able to join in the middle of the game. That's backfill, but for the first timer handle, this will be for counting down the amount of seconds left in the game to inform the clients through the custom widget class how much time is left in the game. So let's write public colon uProperty parentheses f timer handle, and then we'll call this variable count down until game over handle. Next up, we need a timer handle for when we quote-unquote end the game, which means terminating the game session on GameLift as well as terminating the server process. And since I want to do that after a small delay, preferably, type out uProperty parentheses and then f timer handle, and then call this variable end game handle. And then we also need a timer handle for when the game is over and the server has to pick a winning team. So the delegate function for this timer handle will be called, in our case, 4 minutes after the game session activated. So type out uProperty parentheses f timer handle and call this one pick a winning team handle. And we also need a timer handle for a delegate function that constantly checks if the server process was interrupted somehow and has to terminate. So type out uProperty parentheses f timer handle, and then we'll call this variable handle process termination handle. And lastly, we need a timer handle for a delegate function that will constantly do one of two things. It will either be checking for when a game session activates, or when the onUpdate game session handler function gets called. A game session activates once in the lifetime of a server process, in our case, just to make things easier since we will be ending the server process after the end of every game. After that, the function tied to this timer handle will only check for updates to backfill requests, and normally I would separate the two checks into two separate functions, but I'm going to combine them into one function just to make this tutorial a little faster by typing uProperty and then parentheses f timer handle, and then we'll call this variable handle game session update handle. Moving on, we need a member variable of type fHTTP module pointer since we will be making an HTTP request at the end of the game to the record match result API endpoint. So type out fHTTP module star HTTP module. And of course, we have to get the API URL from the text file in the URLs folder and store it somewhere. So type down here uProperty parentheses fstring API URL. Also, since we added a Lambda authorizer to the record match result API method, let's keep track of the value that the Lambda authorizer will be expecting. Although we will get this value from the command line arguments, we should store it somewhere as well. So type uProperty parentheses fstring server password. Now let's make a property for the amount of time remaining in the game. Although it will start at 240 because that's 4 minutes and seconds, this number will go down every second. So let's type uProperty parentheses and then int remaining game time. And also let's have a Boolean member variable to keep track of when the game session gets activated on the server process. So type uProperty parentheses bool game session activated. Now let's define all the delegate functions for those timer handle properties that we made earlier. So type ufunction parentheses void count down until game over parentheses, and then ufunction parentheses void end game parentheses, and then ufunction parentheses void pick a winning team, parentheses, then u function, parentheses, void handle process termination, parentheses, and lastly u function, parentheses, void handle game session update, parentheses. And let's define one more function, which will be the response handler function for the HTTP request to the record match result API endpoint at the end of the game. So type out void on record match result response received. And then this function will take in 3 parameters. First one will be of type of HTTP request PTR, and it will be called request. Second one will be of type of HTTP response PTR, called response, and the last one will be of type bool, called b was successful. Now let's go to the GameLift tutorial game mode C++ class so that we can actually initialize some of those properties we just defined, as well as implement the functions we just defined. Before we do that, let's add some include statements here at the top of the file. So just type hashtag include in quotes text reader component.h, and then hashtag include in quotes kismet/gameplay statics.h, and then type out hashtag include in quotes json.h, and lastly hashtag include in quotes json utilities.h. Now let's move on to the constructor method and initialize some default values, starting with the API URL string. So first we need the custom text reader component that we wrote. So type out u text reader component. Sorry about that, missed the first letter. U text reader component star text reader equal create default sub object, and then in carets u text reader, sorry about that guys, u text reader component, and then in parentheses pass in text, and then in parentheses and in quotes text reader comp, and then just read the value from the text file and store it in the API URL variable by typing API URL equal text reader arrow read file, and then in parentheses and in quotes the path of the text file relative to the content folder. So the file was in the URLs directory and it was called API URL.txt. And then let's instantiate an object of type fHTTP module and set our HTTP module variable to the address of that object by typing HTTP module equal and then ampersand fHTTP module double colon get parentheses. And let's also give some default values to some of the game mode's member variables. So for example, remaining game time. Like I said earlier, we want a game to last approximately 4 minutes. So in seconds, that's 240. And as for the game session activated property, by default, that will be equal to false. Moving on to the begin play function, we are going to start by modifying the onStart game session handler function to parse that matchmaker data that we were talking about earlier so that we can populate the player ID to player team app variable in the game mode start game session state struct. So inside this onStart game session handler function, let's get the matchmaker data from the game session object by typing fstring matchmaker data equal game session obj.get matchmaker data parentheses. Then let's deserialize this JSON formatted matchmaker data string, which will require a JSON object and a JSON reader. So type t shared ptr and then in carets f JSON object. We'll call this variable JSON object, and also type out on the next line t shared ref carets t JSON reader, and then carets, and we'll call this variable reader, and we'll set it equal to t JSON reader factory, and then carets, double colon, create, and then in parentheses pass in the matchmaker data variable. Now let's actually perform the deserialization, converting the JSON string to a JSON object, and check if it's successful by typing if in parentheses f JSON serializer, double colon deserialize, and then in parentheses pass in the reader object, and as well as the JSON object, and then squiggly brackets. And if the deserialization was successful, let's start extracting fields from this JSON object. Now remember that we looked at this example matchmaker data string earlier in the tutorial, but I just want to pull it back up here to remind you guys to check the link out in the description to see this example, because it can help give a better idea of what fields we are getting from the matchmaker data. But back to the code, let's first get the matchmaking configuration ARN and store it in our game session state by typing state arrow matchmaking configuration ARN equals JSON object arrow get string field, and then in parentheses and in quotes the name of the field, which in this case is matchmaking configuration ARN. Now let's get the teams array, so type out t array caret t shared ptr carets of JSON value, and call this variable teams, and we'll set it equal to JSON object arrow get array field, and then in parentheses and in quotes the name of the field, which in this case is teams. And then let's iterate through this teams array by typing for in parentheses t shared ptr, and then carets f JSON value team colon teams, and then squiggly brackets. And then let's convert the pointer to an fjson value to a pointer to an fjson object so that we can further extract fields by typing t shared ptr and carets f JSON object, and then we'll call this variable team obj, and we'll set it equal to team arrow as object parentheses. Now we can get fields from this team object, for example the name of the team, so type out f string team name equal team obj arrow get string field, and then in parentheses and in quotes the name of the field, which in this case is just name. And let's also get the players array in this team object by typing t array and carets t shared ptr and carets f JSON value, and then we'll call this variable players and set it equal to team obj arrow get array field, and then in parentheses and in quotes the name of the field, which is in this case players. Now let's iterate through this players array by typing for in parentheses t shared ptr, and then in carets of JSON value player colon players squiggly brackets. And just like with the team, let's convert this pointer into a pointer that points to an fjson object, so type out t shared ptr and carets f JSON object, call this variable player obj, and we'll set it equal to player arrow as object parentheses. Now we can extract fields from this player object, so for example with the player ID, type out f string player ID equal player obj arrow get string field, and then in parentheses and in quotes the name of the field, which in this case is player ID. Now let's extract the attributes field and get the actual skill value, so type t shared ptr and carets f JSON object attributes equal player obj arrow get object field, and then in parentheses and in quotes name of the field, which in this case is attributes, and then t shared ptr and carets of JSON object skill, and set this equal to attributes arrow get object field, and then in parentheses and in quotes the name of the attribute field, which in this case is skill, And then let's get the actual value of the skill by typing f-string skill value equal skill arrow get string field, and then in parentheses and in quotes the name of the field, which is value attribute. And I've said this before, but I'll say it again because it's kind of strange to look at, but attributes in the attributes array come in objects that contain not only the type of the value of the the type of the attribute, but also the actual value of the attribute. So even though the skill value is a string, it's apparent in the type field of the attribute that it is of type double. Now let's create an object of type AWS GameLift server model attribute value, because we will eventually instantiate an object of type AWS GameLift server model player for our start game session states player ID to player map. Again, this is for helping us determine the team of incoming players as well as handle backfill for later. So type auto. Remember, the auto keyword is used for avoiding typing out really long variable types. So we'll call this variable skill attribute value, and we'll set it equal to new AWS :GameLift :server :model :attribute value, and then in parentheses let's pass in the skill value but converted to a variable of type double. So to do that, type out fc string ATOD, and then in parentheses pass in star skill value, and then add a semicolon at the end. Now let's actually instantiate the AWS GameLift server model player object by typing AWS :GameLift :server :model :player AWS player obj. And let's set the player ID of this object by typing AWS player obj dot set player ID, and then in parentheses pass in tchar _2 _ANSI in all caps, and then in parentheses pass in star player ID. Then let's set the team by typing AWS player obj dot set team, and then in parentheses tchar _2 _ANSI in all caps, and then in parentheses star team name. After that, let's set the skill attribute by typing AWS player obj dot add player attribute, and then in parentheses this function will take in two parameters. The first one will be the name of the attribute in quotes, so that'll be skill, and then the second parameter will be the actual attribute value object. So type in star skill attribute value. And finally, let's add this player object to our map by typing state arrow player ID to player dot add, and then in parentheses pass in player ID as the key, and then AWS player object for the value. And that is it for the onStart game session handler function. Let's move on to the onProcess terminate handler function, because I do want to make a very small change. Since we are going to handle process termination now in a separate function, remove all the code in this handler function after this if get termination time outcome that is success statement, but keep the line of code that sets state arrow status equal to true. So copy that line of code, then get rid of this snippet of code, and then paste that line of code back in, because we still need a way for that new handle process termination function to be able to know when a server process has been interrupted for whatever reason. Then moving on to where we parse the command line arguments, since we will now be expecting a password command line switch in addition to the port, let's make sure that we get the value for that password command line argument and store it in the game mode server password variable. So type inside this for loop that iterates through all the command line switches inside the if statement that splits the switch into the name and value of the argument. Right after the if statement, check to see if the switch being iterated on is the port switch. Type out else if in parentheses key dot equals, and then in parentheses and in quotes, password, and then in squiggly brackets, set server password equal to value. And I seem to have missed a closing squiggly bracket. Note that when you're writing code inside the compiler derivative, so the hashtag if, hashtag end if block, sometimes the autocomplete can be a little funky. As I keep writing code inside this class throughout this tutorial, I'm going to remember to write the hashtag if with GameLift, hashtag end if compiler derivative after writing all the code. So just keep that in mind. So as you're writing code, make sure that you are including all of those closing including all those closing parentheses and squiggly brackets. The last thing we're going to write in the begin play function is going to be at the very end of this function. So after the end if compiler derivative, we're going to call set timer specifically on the handle game session update and handle process termination functions, because a game session can be activated and a server process can be interrupted as soon as the server process starts up. So we have to start calling these functions on loop immediately. So type out get world timer manager parentheses dot set timer, and then in parentheses this function takes in 6 parameters. The first one will be the timer handle object, so type out handle game session update handle. Next parameter will be this. Third parameter will be the address of the function to be called, so ampersand a GameLift tutorial game mode double colon handle game session update. Next parameter will be the rate at which the function will be called on loop, if at all. So we're going to have this function get called every second, so type in 1.0f. Next parameter is a boolean denoting whether or not this function will get called on a loop, so type in true, because yes, we do want this function to keep getting called over and over again. And then the last parameter is the initial delay before the very first time that this function gets called. So we're going to set that equal to 5.0f. So this function will get called for the very first time after 5 seconds from calling set timer. And then we're going to do the exact same thing for the handle process termination method. So type out get world timer manager parentheses dot set timer, and then in parentheses pass in handle process termination handle process termination handle, comma this, comma ampersand a GameLift tutorial game mode double colon handle process termination, comma 1.0f, because we want the function to be called once a second, comma true, because we do want the function to get called on a loop, and then comma 5.0f to make this function get called for the very first time after 5 seconds of calling set timer. Now let's override the pre-login function, so go down and type here void a GameLift tutorial game mode double colon pre-login, then in parentheses const f string ampersand options, comma const f string ampersand address, comma const f unique net id repl ampersand unique id, comma f string ampersand error message, and then a pair of squiggly brackets. And the first thing that we are going to do is call the game mode based parent class's version of the method. So type super double colon pre-login, and then in parentheses pass in these same 4 parameters that the pre-login function is taking. So type in options, comma address, comma unique ID, comma error message. And before I move on, I just want to mention what we will be doing in this method. So the pre-login function, like I mentioned before, is for authenticating incoming player connections. And if you believe that an incoming connection should be rejected, then all you have to do is set the error message parameter passed into the pre-login function to any non-empty string value. So that once the pre-login function is finished getting called when a client tries to connect, the game mode class's inherited login function will get called, and that method will just simply check the value of the error message parameter, and if it is not empty, then the login method will return null pointer for the player connection or for the player controller, and as a result, the player will get kicked out of the game. So how are we going to decide whether or not a client should be able to connect to the game? Well, first we have to make sure that the client pass some options when calling open level. Otherwise, we can't get the player session and player session ID and player ID values. So type out if in parentheses options.len parentheses greater than 0 squiggly brackets, and like I just mentioned, if the client doesn't pass in options, then we should consider rejecting this incoming player connection. So type out else squiggly brackets and then error message equal in quotes. This can be anything, but I'm just going to make it unauthorized. But if the client did pass options when calling open level, then let's extract the player session ID and player ID values from those options by running const f string ampersand player session ID equal u game play statics double colon parse option, and then in parentheses this method will take in two parameters. The first one will be the options and the second one will be the name of the specific option that you want to parse out. So in quotes, this one will be player session ID. And next up, type out const f string ampersand player ID and set that equal to u gameplay statics double colon parse option, and then pass in parentheses options, and in quotes this time it will be a player ID since we want to parse out the player ID option. Now another reason that we would reject an incoming player connection is if the client didn't pass in either a player session ID nor a player ID value. So let's check for either of those possibilities by typing if in parentheses player session ID dot len parentheses greater than 0 double ampersand player ID dot len parentheses greater than 0 and then squiggly brackets. And like I just mentioned, we want to reject an incoming player connection if either one of these options that we're looking for are not valid string values. So type out else squiggly brackets, and let's copy this line where we set error message equal to unauthorized in quotes and just paste it in this else block here. But going back up, if the client did pass in both a player session ID and player ID through the option, then let's make sure that these two values line up with each other, meaning that the player ID is associated with the player session ID, because when a matchmaking request gets fulfilled, each player in the request who is uniquely identified by a player ID will be assigned a unique player session ID. So what we can do to check this is by calling the GameLift server describe player sessions method in the AWS namespace. So to do that, we need to first create a describe player sessions request object by typing AWS ;GameLift ;server ;model ;describe player sessions request, and we'll call this variable describe player sessions request. And let's set the player session ID in this request by typing describe player sessions request, and we'll do .set player session ID, and then in parentheses type out tchar_2_ ANSI in all caps, and then in parentheses pass in star player session ID. And then let's actually call describe player sessions by typing auto describe player sessions outcome equal AWS ;GameLift ;server ;describe player sessions, and then in parentheses passing the describe player sessions request object. Now let's check if the call to describe player sessions was successful by typing if, and then in parentheses describe player sessions outcome, that is success, parentheses, and then squiggly brackets. Because if it wasn't usually due to an invalid player session ID, let's reject the player connection by typing underneath this else squiggly brackets, and then copy the line where we set error message equal to unauthorized in quotes and just paste it in this else block. But if the call to describe player sessions was successful, then let's look at the player session object return by typing auto describe player sessions result equal describe player sessions outcome dot get result parentheses. And note that the player session object will be in an array because when calling describe player sessions, you can pass in one of three parameters, either a player session ID like we just did and get an array with one player session object back, a game session ID and get an array with all the player session objects currently in that game session, or a player ID and get an array with all the player session objects associated with that player ID in its lifetime. Since we passed in a player session ID, we are only expecting one player session object in the player sessions array return, so type out int count equal 1, and then auto player sessions equal describe player sessions result dot get player sessions, and then in parentheses pass in the count. And just to be safe, let's just do a null pointer check on the player sessions array by typing if in parentheses player sessions not equal null pointer and then squiggly brackets, and if for whatever rare reason that it is null pointer, then let's reject the incoming player connection by writing else and then squiggly brackets. Just copy the line where we set error message equal to unauthorized in quotes and just paste it in there. But going back up in the case where we do have a player sessions array, let's get the first entry in this array by typing auto player session equal player sessions square brackets 0. And of course, let's get the player ID that we expected to be associated with this player session by writing f string expected player ID equal player session dot get player ID parentheses. And then let's get the status of that player session by typing auto player status equal player session dot get status parentheses. We need this because in GameLift, when matchmaking requests get fulfilled and lead to an event of type matchmaking succeeded, meaning that an available server process was found in the fleet in the queue associated with the matchmaker for hosting a game session for this new match. When that happens, player session objects are made for each player in the match, and they stay in the reserve state for 60 seconds until they transition into the timed out state. Now in this tutorial, we are only going to let players join within that 60-second time frame when the player session is in the reserve state. Because if the player session is timed out, then we're going to assume that the player took too long to join. If the player session is in active state, then that means the player is currently in the game, because as you will see shortly, in the case where we don't reject incoming player connections, we call a GameLift function to accept the player session and mark it as active. And of course, if the player session is in the completed state, then that means that the player was in the game at one point and then left, as we will see when we implement the logout method. And in that case, for this tutorial, we won't let players leave and join back unless they make a backfill request and get back into, unless they make another matchmaking request and that gets paired with an existing backfill request for the same game that they were originally in, and that player ends up getting back into the same game through flex match, and they get a new player session ID as a result. So let's check two things. One, whether or not the expected player ID is the same as the one passing through the options, and two, whether or not the player session is in reserve status. So let's type if in parentheses expected player ID dot equals in parentheses player ID double ampersand player status double equals AWS double colon GameLift double colon server double colon model double colon player session status double colon reserve and then squiggly brackets. And of course, if either one of these two conditions evaluates the false, then we should reject the incoming connection. So type underneath this if statement else squiggly brackets, copy the line where we set error message equal to unauthorized in quotes and paste it in this else block. And like I mentioned earlier, if the player ID passed in is what we expected and the player session is in reserve status, then let's mark the player session as active by calling the GameLift server accept player session method, because we are not going to reject the player connection in that case. So type out auto accept player session outcome equal AWS :GameLift :server accept player session, and then in parentheses this method will take in one parameter, so pass in tchar_2_ANSI in all caps, and then in parentheses pass in star player session ID. But in rare occurrences, the call to accept player session can fail. So in this final case, let's reject an incoming player connection by typing if in parentheses accept player session outcome dot is success parentheses, and don't forget, sorry, I meant to say if not accept player session outcome dot is success. So make sure you have an exclamation point, or sorry, an exclamation mark before accept player session outcome dot is success, and then squiggly brackets. Just copy the line that where we set error message equal to unauthorized in quotes, and just paste it in this if statement. And lastly, just to finish this method, since we wrote a lot of GameLift related code, let's wrap everything after the first line of this function. So scroll up inside the hashtag if with GameLift hashtag end if compiler directive. So let's type up here hashtag if and then with _GameLift in all caps, and then scroll down to the end of the function and type out hashtag end if. Now let's move on and implement the logout function by typing void a GameLift tutorial game mode :logout, and then in parentheses a controller star exiting, and then squiggly brackets. And before we call the parent class's logout method, let's do our own custom logic first, because it does involve the exiting controller parameter passed in. So let's first be extra cautious and do a null pointer check on it by typing if in parentheses exiting not equal null pointer and squiggly brackets. And if the exiting parameter is not equal to null pointer, then let's get the player state from that controller object, because that player state object contains properties such as the player session ID, and like I mentioned earlier when we were coding the pre-login function, when a player leaves, we want to set that player session associated with that player session ID as completed. So let's type a player state star player state also equal to exiting arrow player state. And then let's do a null pointer check on that as well by typing if player state not equal null pointer and then squiggly brackets. Let's cast the player state to a pointer of type GameLiftTutorial player state by typing a GameLiftTutorial player state pointer GameLiftTutorial player state, and set that equal to cast and caret a GameLiftTutorial player state, and then in parentheses pass in player state. And before we keep writing code, I forgot to explain when this logout method that we overwrote gets called. So whenever a player with a controller with the player state leaves the game, or the controller is destroyed, this method gets called. That's why here it's actually good to do the null pointer checks, because very rarely this method will be called when the player controller gets destroyed. Although in this tutorial that should not happen, so normally this method only gets called when a player leaves the game, and in that case we will call the GameLift server remove player session method to mark the player session as completed for GameLift and backfill purposes. So let's get the player session ID by typing const f string ampersand player session ID and set that equal to GameLift tutorial player state arrow player session ID. And let's check if the player session ID contains a valid string value by typing if in parentheses player session ID len parentheses greater than 0 squiggly brackets, and if it does, then let's call remove player session by typing AWS :GameLift :server remove player session, and then in parentheses pass in tchar _2_ANSI, and then in parentheses type in star player session ID. And that's pretty much it for our custom logic. So let's wrap this snippet of code in the hashtag if with GameLift hashtag and if compiler directive. So type up here hashtag if with underscore GameLift, and down here hashtag and if. After our version of the logout method is done, let's now call the parent class's version of the logout method by writing down here super double colon logout and then in parentheses exiting. Now let's go back to the initNewPlayer method that we defined earlier and wrote some testing logic for, but now let's actually write this function the way it is meant to be written. So initNewPlayer is supposed to be used to customize players based on incoming options passed into a call to open level. Therefore, we should be extracting those player session and player ID values from the options like we did in the pre-login method, and actually set the properties in the player state to those values so that we can access them in other methods like the logout method, for example. Now, before we extract the player session ID and player ID values from the options, just like how we did it in the pre-login method, I just want to note that this initNewPlayer method gets called after the pre-login method. So we don't have to do the same validation checks on the lengths of the option string as well as the result of the parsing of the option string, because the pre-login function took care of that for us, and the only way for an incoming connection to pass the pre-login check is if that player passes a valid player session ID and player ID through the options. So let's get those values by typing const f-string ampersand player session ID equal u gameplay statics double colon parse option, and then in parentheses options comma in quotes player session ID, and then const f-string ampersand player ID equal u gameplay statics double colon parse option, and then in parentheses options comma in quotes player ID. And now let's do a quick null pointer check on the new player controller parameter by typing if in parentheses new player controller not equal null pointer squiggly brackets. Now let's get the player state from the player controller passed into this method by typing a player state star player state equal new player controller arrow player state, and then let's do a null pointer check on that as well by typing if in parentheses player state not equal null pointer squiggly brackets, and then let's cast the player state pointer to a GameLiftTutorial player state pointer by typing a GameLiftTutorial player state star GameLift tutorial player state equal cast, and then in carets a GameLiftTutorial player state, and then in parentheses passing the player state. And of course let's do a null pointer check on that as well by typing if in parentheses GameLiftTutorial player state not equal null pointer squiggly brackets, and after all those null pointer checks, let's set the player session ID and matchmaking player ID properties by typing GameLiftTutorial player state arrow player session ID equals star player session ID, and GameLiftTutorial player state arrow player, sorry, not player ID, matchmaking player ID, because remember the player state class has a built-in player ID variable, so we don't want to mess with that at all. So that's why we define our custom property with a different name. So matchmaking player ID equals star player ID. Keep in mind, don't get the matchmaking player, or don't get the player ID used in matchmaking requests to GameLift Flex Match confused with the built-in player ID in Unreal Engine's player state class. Now the server from this point on will be able to access the player's player session ID and matchmaking player ID through their player state instance. But we also have to set the team property. Luckily, we have an easy way to get a player's team from the matchmaker data retrieved in the onStartGameSession handler function. So let's look inside the player ID to player map in the start game session state object by first checking if the map is even populated by typing if in parentheses start game session state dot player id to player dot num parentheses greater than 0. So squiggly brackets, and if it is, let's see if the player ID is in the map by typing if in parentheses start game session state dot player ID to player dot contains in parentheses player ID squiggly bracket. And if it does, let's get the player object associated with that player ID from the map by typing auto player obj equals start game session state dot player ID to player and then dot find in parentheses player ID. And then let's set the team property of that player object by typing fstring team equal player obj arrow get team parentheses. And finally, let's set the team property in the player state to that team value by writing GameLiftTutorial player state arrow team equals star team. And then to finish this method for now, let's wrap the code that we just wrote with the hashtag if with GameLift hashtag and if compiler directive. So up here, let's type hashtag if with underscore GameLift, and then down here, let's type hashtag and if. And that should be it for now for the overridden methods. Now we can move on to implementing our timer delegate functions that make up most of our quote-unquote simple game logic. So starting with the countdown until game over method, let's write void a GameLiftTutorial game mode double colon count down until game over parentheses squiggly bracket. And this method will be responsible for updating the latest event property in the game state to denote how much time is left in the game. So let's check if the game state is null pointer by typing if in parentheses game state not equal null pointer and then squiggly brackets. If it's not, then let's cast the game state pointer to a GameLiftTutorial game state pointer by typing a GameLiftTutorial game state star GameLiftTutorial game state equals cast and then in carets a GameLift tutorial game state and then in parentheses pass in the game state. And of course, let's do a null pointer check on that as well by typing if in parentheses GameLiftTutorial game state not equal null pointer squiggly brackets. If it's not null pointer, then let's set the latest event property. So type GameLiftTutorial game state arrow latest event equals f string double colon from int in parentheses remaining game time plus in quotes space seconds until the game is over. Now, when this function eventually gets set on a timer interval, it will be called every second, and since the remaining game time property will represent the amount of seconds left until the game is over, let's decrement the remaining game time property by 1 if it is greater than 0. So type out if in parentheses remaining game time greater than 0 and then squiggly brackets remaining game time minus minus. The minus minus or dash dash or double hyphen is the decrement operator, so the opposite of the plus plus increment operator that we used earlier in the GameLiftTutorial widget class. The decrement operator decreases the value of a variable by 1. Now, if the remaining game time has already reached 0, then the game should be over by then and we should be good to clear the timer handle for this function. So type else squiggly brackets get world timer manager parentheses dot clear timer and then in parentheses pass in countdown until game over handle. Now moving on to the end game method, let's write down here void a GameLiftTutorial game mode double colon and game parentheses squiggly brackets, and we're going to do a few simple things in this method. So first, we're going to call clear timer on all the timer handle member variables in this game mode class. Even though there will be points when specific timer handles get cleared, this method will kind of serve as a safe precaution to double check that no timer functions are running anymore, and then after that we will do some GameLift related things. So let's clear the timer handles by writing get world timer manager parentheses dot clear timer and then in parentheses let's pass in the countdown until game over handle. And then I'm just gonna copy this line. I'm gonna paste it 4 more times because we have 4 more timer handles to clear. So in the second line, let's replace the parameter passed with end game handle. And then on the third line, let's replace this handle with pick a winning team handle. And then on this next line, let's replace this parameter with handle process termination handle. And lastly, let's replace this last parameter with terminate, or sorry, not terminate, handle game session update handle. Now let's perform some GameLift functions and then terminate the server process. So first, when the game ends, we should terminate the game session that is activated on the server process so that we can reuse the server process running on this port to host another game session for a new match in the future, since the server process can only host one game session at a time. So to do that, let's type down here AWS ;GameLift :server :terminate game session parentheses. Now after calling terminate game session, you have 2 options here. You can either do some custom logic to clean up the server process, like reset game variables, kick the players out, etc. And once the server process is ready to host a new game session, you can call GameLift server process ready, like how we did in the begin play function, to let GameLift know that this server process can host another game session. Now for this tutorial, just to keep things simple, we will be letting GameLift know that the server process is shutting down, so that when the server process restarts, the begin play function will run again and process ready will be called again. This just makes it a lot easier in the tutorial in terms of cleanup and reusing the server process for a new game session. Now keep in mind that depending on whichever implementation you choose to do, in some cases one approach can be faster for getting a server process ready again, and in other cases the other approach can be faster. But in our case, when shutting down a server process, we have to let GameLift know by calling the GameLift server process ending function, and this should be called generally after doing whatever shutdown cleanup logic that has to be done and terminating an active game session if there is one. So let's type AWS ;GameLift :server :process ending parentheses. And lastly, let's actually stop the execution of the server process by calling the Unreal Engine request exit method. So type out f generic platform misc :request exit, and then in parentheses, this method takes in a boolean parameter for whether or not you want to force the application shutdown. So we are just going to pass in false so that we don't have to force a shutdown and we can just exit cleanly. And to finish this method, let's wrap the last 3 lines of code in the hashtag if with GameLift hashtag and if compiler directives. So right here hashtag if with _ GameLift, and then down here type hashtag and if. Now let's move on to the pick a winning team method. So down here type out void a GameLift tutorial game mode ; pick a winning team parentheses squiggly brackets. And this method will be responsible for choosing one of the 2 teams at random to win the game and make an HTTP request to the record match result API endpoint so that the player and game stats get updated in DynamoDB. But the first thing that we're going to do is clear the countdown until game over handle variable, because by this point the game should be over and there's no point in updating the game state's latest event property with the amount of time left in the game. So write get world timer manager parentheses .clear timer, and then in parentheses pass in countdown until game over handle. After that, let's set the latest event and winning team properties of the game state, but first check if the game state is equal to null pointer by typing if in parentheses game state not equal null pointer, and then in squiggly brackets, then cast the game state to a GameLift tutorial game state pointer by typing a GameLift tutorial game state pointer GameLift tutorial game state equal cast, and then in carets a GameLift tutorial game state, and then in parentheses pass in the game state. And let's do a null pointer check on that as well by writing if in parentheses GameLift tutorial game state not equal null pointer, and then in squiggly brackets. After those null pointer checks, let's set the latest event property to game ended by typing GameLift tutorial game state arrow latest event equal in quotes game ended. And like I mentioned before, let's pick one of the two teams, Cowboys or Aliens, at random to win the game. So let's generate a random number between 0 and 1 inclusive. And if it's equal to 0, then we'll set the winning team property in the game state to Cowboys. But if it's equal to 1, we will set the winning team property to Aliens. So type out if in parentheses fmath rand range, and then in parentheses 0, 1 equals 0, and then in squiggly brackets let's set GameLift tutorial game state arrow winning team equal to in quotes Cowboys, else, and then in squiggly brackets we'll set GameLift tutorial game state arrow winning team equal to in quotes Aliens. And remember, the setting of these game state properties is to make sure that the clients can be notified through their UI of the latest event and winning team changes. Now, before we move on to the making of the HTTP request, I just want to cover some edge cases for some of these if statements. So in the event that the game state is equal to null pointer, in the very, very rare case, let's call the endGame function in 5 seconds. So right here, else, and then in squiggly brackets, type out get world timer manager, and then parentheses dot set timer, and then in parentheses pass in the endGame handle, this, comma, ampersand a GameLift tutorial game mode double colon and game, comma 1.0f, comma false. Since we won't have this function running on a loop, we're just having it run once after a delay, and that delay will be 5 seconds, so the last parameter will be 5.0f. Also, in the very, very rare case in which the game state cast fails, let's also call the endGame function in 5 seconds. So over here, write out else, squiggly brackets, and then do the exact same thing as we just did. So copy this line where we set a timer for the endGame function to be called in 5 seconds. Copy that line and just paste it in that else block. Alright, now we can move on and make the HTTP request. So for the request, as you guys remember from earlier in the video, the record match result lambda function will be expecting a winning team and game session ID in the request body. So let's make a JSON object for the request body by typing t shared ptr and then in carets f JSON object. We'll call this variable request obj, and we'll set it equal to make shareable in parentheses passing uf JSON object. And then let's set the winning team field to the winning team property in the game state by typing request obj arrow set string field, and then in parentheses and in quotes the name of the field, which in this case would be winning team, and then comma the actual value, which will be GameLift tutorial game state arrow winning team. And then let's get the game session ID by calling the GameLift server get game session ID function by typing auto get game session ID outcome equal AWS double colon GameLift double colon server double colon get game session ID parentheses. And let's check if the call to the get game session ID function was successful by typing if in parentheses get game session ID outcome that is success parentheses and then squiggly brackets. Now if it wasn't successful, then let's just call the endGame function in 5 seconds by typing down here else in squiggly brackets. Just copy this line where we set the timer for the end game function, and then just paste it in this else block. But if the call to get game session ID was successful, then let's set the value of the game session ID property in the request body object to the game session ID by typing up here request obj arrow set string field, and then in parentheses and in quotes the name of the field, which in this case is game session ID, and then comma the actual value for this property, which will be get game session ID outcome dot get result parentheses. Now let's serialize the JSON object into a JSON formatted string. For that we will need a f string variable and a t JSON writer variable, so type out f string request body and then t shared ref in carrots t JSON writer carrots. We'll call this variable writer, and we'll set equal to t JSON writer factory carrots double colon create, and then in parentheses pass an ampersand request body. Then let's actually perform the serialization and check if it's successful by writing if in parentheses f JSON serializer double colon serialize, and then in parentheses pass in request obj.to shared ref parentheses comma writer squiggly brackets. Now if the serialization was not successful for whatever weird reason, then we will just call the endgame function in 5 seconds by typing else squiggly brackets and then copy a line of code where we already do that and then paste it in this else block. Now going back up, if the serialization was successful, then let's actually make the HTTP request. So first we need a HTTP request variable, so type out t shared ref and then in carrots I HTTP request, call this variable record match result request, and we'll set it equal to HTTP module arrow create request parentheses. Then let's bind a onProcess request complete delegate function to this request by typing record match result request arrow onProcess request complete parentheses dot bind u object, and then in parentheses pass in this comma ampersand a GameLift tutorial game mode double colon on record match result response received. Next, let's set the URL of this request by typing record match result request arrow set URL, and then in parentheses pass in API URL plus in quotes slash record match result. And then this will be a post request, so type record match result request arrow set verb, and then in parentheses and in quotes post. And we have to set 2 headers for this request. So first let's do the authorization header by running record match result request and then arrow set header and then in parentheses and in quotes authorization. And then the value for this authorization header will be the server password, and hopefully that will be that will contain the right value for the Lambda authorizer. And let's do the content type header by running record match result request arrow set header and then in parentheses and in quotes content dash type comma, and the value for this header will be in quotes application slash JSON. Then let's set the request content by typing record match result request arrow set content as string and then in parentheses pass in the request body variable. And finally let's send the request by typing record match result request arrow process request parentheses. And I made a typo here. This should be a capital M in record match result request. And to finish this method, let's wrap everything besides the call to clear timer at the beginning of the function in the hashtag if with GameLift hashtag and if compiler directive. So up here type out hashtag if with underscore GameLift, and then down here type hashtag and if. Alright, moving on, let's implement the handle process termination method by writing down here void a GameLift tutorial game mode handle process termination parentheses squiggly brackets, and as we wrote earlier, this function will be called every second starting from 5 seconds after begin play was called. So the purpose of this function is to periodically check for server process interruptions by GameLift. So let's check the status of the process terminate state member variable by writing if in parentheses process terminate state dot status, and then in squiggly brackets, if the status is set to true, then that means at one point the onProcess terminate handler function was at one point invoked by the GameLift service. So the first thing we will do in this case is clear some timer handles, because for this tutorial, if we get a server interruption, no matter how much time we have until the process is scheduled to end, we're going to end the game right away. So let's type get world timer manager parentheses dot set time, get world timer manager parentheses dot clear timer, and then in parentheses let's start first with the countdown until game over handle, and I want to clear a couple more timer handle variables, so let's copy this line and just paste it 2 more times. And then the next timer handle that we're going to clear is the handle process termination handle variable, because we shouldn't be calling handle process termination if we figure that the server process was interrupted. And lastly, let's also clear the handle game session update handle, because if the server is interrupted and we're about to end the game, then we don't really care about backfill requests or people joining the game anymore. Now let's set the latest event property in our game state to let the clients know of this interruption. So first let's initialize an fstring variable and call it process interruption message. Now the get termination time method is called in the event that the onProcess terminate handler function is invoked. Now this method can return a couple of values in the case where the function call was successful. It will either return a long value of -1, meaning that the server process can shut down at any time because the time when it is going to shut down is unknown, or it will return a long value representing the time in Unix epoch timestamp format in seconds when the server process is scheduled to shut down. In the case that the call to get termination time fails, then the termination time property in our process terminate state variable will still contain its default long value of 0. Now very quickly, I actually made a minor harmless typo earlier in this video with regards to setting the default value of the termination time property in the constructor of the fprocess terminate state struct. So let's go back to the GameLift tutorial game mode header file, specifically again up to the fprocess terminate state struct. And notice in the constructor that I set the default value for the termination time value to 0.0L. Get rid of the 0.0L and just have it as 0L. And I just realized that before, when it was 0.0L, that was a value of type long double. Technically this is okay, because when you assign a long variable, or when you assign a value of type long double to a long variable, all the numbers after the decimal point get truncated anyway. That's really the only difference between a long double and a long, is that a long double is a decimal, whereas just a plain long has no numbers after the decimal point. And for me, it's just a personal preference, but don't worry if you missed this for some reason, because I didn't point this out earlier, because setting this to 0.0L or 0L will technically make no difference in this tutorial. And just a fun fact, the only reason why the termination time property is of type long is that the get termination time method from the GameLift server SDK returns the scheduled termination time of the server process if there is one in a variable of type long. Now, the interesting thing is that in Unix epoch time format in seconds, the max value that a long variable in C++ can contain is equivalent to some date in 2038. So hopefully by then, the get termination time method will be modified to return a value of type long so that it can return values greater than the max value of a long by the time 2038 comes by. Luckily, Unreal Engine is already way ahead here because, as you guys will see very shortly, when we calculate how much time we have until the server process terminates, we will use a built-in Unreal Engine function that returns the current Unix epoch time format, we will be using a built-in Unreal Engine function that returns the current time in Unix epoch time format in seconds, but that function returns a value of type int64, which is similar to long in that it's much bigger than a long, and I could be wrong. Definitely correct me if I'm wrong in the comments below, but I believe the max and min values for a variable of type int64 are the same as the max and min values for a variable of type long. So with that said, let's go back to the GameLift tutorial game mode C++ class, and depending on the value of the termination time, let's set the process interruption message accordingly. So write if in parentheses process terminate state dot termination time less than or equal to 0L, and then squiggly brackets. And in this case, let's set process interruption message equal to, in quotes, server process could shut down at any time. Now, if the termination time is a value greater than 0, then that means that the get termination time method returned a time value in Unix epoch format in seconds. So let's calculate the difference between the termination time and today, right this very moment when this method is called and reaches this point in the code, and store that in a variable of type long. So type out else, and then in squiggly brackets, long time left equal process terminate state dot termination time, and then we're going to subtract the current time in Unix epoch seconds. So the method that returns that, the current time in Unix epoch seconds, is fdate time now parentheses .to Unix timestamp parentheses. And you theoretically could make this time left variable of type int64, since the datetime now to Unix timestamp method returns a variable of type int64, but I decided to make it of type long just to keep consistent with GameLift's get termination time method. Now let's set process interruption message equal to fstring printf, and then in parentheses pass in text, and then in parentheses pass in quotes server process scheduled to terminate in %LD space seconds, and then comma time left. Now, for those who may be a little confused at this line of code we just wrote, the printf method is needed here because there is no standard straightforward way to convert a long variable into an f string, and the %LD is what's called a custom format placeholder for a value of type signed long, hence why it's %LD instead of %LU, because %LU is a placeholder for unsigned longs, so only positive longs. But by default, variables of type long are signed. Now, am I expecting the time left variable to ever be negative? Usually no, but there may be very rare instances when the server process is scheduled to shut down before this method gets called. So in that very rare case, we would need to format the string to expect both positive and negative long values. Then once the process interruption message is set, let's set the latest event property in the game state. So let's do a null pointer check on the game state by typing if in parentheses game state not equal null pointer, and then in squiggly brackets let's cast the game state to a GameLift tutorial game state pointer by typing a GameLift tutorial game state pointer GameLift tutorial game state equal cast, and then in cast, and then in carets a GameLift tutorial game state, and then in parentheses passing the game state. Then do a null pointer check on that by typing if in parentheses GameLift tutorial game state not equal null pointer, and then in squiggly brackets now we can set GameLift tutorial game state arrow latest event equal to process interruption message. And lastly, let's call the end game method 10 seconds from now by typing get world timer manager, and then in parentheses dot set timer, and then in parentheses pass an end game handle, comma this, comma ampersand a GameLift tutorial game mode double colon end game, comma 1.0f, comma false because we don't want this function to be run on a loop periodically, comma 10.0f because we want this function to be called 10 seconds from now. Now let's move on to the last timer delegate function, handle game session update. So right down here, void a GameLift tutorial game mode double colon handle game session update, and then in parentheses squiggly brackets. And this function, as we wrote earlier, will be run once a second approximately, and the purpose of this function is to constantly check if the game session has been activated yet, and then later on in this video it will be further improved upon to check if the game session's backfill request has been fulfilled yet. But to check if the game session has been activated yet, we're first going to check our game session activated flag, because once we know that the server process is hosting a game session for the very first time, we're going to set the game session activated flag to acknowledge that we know that there is an active game session. In response to that, we will quote unquote start the game, which in this tutorial just means running the countdown function every second and calling the pick a winning team function in approximately 4 minutes. So let's check if we already know that a game session started, if one ever did start, because we're not going to start the game multiple times, we're only going to start it once. So type if in parentheses not game session activated, and then in squiggly brackets, if we don't know if a game session started, then let's check if one started by seeing if the onStart game sessions handler function was ever invoked. And luckily we can do that through the start game session state memory variables. So right, if in parentheses start game session state dot status, and then squiggly brackets. And like I just said, let's set game session activated equal to true so that we don't run this block of code inside this if statement more than once, since we will be calling set timer on a couple of functions, and one of those functions, like we just mentioned, was pick a winning team. So type get world timer manager parentheses dot set timer, and then in parentheses pass and pick a winning team handle, and then comma this, comma ampersand a GameLift tutorial game mode double colon pick a winning team, comma 1.0f, and this parameter doesn't really matter because the next parameter is going to be false, since we only want this function to be run once after a delay, not necessarily repeatedly on a loop. And then the last parameter will be when we want this function to be called. So like I mentioned before, we initialized the remaining game time variable in the constructor to be 240 because that is about 4 minutes in seconds, and that's when we want this function to be called. We want it to be called in 4 minutes because that's how long we want our game to last approximately. So type out in parentheses the word float, because we need to cast the variable to type float, since remaining game time as I type it out is of type int. So, but this function takes in a float for the last parameter. And lastly, let's call set timer on the countdown until game over function as well. So type get world timer manager parentheses dot set timer, and then in parentheses pass countdown until game over handle, comma this, comma ampersand a GameLift tutorial game mode double colon count down until game over, comma 1.0f, and this time this parameter does matter because the next parameter will be true, because we do want this function to be called repeatedly, approximately once a second, comma, and then for the initial delay before the function is called for the first time, we're just going to make this 0.0f because we want this function to actually be executed immediately. And lastly, let's implement the last function we defined, which was the response handler function for the HTTP request to the record match result API endpoint. So type void a GameLift tutorial game mode double colon on record match result response received, and then in parentheses pass in HTTP request PTR request, comma HTTP response PTR response, comma bool b was successful. And then in squiggly brackets, we're not actually going to do anything with the response. Basically, the point of this method is to just know when the request to the API finished, whether the call succeeded or not, whether the Lambda function actually wrote to DynamoDB or not, even though it usually will. And once we know that, let's call endgame in 5 seconds by typing get world timer manager parentheses dot set timer, then in parentheses pass in the endgame handle, and then comma this, comma ampersand a GameLift tutorial game mode double colon end game, comma 1.0f, comma false, comma 5.0f. And one more correction that I want to make, it's just a minor harmless preference thing, but scroll back up to the handle process termination method, specifically where I calculated the value for the time left local variable. I personally prefer to do explicit cast because, like I said before, the toUnix timestamp method returns a value of type int64. So after doing the subtraction operation and storing the difference in a variable of type long, an implicit cast is performed to convert the value to a long in the end, but I just prefer doing explicit casts so that it's clear to the reader of the code that at least one of these two values is not of type long. So to do an explicit cast, let's enwrap this whole thing to the right of the equal signs in parentheses. So process terminate state.termination time minus update time now to Unix timestamp. Just put that all in parentheses, and then before that, after the equal sign, add another pair of opening and closing parentheses and type out the name of the type that you want to cast this to. So in our case, it's long. And I know this is kind of weird because, again, it is mainly just preference. There's nothing wrong with an implicit cast, it's just an explicit cast can help with readability or debugging here and there. So even if you didn't have this explicit cast, the implicit cast will work just fine, as it usually does in most cases. Okay, with all of that said, we are now ready to build the project once again. Now make sure to just do a quick scan of the code, double check for small typos here and there just in case, because the code we just wrote in the game mode class is not really testable in the Unreal Engine editor. So we're going to just go straight to compiling the server to make sure that there are no compiler errors. So for the solution configuration up here in this drop down menu, on the top left, make sure you have development server selected. Keep Win64 selected for your solution platform. And then once you have those options selected, go to your project on the right side and then right click it and select build. And once the server is finished compiling, assuming with no errors, let's go back to the Unreal Engine editor and tinker with the packaging settings really quickly before we package the server. So go up here to the top left corner, go to File, and then go to Package Project, and then where it says build target, make sure that you have GameLiftTutorial server selected. I believe it should be selected since we just built the project in the development server configuration in Visual Studio. Once you have that selected, click on packaging settings. And in here we're going to do a couple of things. First, scroll down to where it says additional non-asset directories to package for dedicated server. It might be a little cut off at the end, so let's maximize this window so that you can better see it. And essentially, similar to the client, we need to package the URLs folder containing the text files because the server will be relying specifically on the API URL text file, since the record match result method is on the same API that hosts other methods that the client mainly uses. Again, I recommend in a production application to separate the server and client Lambda functions into two separate APIs, with the one for the server to be in a private VPC network, but that is outside the scope of this tutorial, so let's just click on the plus button here to add a new non-asset directory to package for the dedicated server, and then click on the three dots, and let's in this file explorer like window, let's find and select the URLs folder. According to the path, it seems that I'm actually already in the folder, so I can just go ahead and click on select folder. Probably remembered from when we did the additional non-asset directories to package, probably just remembered that same folder that we were in before. And lastly, I also want to check in the project section that the checkbox for the include debug files option is ticked off, because in order to make the server build upload go faster, we can reduce the file size of the dedicated server build, and debug files generally are in the form of PDB files, and those can take up a lot of space, so turning this flag off can be good for that purpose. Now, as long as you have the PDB debug files locally, you can always remotely connect to the EC2 instance that's hosting your server processes and dump the log files from there onto your local machine so that you can better read the logs. The same thing applies to, client builds that you distribute to other people. That's why we also turn this option off for client builds as well, so to make them smaller, and if you want to read if you want to read logs from outside client builds, those people can send you their logs and then you can read them on your local machine. Because the PDB files are mainly used for better understanding log files, tracing them, and debugging them, because without the PDB files, the logs don't show as much information. It's kind of hard to explain, and maybe even a little bit outside of my scope and may require further research to better understand. And whenever you build the project in Visual Studio for whatever configuration and platform, the PDB file for that configuration and platform usually gets built as well, along with the main executable and other files, and those can all be found in the local projects directories binary folder. They can be found in the local projects directory, specifically the binaries folder. So keep this option toggled off, and we can now close out of here. With all of that said about reducing the file size of the server build, before we finally package the server, let's go to File Explorer, specifically where the local project directory is located, and go inside the Windows Server folder, which is where we are putting the package server build files in, and let's just delete everything besides the stuff that we need for GameLift. So don't delete the VC redistributable file, and don't delete the install.bat file, but let's delete everything else. So these text files, go ahead and delete those. The server executable, the GameLift tutorial folder, and the engine folder, just go ahead and delete those as well. And the reason I want to do this, and I'm not sure the reason behind this or if it's even 100% correct, but we've done many things since the last time we packaged the server, including disabling plugins and not including debug files, which will save us space. But if we just package the server as normal without deleting the old build files, then those removal of files that I just mentioned, like the disabling of plugins and not including debug files, don't get applied. Files get overwritten when repackaging, but not deleted, as far as I know. So I want to delete those files and folders just to be extra safe and get a brand new fresh build. But of course, keep the old files that we added in addition to the package build, like the install Windows batch script and the VC redistributable file, because you need those once again when you upload the server build to GameLift. You need these two files to be executed so that the environment in the EC2 instance has all the prerequisites for running an Unreal Engine server executable. And by the way, again, all of this, just want to reiterate, is due to the fact that we are trying to reduce file size to make the server build upload faster. When we package the server again with the backfill code changes, we won't do this. We won't go in the file explorer and delete files, because at that point the main thing that is getting rebuilt is the server executable. With all of that said, we can go back to the editor and finally package the project. So go to File on the top left, go to Package Project. Again, reiterating here, for the build target, make sure you have GameLiftTutorial server selected, and for the build configuration, make sure you have development selected. Now, you don't necessarily have to have development selected. You can also have any of these other configurations selected. You can even have shipping selected, but just keep in mind with shipping, I could be wrong about this in case it changed, but if you choose the shipping configuration, then log files won't be generated. As for the debug configurations, they just have some special stuff associated with them in terms of with debugging with Visual Studio, I believe, and the test configuration, I'm not too familiar with that. But again, development configuration and server target for this tutorial. Once you have those selected, go to Windows and then select Windows 64-bit to package the server in the Windows, or for the Windows 64-bit solution platform. Make sure for the folder you want to package the project to, make sure you have your project directory selected, and then click on select folder. And if you want to see the logs of the packaging, then just click on the show output log button here on the bottom right corner of the screen. Once the server is finished packaging, let's open up command prompt so that we can upload the server build to GameLift. Now, I know in an earlier part of the tutorial I tested the server build against GameLift local to make sure that the server on a very bare bones simple level was functioning and not crashing. However, the reason why I'm not going to do that in this part of the tutorial is, one, to save time and make the tutorial go a bit faster, and two, a lot of the GameLift features that we were testing involve matchmaking, which, as far as I know, but correct me if I'm wrong, GameLift local does not have heavy support for testing that right now. So let's go ahead and upload the build to GameLift. Hopefully your AWS CLI is still configured to the same user credentials that you used last time. If so, just run AWS configure if you want. But my AWS command line interface is already configured, so I'm not going to run AWS configure again. But if you at one point change your AWS CLI configuration, and go ahead and run this. But I'm going to just jump straight to uploading the build by typing AWS GameLift upload-build, and then this function will take in a few parameters. The first one will be --name, and we're going to keep the name of this build the same as the build from last time. So GameLift tutorial, and then the next parameter will be --build-version. Now, the value for this parameter will not be the same as last time. Last time it was 1.00. Now I'm going to make it 1.0.1. The next parameter is --build-root, and this is basically the absolute file location path of your server build directory, which should be the same as last time unless you move the project directory since then. But for me, it's going to be in quotes because my path has a space in it. So in quotes c:/users/Chris/documents/Unreal space projects /GameLift tutorial/Windows server, and then a closing quote. Now again, this path will be dependent on where you put the packaged server build directory, so this will most likely be different for you. The next parameter is --operating-system, and this will have a value of Windows_2012 in all caps because we are uploading a Windows server build. And then the last parameter that we're going to use is --region, and the value for this will just be the code of the region that you're operating in. So for me, it'll be US-East-1. Once you have all that typed out, go ahead and press enter. By the way, this command will be in the description below. Once the server build has finished uploading, let's go to the AWS Management Console. Make sure you're logged in, and under where it says Find Services in the search bar, type in GameLift and select on the option labeled Amazon GameLift. And then from here, find the server build with the name and version that you specified in the AWS GameLift upload build command. So in my case, my build was named GameLift Tutorial, and it was version 1.0.1. So click on that once you find it, and click on the name specifically, so that'll take you to this build page. And from here, in order to create a new fleet for this build, click on where it says Actions, and then from the drop down menu, select the option labeled Create Fleet from Build. Now in this create fleet page, we're going to follow a lot of what we did in a previous part of the tutorial with some minor differences and additions. So first, for the name of the fleet, we are going to follow a little different naming convention than what we used last time, since this is our second fleet now, and it's good to have a way to differentiate between fleets, similarly to how we have different versions for the server builds. Although for the builds, unlike what I just did, you should probably have different names for each build of the same game even. But for this fleet, let's go ahead and name it the name of the build first, so GameLift Tutorial, the name of the build that it's built off after, and then space the instance type that this fleet is using. So I'm getting a little technical here, but if we scroll down, we're using currently the free tier eligible instance type, which at the time of recording this video is c5.large. So let's just type out c5.large, and then space, I want to type out the operating system of this fleet. So in our case, it's going to be Windows. So type out Windows, and then what kind of fleet is this? Is this on-demand or spot? Like we did in a former part of the tutorial, this will be a spot fleet to make the fleet a little cheaper to operate in terms of price and cost. And then I'm just going to call this, and then I'm going to do space fleet to signify that this is a fleet. And then after that, the version number of the build that we're building a fleet off of. So I'm going to call this, or I'm going to type 1.0.1 because in my case that is the version of the build that we are building a fleet off of. And as I just mentioned, this will be a spot fleet, not an on-demand fleet, because spot fleets are generally significantly cheaper than on-demand fleets. So by where it says fleet type, select the drop-down menu that currently says on-demand and select spot. Now let's keep the rest of the default fleet settings for the fleet details section as well as the instance type section. So scroll down to the process management section, and under where it says server process in bold, let's configure a server process to run on each instance in this fleet. So for the launch path, once again, this value should be the path of the server executable in the binaries folder in our package build. The game folder labeled here is synonymous to the Windows Server folder in our local project directory. So type in here the path of the server executable in the binaries folder relative to the Windows Server folder. So in my case, it will be GameLift Tutorial / not / binaries /win64 / GameLift Tutorial server.exe. Now, if you're not sure, you can always go to your local project directory in File Explorer, specifically the Windows Server folder. Then go to the folder named after your project. In this case, it's GameLift Tutorial, and then the binaries folder, and then the Win64 folder. And in here, you can go up in the file path bar here and copy the path up to, but not including the path of the Windows Server directory. And then you can paste it in here, plus a slash, and then the name of the server executable with the file extension. And for the launch parameters, remember last time we specified a port parameter for the server process to run on. Now, we will be defining a password parameter in addition to that so that the server process can make a successful request to the Lambda authorized record match result API endpoint. So type out -port equals, and we'll set this equal to 7777, and then space -password equal, and then the value you used in the Lambda authorizer function for the record match result API endpoint. In our case, we made the value to check the authorization header for dummy. So I'm going to write dummy, but make sure you write the value that you used to check incoming request authorization headers for. And then once you have that all typed out, click on the green check mark button to save your changes. Now for this fleet, I'm only going to specify one server process because I want to test the ability to run multiple game sessions on the server processes running on a specific port, so that we are correctly terminating the game session and shutting the server process down so that the process can be started back up and host a new game session on that port. This is also why we left the value for concurrent processes for this server process at its default value of 1, because we don't want multiple server processes running on the same port. But now we have to open up that port 7777 to incoming player connection. So to do that, scroll down to the EC2 port settings section and click on add port settings to add a new entry in this port settings table. And for the port range, since we only specified one server process to run on port 7777, let's just type here 7777. For the protocol, change this from TCP to UDP, and for the IP address range, type in 0.0.0/0 and click the checkmark button, the green checkmark button, to save your changes. And lastly, make sure that the protection policy is set to the default value of no protection, because later when we test the server, we are going to scale the fleet down manually to simulate a server interruption event in the middle of a game. And full protection only protects server processes from interruptions caused by fleet capacity scale down events, not failed health checks and spot interruptions. So with that said, let's go ahead and create the fleet by clicking on the initialize fleet button. And if you remembered from last time, a fleet takes a while to get set up and fully activate, so you can track the status of your fleet in the events tab. So click on where it says events, while occasionally clicking on this refresh button to see the latest events. In the meantime, feel free to pause the video and come back in around 20 minutes, because that's usually how long it takes for the fleet to fully activate. Once you guys see this fleet scaling event after refreshing the events, let's go ahead and refresh the page to see the other parts of the UI be up to date, like the status, number of active instances, and number of active servers. And before we test the server by running a couple of clients, let's change the fleet destination inside of the queue associated with the matchmaker. So go to where it says fleets up here by where it says Amazon GameLift, and click on the option labeled queues, and then go ahead and click on your queue, and then from here click on the actions button and select the edit queue option. And from here, under where it says destinations, click on the pencil button to the right of the only entry in this destinations table, and all we are going to do is replace the fleet for this entry with the new fleet we just made. So under where it says fleet or alias name, just click on the value, and you should see this drop down menu appear with all the fleets in the region specified in this entry. and let's just select the new fleet that we just made. Now you should see in parentheses to the right of the fleet ID the name of the fleet. So by looking at the name of the fleet, you should know which fleet was the one you just made. So select that, click on the green check mark button to save your changes, and then click on the submit button. And then once that's done, we now have to repackage our client. So go to Unreal Engine, specifically File on the top left corner, go to Package Project, and this time for the build target, select GameLift Tutorial instead of GameLift Tutorial Server, because we're building the client this time. And then go back to File, go back to Package Project, and then go to Windows and select Windows 64-bit, and then make sure in this File Explorer like window that you have the project directory selected, and then just go ahead and click on select folder to begin packaging the client again. Once the client is finished packaging, let's go ahead and open up a couple of clients so that we can test our server. So go to File Explorer, specifically where our project is located, and go to the Windows No Editor folder, and from here just double click the GameLift tutorial application file twice so that you can open up two clients at once. And remember from the last part of the tutorial that we open up the executable in a way so that it would take up about half of the screen approximately. So let's just move those two windows side by side, and then in each client just log into a different account. So I'm going to log into a FlopRAM account on this end, and then the other client I'm going to use Google Sign-In. Again, you can use Google Sign-In for both accounts. You can use Cognito Sign-In for both accounts, just as long as you're signing into two different accounts. So just going to log into the account, and then once you're logged into both clients in different accounts, just go ahead and click join game in both of those clients so that we can start looking for a match on both clients. And then after a certain period of time, we should both get into a match, and as you can see, it seems like it's working. We have the countdown timer going. If I move on one client window, you see the exact same movement replicated in the other client window. And if I do Alt Tab to move between other client windows, I can also start controlling this guy, and you see the movement is also replicated on the other guy's end as well. And as you can see, also the other parts of the UI, the ping, the team name. Remember, we made aliens blue and we made cowboys red, and right now the teammate count on each guy's team is 1, which makes sense because we only have 2 people currently. You can theoretically have 4 players in one game at this point. You kind of just have to click join game on all 4 of the clients really fast. Otherwise, there's a pretty high chance they won't get in the game, just because GameLift's Flex Match service works really fast to create potential matches. And since we have one server process running right now, we have to wait until, we have one server process running on one instance right now. We have to wait until the game is over to get another match going, but that's fine because right now I kind of want to just test to make sure that the game can complete its full lifespan. So by the time this game ends in about 140 seconds, we should see which team won at random. It's about 50-50 odds, and then after that we are going to check DynamoDB for the updated player stats and game stats. But in the meantime, we can actually go to the Amazon GameLift dashboard. Let's go back to the fleet, so click on queues and select fleets from the drop down menu. Let's select the fleet that we just made, and as you can see in the game sessions tab, we currently have an active game session. Ignore the game session underneath that. I was testing this earlier as well, but click on the ID value to get details about the players in the game. And right now, as you can see, we have 2 active player sessions, which makes sense because we have 2 active players in the game. So if I bring both those windows back up, if I bring both those windows back up, we have 2 active player sessions in the game. So that makes sense. Now Remember, we also enabled the escape key, but we're going to test that when we join another game session. So let's just let this game session on the server process run its course. So we got about a minute left until this game session is over, but we will later test on other features of the game, such as in the case of a server interruption, since I made a big deal about that. We'll also test the escape key to make sure that clients can go back to the main menu. And when clients leave, like I mentioned before, we mark their player session as completed for backfill purposes. And right now, actually, believe it or not, and you'll see this later, when a player leaves the game and their player session is marked as completed, since we don't update the matchmaker data, technically a player that left the game, their player stats will still get updated, which I guess kind of makes sense, but just keep that in mind that you don't necessarily have to be in the game for your player stats to be updated, because your player stats only have to be updated if the player is in the matchmaker data. So as you can see, the game's over. You and the Cowboys lost. You and the Aliens won. So we should see. So as you can see, the client on the left side, their number of losses increased by 1, and on the right side, the number of wins increased by 1. And now, before I move on to checking the GameLift and DynamoDB dashboards, some people have asked me when you should repackage the client, because obviously if you make changes to the server that don't affect the client, you shouldn't have to repackage the client. But with all the changes we just made in the project, we kind of had to repackage the client in that case. So I'm not entirely sure when you need to and when you don't need to repackage the client. Now with that said, let's go back to the GameLift dashboard. And if we refresh now, you'll notice that the player sessions are in completed status. This makes sense because we terminated the game session. So if you refresh this page, you'll notice that the status of this game session is terminated. Even if we go back, you'll also see that the game session is in terminated state. Also, while we're here, also go to the events tab, click refresh. Make sure you don't see any messages with an error code, because sometimes that can happen if you shut down your server process, not cleanly, or you didn't call process ending, for example, and you just shut down your process randomly, stuff like that. And everything seems to look good here. So now, in a separate tab in your browser, go to the DynamoDB dashboard, specifically the tables page, and let's make sure that our tables are updated. So first, let's look at the easy one. Click on the players table, go to items, and right now, at least in my case, I only have 2 users. It's just easier to find the 2 users in that case, because these were the 2 users in the game, and as you can see, one of them has 1 loss and 3 wins, and the other one has 3 losses and 1 win. Now let's check the match results table, because that should have been the other table that was updated as a result of a game ending. So as you can see, we have 3 entries right now, so we kind of have to figure out which one was the one that was recently made. So trying to look here, it could really be any of them. I'm just going to click on this first one, see if I get lucky. Let me expand the players. So okay, it probably wasn't this one, and the reason I can tell is because the skill attributes of each of these players are 50 and 50, meaning at one point they had a 50% win-loss ratio, which was not true in that case. I remember one player had 1 loss and 2 wins, and the other one had 2 losses and 1 win. So one player's attribute should be like 66%, and the other player's skill attribute should be like 33. So let's just expand these. So let's see, are these guys, oh, sorry about that, guys, my mouse is lagging right now, and we gotta expand all of these. So this is also 50-50, so I don't think it's this one either. Let me do the last one. So this is probably going to be yeah. So all right, this makes sense. So we had we had one player on the Cowboys, and that makes sense. So the winning team in this case was the Aliens. I do remember that. And that player was the player on the right with the higher skill attribute, which makes sense because if you remember before we joined the game, the player on the Aliens was on the right side, and they had, I believe, more wins than losses, hence the higher skill attribute value. And the player on the Cowboys was on the left side of the screen, if I'm not mistaken, and that player had less wins than losses, so obviously that player's skill attribute value will be lower. Alright, now let's go back to the clients and make sure that we can run another game session on a server process on the same port. So go ahead and click join game on both of these clients, and as you will notice, we are going to be looking for a match, and it's actually going to take, it's not instant anymore because as you can see now we have actual skill attributes. See, there was a little delay. Normally it would be instant, but because now the skill attributes are farther and farther away from each other, the rule set has to now apply its expansions on the fair team skill rule to get these players in a potential match. So if I go in here, so we got one guy in the Alien, one guy in the Cowboys, actually same teams as before, ironically. And what was I going to say? Okay, so one thing I want to test is, let's go back to the GameLift dashboard. So let's go back here and let's go to the game sessions tab. Let's click on refresh, and as you can see, we now have a new game session, a new active game session on the exact same IP address and port as the last game session. And if we click on this game session again, we should see two active player sessions. Now if I go back to the clients, so let's say so let me test the escape key now. Let me actually leave the game. So if I press escape, that should take me back to the main menu, and that seems pretty normal. And if I click on the refresh button, we should see one of those player sessions go to the completed state, because in our logout function we do terminate the player session. So that seems to be working normally. Now another thing I want to test is the pre-login function logic. You know, can we get into a game unauthorized? So, you know, when these clients are joining the game, normally they pass in a valid player session ID and player ID like we talked about earlier. But what if we just joined it just using the open level function, right? Because right now in our fleet settings, anyone can join the game, right? That's literally technically what we did. So let's copy this IP address and go back to that client that left the game, and then press the it's the tick mark, it's the key on your keyboard with the tick mark and the tilde. So just click on that inside this client and type out open and then I guess space, and then copy that value, colon the port you use for the server process. So in our case it was 7777, and press enter and see if you can join the game. See, you didn't join the server map. You don't see yourself in the third person example map right now. You actually went straight back to the main menu map. That's because the pre-login function is doing its job. And if you do that again, if you press the key with the tilde and the tick mark on it, then you'll get this, you know, terminal command prompt like thing again. And if you do open, same thing, copy the IP address and then do colon the port 7777, and this time add some options. Try to trick the server. Do like question mark player session ID equals dummy, and then question mark again player ID equal dummy, and then press enter again. You still can't join the server because, like we did in the pre-login function, it checks that the player ID and player session ID are legit, meaning they match up with each other, and the player session ID is that of a player session object that is currently active, currently reserved, not active, not completed, not timed out. And let's just quickly go back to the other client. Now I know that was really fast there. It kind of went back right when the game ended, but it said you and the Cowboys lost. So this guy, same team lost. I guess this client's just really unlucky. So the Cowboys lost. And if we go back to this client, the results won't update on this client because we're not reloading the main menu widget. But if we go back to DynamoDB, first off, let's refresh this table. And I believe this new entry is right here. I believe, I could be wrong. This is in the match results table, right? No, it's not this one. It probably is this last one. It's probably sorted in, I guess, ascending order in terms of date. I'm not really sure, to be honest. I don't think that's checkable. Yeah, see, because the skill attribute values are lower than last time, so this makes sense. Yep, Cowboys losing team again. Aliens is the winning team. That makes sense because the Aliens had the player with more wins and the Cowboys had the player with more losses. Now if we go to the players table, check on that as well, you'll see one player has 1 loss and 4 wins and the other player has 4 losses and 1 win. You just don't see it updated in that one client window on the right, because in that case we would have to reload the main menu widget to do that. Now the last thing that I want to test is what happens in the event of a server process interruption. So let's go back to the clients. Let's just open them both back up again. Press join game in both of them to get into a new game, and it's going to take some time. Actually, it's going to take even more time now because their skill attributes are even more away from each other. And third time in a row, I don't know why it is. I guess we could call it luck or something, but same teams as before. I mean, that's okay. That can happen sometimes. Let's go back to GameLift now, and let's go back to the fleet page. And as you notice, there's now a new active game session. But that's not what I'm testing. We've tested that works before. Go to the scaling tab, and then scroll down, and then where it says auto scaling policies underneath that, it says manually adjust the desired instance count to. So right now it's set at 1, so that makes sense because right now the desired instance count is 1 instance. So we have 1 instance running with 1 server process. So let's change that number from 1 to 0, and then click on the check mark button to save your changes and simulate a server process interruption via a fleet scale down event, because that's what we're doing. We're scaling down the number of instances in a fleet manually, and because we don't have full protection on, this server process should be scheduled to terminate. If you did have full protection on, then even in the case of a fleet scale down event, the server process would keep running until the game session was terminated. And as you can see, I know it's cut off here, but it did say server process scheduled to terminate in 269 seconds. So that means when we call get termination time, it was approximately, I guess, a little more than maybe about 4.5 minutes. Since it's 4.5 minutes after the time that the handle process termination method was able to catch the event, to catch that the on process terminate handler function was called. Let's actually go back now to the also, I forgot to note on this client, because the main menu widget reloaded, you'll notice the player stats was updated, but that's besides the point. Let's actually go back to GameLift. Let's go to game sessions. Let's refresh here. Everything's terminated now, and as you can see, all the player sessions are inactivated, which makes sense. And then go to the events page and click on refresh. So you see the scaling event, the one after the first one that initially activated the fleet, but the one after where you set the desired amount of instances from 1 to 0. And I actually wanted to come here more so just to make sure that there were no error messages, because again, if you don't clean up the server process cleanly before you shut it down, and for example you don't call process ending, then you will get an error message here. But everything seems to look good. And as you saw from those client windows, neither of the players' wins and losses were updated because the server process was shut down before the game ended, so the HTTP request to the record match result API endpoint was never made, and we can confirm this in DynamoDB. So let's go there, and we're in the players table, so let's refresh the entries in here, and as you can see in here, the wins and losses didn't update. And if we go to the match results table and you refresh here, the last time we saw it, before we joined that last game, there were 4 entries in here, and there are still 4 entries here. So the record match result endpoint was never called. And everything seems to look good here. So let's close out of those 2 clients, and I believe we are ready to code the final parts of the game mode class needed for implementing manual backfill. 4 minutes is a lot of time for players to join that game and fill it with more players to have a full 2v2 match, in the case where we don't get one upon the initial creation of the match. With all that said, let's go back to Visual Studio, specifically the GameLift tutorial game mode header file. And the first thing that we are going to add in here is at the very top of the file. Let's define our own custom enum. And basically an enum is a variable type with a restricted set of values. So a good example is if you had an enum type called fruits, and you can list the different values for that enum, which could include apples, bananas, pears, and whatever other value you want to include. Now, we need an enum for the different types of game session updates that can occur. So when something happens to a backfill request, whether it's positive or negative, we need a good descriptive way of knowing the event that occurred. And we also need some custom values for that enum as well, such as whether or not a backfill request is currently in progress. So let's write up here enum parentheses, and then underneath that enum class, and we'll call this enum update reason colon uint8, and then underneath that a pair of squiggly brackets. And the name update reason was chosen because I want this enum type to represent the reason why our game session was updated, whether it was something that we did in the game mode class or something that was set in the onUpdate game session handler function. Now in the squiggly brackets, we can define the different values that this enum type can take. So the first one is just going to be a default value because when the game session starts, I would consider that state as nothing has happened yet, no update happened yet beyond the game session starting. So let's write no underscore update underscore receive in all caps. And next I want a value for letting us know that a backfill request is currently going on. So let's write comma and then backfill underscore initiated. Now the next 4 values that I'm going to write for this enum are based off actual GameLift matchmaking backfill events. So when the onUpdate game session handler function is called, one of these next 4 values will be the reason that it was called. So let's type comma and then matchmaking underscore data underscore data. Now this becomes the reason that the onUpdate game session handler function gets called if there was a backfill request for this game session and it was recently fulfilled successfully, meaning we were able to find players to backfill this match and now they're in the process of joining the server. Now let's move on by writing comma backfill underscore failed. So this is the reason that the onUpdate game session function gets called if we had a backfill request and it just failed for due to an internal server reason. So then comma backfill underscore timed out. This is the reason that the onUpdate game session function gets called if you had a backfill request and it just timed out, meaning we couldn't match the backfill ticket for this match with other matchmaking tickets and use some kind of combination of the tickets in the pool and then this backfill ticket to create a new potential match to backfill this match with. So the last one, let's write comma backfill underscore canceled. So usually this is the reason for the onUpdate game session function to get called if someone, usually the server, manually stops the matchmaking backfill request. And the last value that I want to add to this enum type is a custom one to tell us when there is no backfill request going on, because the server currently has the max amount of players that it can hold. So write comma backfill underscore completed. Now moving down to the fUpdate game session state struct that we defined a while ago, let's now add some stuff to it. So first I want to make a member variable for that enum we just wrote. So type out uProperty and then parentheses eUpdate reason, and then we'll call this variable reason. And similarly to the fStart game session state struct, I want to keep track of the players defined in the matchmaker data from the game session object passed to the onUpdate game session handler function. So let's actually copy the player ID to player member variable of the fStart game session state struct, and just take this line here where we define the player ID to player variable, copy it, and then go back to the fUpdate game session state struct definition and just paste it in here. And let's go into the constructor and now give a default value for the reason member variable. So we're actually going to set it to equal to eUpdate reason no update received. And after that, let's go further down to the class definition, and let's add a member variable to the game mode class, specifically one of type fTimerHandle, for calling a function to stop backfill for this game session if an active backfill ticket even exists after a certain delay of time. I will explain later why we need this, but for now let's just type out uProperty parentheses fTimerHandle, and we'll call this variable suspend backfill handle. Now let's move down again and define some private member variables. But before we do that, I apologize because I should have paused and explained what we are coding now, which is backfill. And what is backfill? Backfill for games is getting new players to join existing game sessions that have room for more players. And in GameLift, there are two ways to achieve backfill. One is automatic backfill and the other is manual backfill. The reason that I did not want to settle for automatic backfill for this tutorial is that at the time of this video, I believe, correct me if I'm wrong, but automatic backfill only makes one backfill request at the very beginning of the game, if the game session does not have the maximum amount of players that it can contain. But after the start of the game session, backfill tickets are no longer made. So that is why I wanted to do a very simple and primitive example of going about manual backfill, so that you can get new players into your game throughout the entire lifespan, or as much of the entire lifespan of your game session. Now, this approach that we're about to do is not necessarily the best, but it can help teach some things about how backfill can be implemented for games hosted on GameLift. So with all that said, first, when there is an active backfill ticket for the game session to try to get players into this match, we need to keep track of the ID of that ticket for when we need to stop backfill for whatever reason. So I guess let's go down here and type out uProperty parentheses fstring latest backfill ticket ID. So as I mentioned earlier in the tutorial, when a match gets made successfully through flex match and a couple of matchmaking requests, a game session is made somehow, and in addition to that, the player sessions for the players are also made. And those player sessions start in the reserve state until the server activates those sessions by calling the accept player session method. Now, for this tutorial, I'm going to give the clients the benefit of the doubt in that they may take some time to connect to the server for whatever reason. It could be bad internet, for example. So I'm going to give the clients the full 60 seconds to join the game, because that is the amount of time that the player session stays in the reserve state until it times out. if the server never makes it active. So with that said, I'm going to define a couple of member variables. One is going to be a boolean that gets set to true when either on start game session or on update game session gets invoked by GameLift. In the case of on update game session, the reason has to be that matchmaker data was updated due to a backfill request being completed successfully. And in those cases, this flag gets set to true. Then I want to keep a counter going, which will be another member variable, for the amount of time we spent waiting for the newly matched players to join, which can go up to 60 seconds. And again, the reason for that is that we will periodically check if the amount of players we expect to be in the game is equal to the amount of players actually in the game. And like I said earlier, we will give the clients the benefit of the doubt, so this counter variable won't go past 60, but it can reach 60. So type out u property parentheses bool waiting for players to join, and then underneath that u property parentheses int time spent waiting for players to join. And as I just mentioned, we need a way to keep track of the players that we expect to be in the game based off of the matchmaker data, whether or not the on start game session or on update game session handler functions were called containing information about the newly updated set of players that are supposed to be in the match. And the players we expect in the game can always change, as when backfill requests are in progress, maybe a player, or sorry, when a backfill requests are in progress, because there can only be one backfill request for a match at a time. Maybe a player leaves and we have to redo the backfill request, or if the game is full, there are no backfill requests going on, and then someone leaves and we have to make a backfill request to fill for that player. So type out t map and then in carets of string for the key, and for the value it's going to be of type AWS :GameLift :server :model and :player. And we're going to call this member variable expected players. Now let's define a few new methods. First, we need a new delegate function for the timer handle that we just defined for suspending backfill after a certain amount of time in the game. So let's type down here u function and then parentheses and then void suspend backfill parentheses. And then let's define some reusable methods for creating and stopping backfill requests. So type out here f string, because we're going to make this method return a variable of type f string, create a backfill request, and then in parentheses this method will take in 3 parameters. First one will be of type f string, and this will be the game session ARN. Next one will also be of type f string, and this will be called matchmaking configuration ARN. And then the last variable will be of type tmap, and then in angle brackets, or as I like to call them carets, sideways carets, the key will be of type f string, the value will be of type AWS GameLift :server :model :player, and then this variable will be called players. Make sure that the type of the value in the map AWS GameLift server model player is in carets, not including the variable name like I just did. And then the next method will be for stopping the backfill request, because the method we just defined was for creating backfill requests. So this method will return a variable of type bool. It will be called stop backfill request, and then in parentheses this will also take in 3 parameters. The first 2 parameters are exactly the same as they were for the create backfill request method, so f string game session ARN, f string matchmaking configuration ARN, but the last variable will also be of type f string, and this will be called ticket ID. Alright, now let's go back to the GameLift tutorial game mode C++ class so that we can initialize these new member variables and implement these new functions that we just defined. Starting with the constructor all the way at the very top of the file, let's initialize a couple of those member variables that we just made with some default values. So starting with waiting for players to join. Let's give that a default variable of false. And then as for time spent waiting for players to join, let's give that a default value of 0. Now, before we implement these new functions, I just want to quickly modify some old functions, starting with the begin play function, because we have to actually add logic to that on update game session handler function, and that logic will be very similar to what we did in the on start game session handler function in terms of parsing matchmaker data in the event of matchmaking data updated. And also, before I do start coding in this function again, I just want to temporarily comment out these hashtag if with underscore GameLift, and down here the hashtag and if compiler directives inside this begin play function while we are writing code in this function again, so that we actually get auto complete suggestions while we are typing, as well as syntax highlighting, since I noticed earlier that was not turned on while writing code inside these compiler directives. Once we are done making changes to this function, we will uncomment these 2 lines of code, but for now go back up to the on update game session handler function, and let's get the reason for why this function was invoked by the GameLift service by typing auto reason and set that equal to update game session obj.get update reason parentheses. Then let's check what that reason is. Now again, it can be one of 4 values, so let's check for all 4 of them individually by writing if in parentheses reason double equals AWS double colon GameLift double colon server double colon model double colon update reason double colon matchmaking data updated, and then a pair of opening and closing squiggly brackets. Now I guess because we're writing a C++ Lambda function, that Visual Studio isn't picking up on the auto completion for the squiggly brackets for this if statement. And then underneath that, let's type out else if, and then in parentheses copy the condition from the if statement, because this condition for this else if statement will be very similar. Instead of AWS GameLift server model update reason matchmaking data updated, it's going to be AWS GameLift server model update reason backfill underscore canceled, and then add a pair of opening and closing squiggly brackets, and then underneath that add else if in parentheses. Once again, just copy one of these conditions from either the else if statement or the if statement, paste it inside this new else if statement, and for the update reason, everything after update reason double colon, just get rid of that and replace that with backfill underscore failed, and then a pair of opening and closing squiggly brackets. And then lastly, let's add a final else if statement, so else if, and then in parentheses, again copy one of the conditions from either the if statement or the else if statements and paste it inside here, and everything after update reason double colon, just replace that with backfill timed out, and then a final pair of opening and closing squiggly brackets. Now, in each of these cases, we will be setting the reason member variable in our update game session state struct variable equal to the appropriate equivalent value in our custom eUpdate reason struct. So for the first case, inside this if statement block, if the reason that this function was called is matchmaking data updated, then let's set state arrow reason equal to eUpdate reason double colon matchmaking data updated. And like I just said, we are going to pretty much do the same thing in each of these 4 cases, with some slight modifications of course. So copy this line of code where we set state arrow reason, and then paste it inside of these 3 else if statement blocks below it. So after pasting these this line of code in these 3 else if statement blocks, go back to the first else if statement block. If the reason that this function is getting called is backfill canceled, then let's set state arrow reason equal to eUpdate reason backfill canceled. So instead of matchmaking data updated, replace that with backfill underscore canceled. And we are going to make that slight modification in the other 2 else if statement blocks as well. So instead of setting state state reason equal to e update reason matchmaking data updated. We're going to set it equal to e update reason backfill underscore failed instead. And instead of setting state reason equal to e update reason matchmaking data update, we're going to set it to e update reason backfill timed out. Now, in the case where the onUpdate game session method was called due to a matchmaking data updated reason, then that means that the backfill request was completed successfully and we are expecting new players to join. But how will our game mode class know who those new players are? Well, that's why we're going to parse the matchmaker data inside the update game session object parameter past this function and get the player data from that matchmaker data and store it in the player ID to player member variable of our update game session state struct. Luckily, we already performed this exact logic in the onStart game session handler function, so let's scroll a little bit up and copy a snippet of code let's copy a snippet of code in here where we perform this logic, starting from the line that says fstring matchmaker equal to game session obj.get matchmaker data, all the way down to the closing squiggly bracket for this if statement. So the last closing squiggly bracket before the squiggly bracket that closes the onStart game session function. So again, just copy that snippet of code, scroll back down to the onUpdate game session function and copy that snippet of code in the if reason equals AWS GameLift server model update reason matchmaking data updated, copy in that if statement block specifically after where we set state arrow reason equal to e update reason matchmaking data updated. So yeah, go ahead and paste it in there. And so there are a couple differences between doing this logic in onUpdate game session and doing this in onStart game session. So for example, if we scroll up a little bit here, for me it's on line 102, but whichever line where you set state arrow matchmaking configuration ARN equal to JSON object get string field matchmaking configuration ARN. We don't need to keep track of the matchmaking configuration ARN in this update game session method, because in this tutorial we will be working with one matchmaker at all times. So the ARN will never change, and we already get it once in the onStart game session handler function, so that is enough for us. Therefore, we can get rid of this line of code that says, as I said before, state arrow matchmaking configuration ARN equals JSON object get string field matchmaking configuration ARN. So just get rid of that line of code. And also up here, if we go a little bit up, for me it's on line 96, but the line that says fstring matchmaker data equal game session obj.get matchmaker data, you'll notice another line of code with a red squiggly line underneath it indicating an error, kind of like the line we just got rid of before. That is because there is a small nuance difference between the parameters passed to the onStart game session function and the onUpdate game session function. In onStart game session, an object of type AWS GameLift server model game session is passed, whereas in onUpdate game session, an object of type AWS GameLift server model update game session is passed. So this is a pretty easy thing to fix. We just have to add another line of code before this line of code that sets matchmaker data. Basically, we have to take our update game session obj parameter and we have to get the game session object from it. So that's pretty easy. Just type out auto and we'll call this variable game session obj, and then we'll set it equal to update game session obj.get game session parentheses. And that is pretty much it for the begin play function. We can go ahead and uncomment those hashtag if with underscore GameLift and hashtag and if compiler directives now in this function. Okay, now let's scroll down to the init new player function, because now players can join not only at the beginning of a game session, but after a game session has been updated through a successful backfill request. So when we are assigning the team property in the player state, which is a little bit down below, let's check if the update game session state player ID to player map is populated first before checking if the start game session state player ID to player map is populated, because The update game session states player map, if populated, will be more up to date than the start game session states player map. So copy this snippet of code inside the if start game session state.player id to player.num greater than 0 block, and then paste it right above it, because the logic is almost identical. It's just that we're going to replace the start game session state variable being used with the update game session state member variable. So let's do that. For every occurrence of start game session state, replace it with update game session state. And I'm just gonna double click this word so that I can copy it, just to make this go by a little faster. So everywhere in this snippet of code here where it says start game session state, just go ahead and replace that start game session state word with update game session state. So I'm just going to do that, double click the start game session state word to highlight over it, and then you can replace it by just pasting it with the update game session state word. And with regards to the if statement below, the original one that checked if the start game session state player map was populated, just prepend the if with an else, because so that it says else if, because when a player joins a game, we will only be using the player map in either the update game session state or the start game session state. Now let's scroll down to the end game method, because I want to clear that new timer handle variable that we defined earlier. So just copy one of these lines of code that call clear timer, and then paste it after all these calls to clear timer, and then replace the value passed to the function call with suspend backfill handle. And that was the only change that I wanted to make to the end game method. Now let's scroll down to the handle process termination method so that we can do a couple of things. So first, let's clear the same timer handle variable that we just added a line of code to do in the end game method. So same thing as before, just copy one of these lines where we call clear timer, and then right below it just paste that same exact line and replace the value that you pass into the function called clear timer with suspend backfill handle. And second, if the server process gets interrupted for whatever reason and there's currently a backfill request going on, then we should try to stop that backfill request before trying to shut down the server process. So type out if in parentheses latest backfill ticket id dot len parentheses greater than 0, and then squiggly brackets. This is to check whether or not there's currently an ongoing backfill request. And then let's type out auto game session id outcome equal to aws double colon GameLift double colon server double colon get game session id parentheses, and then let's check if this call to get game session id was successful by typing if in parentheses game session id outcome that is success parentheses, and then another pair of squiggly brackets. And then let's go ahead and get the game session ARN from this game session ID outcome by typing fstring game session ARN equal to fstring, and then in parentheses passing game session ID outcome dot get result, and then parentheses. And then let's get the matchmaking configuration ARN from the start game session state struct by typing fstring matchmaking configuration ARN equals start game session state dot matchmaking configuration ARN. Now, as for why we retrieve the game session and matchmaking configuration ARNs, the reason is that if you remember from when we defined the stop backfill request method in the header file, it took in 3 arguments: a game session ID, a matchmaking configuration ARN, and a ticket ID. So let's call the method now by writing stop backfill request, and then in parentheses passing game session ARN, comma matchmaking configuration ARN, comma latest backfill ticket ID. And then let's surround this if statement block of code with the hashtag if with GameLift and hashtag endif compiler directive. So type out hashtag if with underscore GameLift, and then hashtag end if, where that if statement ends. And since we just called the stop backfill request method, let's actually implement that method. So scroll down to the bottom of the file and start by typing bool, because this function will return a value of type bool, indicating whether or not the call to GameLift server stop match backfill was successful or not, and then write a GameLift tutorial game mode stop backfill request, and then in parentheses, like we just talked about, this method will take in 3 parameters. They will all be of type fstring, the first one being called game session ARN, the second one being called matchmaking configuration ARN, and then the last one being called ticket ID, and then just add a pair of opening and closing squiggly brackets. And the first thing we are going to do in this method is make an object of type AWS GameLift server model stop match backfill request, because you have to pass one to a call to stop match backfill. So type out AWS GameLift server model stop match backfill request, and then we'll call this variable stop match backfill request. And then let's set some properties in this request object to the arguments passed into this function. So starting with the game session ARN, type stop match backfill request dot set game session ARN, and then in parentheses pass in tchar _2 _ANSI, and then in parentheses pass in star game session ARN. And then for the matchmaking configuration ARN, type out stop match backfill request dot set matchmaking configuration ARN, and then in parentheses pass in tchar _2 _ANSI, and then in parentheses pass in star matchmaking configuration ARN. And lastly, for the ticket ID, type in stop match backfill request dot set ticket ID, and then in parentheses pass in tchar _2 _ANSI, and then in parentheses pass in star ticket ID. Now let's actually call the method to stop the backfill request by typing auto stop match backfill outcome, set that equal to AWS GameLift server stop match backfill, and then in parentheses pass in the stop match backfill request local variable that we just made. And then let's finish this method by returning whether or not the call to stop match backfill was successful by writing return and then stop match backfill outcome dot is success parentheses. And then of course let's wrap this function code in the hashtag if with GameLift and hashtag end if compiler directive. So up here type hashtag if with _GameLift, and then down here type out hashtag end if. Now let's implement the method for creating a backfill request. So above this method, go ahead and type out fstring, because this method will return a value of type fstring, which will represent the ID of the ticket associated with the matchmaking backfill request for the match hosted in this game session. Now let's type a GameLift tutorial game mode create backfill request, and then in parentheses this function will take in 3 parameters, and the first 2 parameters will be exactly the same as the first 2 parameters in the stop backfill request function. So write fstring game session ARN comma fstring matchmaking configuration ARN, but the last parameter will be of type tmap, and then in angle brackets fstring will be the type of the key, and then for the value the type of that will be AWS hold on here, AWS GameLift server model player, and it will be called, the parameter will be called players, and then just add a pair of opening and closing squiggly brackets. Now The reason why you need a parameter of type tmap with a f-string key and a GameLift server model player object for the value is that when you make a backfill request, you have to define the current players in your match manually. GameLift won't know the players currently in the match, so the server has to figure out who is currently in the match if it wants to make a backfill request. And then using those connected players, you can make a backfill request to fill the match with new players. Moving on to the actual logic of this function, let's first define an object of type AWS GameLift server model start match backfill request, because you need to pass one to a call to AWS GameLift server start match backfill, and that is how you initiate a backfill request for the match. So type out AWS :GameLift :server :model :start match backfill request. We'll call this variable start match backfill request. And then let's set a couple of properties in the request object, starting with the game session ARN. So type out start match backfill request set game session ARN, and then in parentheses pass in tchar _2 _ANSI, and then in parentheses again pass in star game session ARN. And then for the matchmaking configuration ARN, type out start match backfill request set matchmaking configuration ARN, and then in parentheses pass in tchar _2 _ANSI, and then in parentheses again pass in star matchmaking configuration ARN. Now let's set the players inside of the request object by iterating through the map passed in and adding one player object to the request at a time. So first write out for, and then in parentheses auto ampersand alem, and then colon players, and then a pair of squiggly brackets. And then in this for loop, let's first get the player object from the key value pair that we are iterating on by writing auto player obj and set that equal to alem.value. And add that player object to the request by typing start match backfill request dot add player, and then in parentheses pass in player obj. Now we have everything we need to make a backfill request, so let's call the start match backfill function by writing auto start match backfill outcome equal AWS :GameLift :server start match backfill, and then in parentheses pass in the start match backfill request object. And if the call to start match backfill was successful, then let's return the ticket ID associated with the newly created backfill request. So write if in parentheses start match backfill outcome that is success, and then parentheses, and then a pair of opening and closing squiggly brackets, return start match backfill outcome dot get result parentheses dot get ticket ID parentheses. But if the call to start match backfill was not successful, then let's return an empty string to indicate that something went wrong by typing else, and then in squiggly brackets return double quote with nothing inside those pair of double quotes. And lastly, let's wrap all of this code inside the hashtag if with _GameLift and hashtag and if compiler directives. Alright, and the next function that we are going to implement is the suspend backfill function, and this is a function that will get called in approximately 180 seconds from the start of the game, because player sessions by default have about 60 seconds in the reserve state until they are either set to be active by the server or until they time out. So as a result, because in this tutorial I'm going to stick to the default 60-second time period, not going to change that. So in theory, once new players are matched to this game session through a successful backfill request, those new players have 60 seconds to join the game. Therefore, I don't want players to get into the game when there's less than 60 seconds left in the game, because theoretically they may not have enough time to join the game. I'll talk about why this matters a little more later in in the video, but for now, just right above this create backfill request that we just finished writing, void a GameLift tutorial game mode suspend backfill and then parentheses and a pair of squiggly brackets. Now, since this method is meant for stopping a backfill request if there is an active one currently going on for this game session, let's clear the timer handle for the handle game session update function, because once we get to that method very soon, that method will be modified to handle the completion of backfill requests, whether the outcome is good or bad. So we don't need to keep calling that method if there will no longer be definitively an active backfill request for the match. So let's write get world timer manager parentheses dot clear timer, and then pass into this clear timer function call handle game session update handle. And let's check if there is an active backfill request by checking the length of the latest backfill ticket ID member variable by typing if in parentheses latest backfill ticket id.len parentheses greater than 0 and then a pair of squiggly brackets. And if there is a backfill request in progress, then let's get the parameters that we need for a call to stop backfill requests. So first, let's get the game session ARN by typing auto game session ID outcome equal AWS GameLift server get game session ID parentheses, and then let's check if in parentheses game session ID outcome that is success parentheses and then another pair of squiggly brackets. And if the call to get game session ID was successful, then let's get the game session ID by typing fstring game session ID equal game session ID outcome dot get result parentheses, and then let's also get the matchmaking configuration ARN by typing fstring matchmaking configuration ARN equal start game session state dot matchmaking configuration ARN. Now let's call the stop backfill request method, but also check whether or not the call to GameLift stop match backfill was successful by writing if in parentheses exclamation mark, so not stop backfill request, and then in parentheses pass in game session ID comma matchmaking configuration ARN comma latest backfill ticket ID, and then a pair of opening and closing squiggly brackets. Because if the call was not successful, then let's try to cancel the backfill request again after a delay. Although the call to GameLift stop match backfill rarely fails, this is just an extra safe measure. So type out get world timer manager parentheses dot set timer, and then in parentheses pass in the suspend backfill handle, and then comma this comma ampersand the function, this suspend backfill function, so a GameLift tutorial game mode suspend backfill comma 1.0f comma false, because we don't want this function to be called repeatedly. We just want it to be called once after a delay, specifically a second, so the last parameter will be 1.0f. And just to be even more extra safe, in case the call to get game session ID fails, knowing that there is currently a backfill request going on, then let's do the same thing. Recall this suspend backfill method again after a second. So copy this line of code that we just wrote where we called set timer, and then for the if game session ID outcome that is success statement, right below its closing squiggly bracket, type out else and then squiggly brackets, and then paste that line of code inside that else block. And to finish this function off, wrap the code after the call to clear timer in the hashtag if with underscore GameLift and hashtag end if compiler directives. Now for the last function we are going to modify, which is the handle game session update method. This will be, in my opinion, the most complicated logic of code that we are going to write in this entire tutorial, because there are so many situations to take into account, including when a game session starts, when you are waiting for players to connect to the server, whether these are the first players in the initial matchmaking request that led to the creation of the game session, or new players in the backfill request for this existing match, and when a backfill request is completed, whether it succeeds or fails. Now again, if you are happy with the last version of this project that we just tested with no backfill, don't worry, because we will have a link in the description below to a separate branch in the GitHub repository for this project that contains only the code for what you saw in the last test session. However, we will also have a link in the description below to the project with the backfill code. So don't worry if you missed something while watching the video, because there will always be something on GitHub that you can refer to. Okay, with that said, let's scroll up to the handle game session update method and start with the case that we coded originally, when a game session activates. So a few things happen here. We set a boolean flag equal to true so that we don't execute this block of code inside this if start game session state.status statement more than once, and we initiate some timer functions to simulate the start of a quote-unquote game. Since we are doing backfill now, we need a way to keep track of which players that we expect to be in the game after the game session starts. A reference to a map of players defined in the matchmaker data from the game session object passed to the onStart game session handler function. That's why we defined the expected players variable in our header file earlier. So in here, let's just set expected players equal to start game session state dot player ID to player. And now that we are expecting certain players to be in the game, we need to set a flag so that the server knows that either the on start game session or on update game session handler functions was invoked for the reason that players are currently in the process of joining the server. So that's why we defined the waiting for players to join variable in our header file as well. So set waiting for players to join equal to true. Also, like I mentioned earlier, when a game starts, because we are sticking to the 60-second max time period for a player session in the reserve state, let's call the setTimer function in order to invoke the suspend backfill function to stop any active backfill request if there is one at approximately 60 seconds before the game ends. So in between these two calls to setTimer, type out get world timer manager and then parentheses dot set timer, and then in parentheses pass in suspend backfill handle, comma this, comma ampersand a GameLift tutorial game mode double colon suspend backfill, comma 1.0f, comma false, because we won't be calling this function on a loop, we're just going to call it once after a delay, comma, and then in parentheses float, because we're going to cast this number that we're about to pass into a float, because that number we're going to cast is going to be in parentheses as well, and that's going to be remaining game time minus 60. And then let's add a semicolon here at the end of the line. And again, the reason why it's remaining game time minus 60 is, like I just said, we are going to call this function at approximately 60 seconds before the game ends. And that should be all the code for this if start game session state.status case. Again, this is when the game session activates, and right away we are going to start our game logic through some timer functions, and we have indicated to the server that we are now waiting on players to join. So let's actually start writing the logic to deal with that. Underneath this if not game session activated statement, type out else if, and then in parentheses pass in waiting for players to join, and then a pair of squiggly brackets. And then if we are currently waiting for players to join, like I just mentioned, worst case, the players have up to 60 seconds by default from the creation of their player sessions to join the game. which usually happens right after a game session starts or a backfill request was successfully completed. Otherwise, if the players don't join in time, then their associated player session objects will change to timed out status. And at that point, if a client tries to connect to the server with a player session ID that is linked to a timed out session, then they will be rejected by the pre-login function. So let's check if we have been waiting for less than 60 seconds by typing if in parentheses time spent waiting for players to join less than 60 and then a pair of squiggly brackets. Now, if we have somehow been waiting for more than 60 seconds, then we can assume that one or more of the player sessions tied to the expected players that we are waiting on to join the game have timed out. So let's deal with this case by typing else and then sorry about that, in squiggly brackets, type out update game session state reason and set that equal to update reason backfill timed out. Now keep in mind that I am using an enum value that was used for a reason that the onUpdate game session handler function was called, but we can also use our custom enum for custom cases as well. And let's not forget to reset the waiting for players to join and time spent waiting for players to join variables to indicate that we are no longer waiting for players to join the game. So type out waiting for players to join equal false, and then time spent waiting for players to join equal 0. Now back up to the if statement where we haven't been waiting for at least 60 seconds, so we can't assume that the player sessions of the expected players have timed out yet. So what I want to do in this case is, because we can't assume that the sessions are timed out, we also can't assume whether or not we have any reserved player sessions, because the whole point of the code inside this else or inside this if waiting for players to join block is to wait until the game session has no more players in the reserve status so that we can create a new backfill request if needed with the players currently in the game, because we now know we are no longer expecting new players to join. So to check whether or not this game session has reserved player sessions, we need to call the describe player sessions method, similar to how we did it in the pre-login function, but unlike the pre-login function, instead of passing a player session ID, we will be passing a game session ID as well as a player session status filter to get all the player sessions in a game session that are in reserved status. So let's get the game session ID by typing auto game session ID outcome equal AWS :GameLift server get game session ID parentheses, and then we'll check if in parentheses get game session ID outcome that is success parentheses squiggly brackets, and if it is successful, then let's get the game session ID by typing out fstring game session ID equal fstring, and then in parentheses passing game session ID outcome dot get result parentheses. And then let's make an object of type describe player sessions request, because we need to pass one to a call to describe player session. So write out AWS :GameLift server model describe player sessions request, and then we'll call this variable describe player sessions request, and we'll set a few properties in this request. First, the game session ID, so type out describe player sessions request set game session ID, and then in parentheses pass in tchar_2_ANSI, and then in parentheses pass in star game session ID. And then let's also set the player session status filter that I just mentioned to only get back the player sessions in this game session that are in reserved status, because those are the ones we are going to be caring about here. So type out describe player sessions request dot set player session status filter, and in parentheses pass in quotes reserved in all caps. Can't make a mistake when typing this this word reserved here. And then let's actually call the describe player sessions method by typing auto describe player sessions outcome equal AWS :GameLift :server describe player sessions, and then in parentheses passing the describe player sessions request. And before I keep writing code inside this if game session ID outcome.isSuccess block, in the very rare case where you fail to get a game session ID, meaning that the get game session ID method call failed, then let's still consider that as time spent waiting for players to join. So underneath that if statement, type out else, and then in squiggly brackets set, or not really set, but increment the time spent waiting for players to join variable by 1. So time spent waiting for players plus plus. And then let's resume where we left off. So after calling describe player sessions, let's check if that was successful by writing if in parentheses describe player sessions outcome that is success parentheses and then a pair of squiggly brackets. And similar to what we did if the call to get game session ID wasn't successful, if the call to describe player sessions was not successful, then let's still consider that as time spent waiting for players to join. So type under here else and then in squiggly brackets time spent waiting for players to join plus plus. And then back if the describe player sessions method call was successful, then let's get the result of that function by typing auto describe player sessions result equal describe player sessions outcome dot get result parentheses. Now before we move on, we actually have to add some code now to the GameLift server SDK, specifically in the describe player sessions result class, because like I mentioned before, we need to get the number of player sessions in this game session that are in the reserve status. However, you will not know the number of player sessions ahead of time, and the describe player sessions result class has a method called get player sessions, which is what we use in the pre-login function, and that returns a pointer to an array of player session objects. The problem is that in C/C++, you cannot deduce the number of elements in that array from a pointer to one of its elements, because a pointer to an array is essentially the address of the first element in that array. So we need a new function to get us the number of elements in that array. But don't worry, this is actually really easy, because the describe player sessions result class actually has a private member variable representing the number of elements in the player sessions array member variable in the describe player sessions result class. So all we need is a getter function. So scroll up to the pre-login function, and inside the pre-login function on the line that says, for me it's line 228, but the line that says auto player sessions equal describe player sessions result dot get player sessions, and then in parentheses we pass in some local count variable, highlight just the get player sessions method. So I just double click anywhere inside the get player sessions word, double click that to highlight it, and then right click it, and then click on go to definition, and then you're going to see two symbol results found. Now don't double click the first result, even though they both will lead to the same class, but double click the second result, or actually you may not even have to. Yes, you can just single click it, but I'll double click it anyway. So the difference is that in a lot of these GameLift server SDK header files, you're going to see that they're split into two sections. One section is in the compiler directive if-def GameLift use std, and then the other half is if you're not using the GameLift use std macro. And that's usually because the GameLift server SDK again splits their classes so that, you know, sometimes do you want to use the standard C++ library, or do you not want to use the standard C++ library? That's at least how I interpret it. I could be wrong, because if I scroll to the bottom of this class to the member variables of the bottom half of the class that doesn't use GameLift or doesn't use the GameLift use SCD macro, you'll notice that like it doesn't use the standard C++ variable types like SCD vector and SCD string. Instead, it uses a char array and an object array. Although I do think, and maybe the GameLift team will look at this in the future, but maybe they should consider built-in Unreal Engine variable types like T arrays and F string, and maybe even other variable types like tmap and etc., because these variable types do have built-in functions. Like if this was a T array instead of a player session square bracket array, then you would have built-in functions like the num function to get the number of elements in an array, but they're not using that. So again, this is what we're dealt with. And like I mentioned before, so if we scroll back up to the get player sessions method, you'll notice that it returns an object of player session pointer, and that will return the m player sessions memory variable, which again is just this. So essentially, by returning this back to the user, or sorry, back to whoever calls the get player sessions function, you're just getting a pointer to the first element in the array. So you won't know exactly how many actual elements were added to that array. Yes, you have a predefined array of size max player sessions, which if you scroll all the way up, I believe it is 50 by default, I believe. Yes, you know that there's an array of 50 elements, but you don't know if all 50 of those elements are like actual values or garbage, because if you iterate an array that yes has been defaulted to have 50 elements, but you don't define every single one of those 50 elements, and you iterate through all 50 elements in those array, then you will get what is called undefined behavior. Because if you don't initialize each element in an array, then they can default to some garbage values. So that's why, again, we need this player sessions count variable, because we don't know how many actual elements are in the array. So let's just type underneath this last function in the class, in the bottom half of the class, in the when you're in the not hashtag if GameLift use SCD section. So right before the private member variables, type out inline int, and we'll call this variable get player sessions count parentheses, and then in squiggly brackets in the same line, since we're going to make this inline, just type out return and then m underscore player sessions underscore count, because again, this variable will actually represent the number of player sessions in the array. Because even though, again, the player sessions, or this m player sessions array is defaulted to the size 50, if we scroll up to the constructor, when we make an instance of this describe player sessions result class, that member variable is set to 0 by default. And then if I scroll down to the add player sessions array, the add player session method, you'll notice that every time you add a new player session object, the m player sessions count integer gets updated. So if you call add player session 4 times, then m player sessions count by the end of that will be 4, and then hopefully when we call get player sessions count, we'll get 4 back. And then go ahead and save your changes in this file by pressing Ctrl S or clicking on this little button up here that looks like a floppy disk. And I just want to point out one more thing while we are in this header file. If you are interested in looking at other files within the GameLift server SDK, note that by default the GameLift use SCD identifier, so up here, is normally turned off. So if you see header files split into 2 sections, hashtag if def GameLift use SCD and hashtag else, then look at the bottom code half of the file that is underneath the hashtag else compiler directive. That is not grayed out. Normally in Unreal Engine it is recommended to avoid the C++ standard library, as far as I know, because the Unreal Engine standard library, which includes so many things from T arrays, F strings, and other built-in variable types to U property, U function, and other components of the UE4 reflection system, because it is so much more portable. Alright, now let's go back to the GameLift tutorial game mode C++ class. And before we go back to the handle game session update method, I just want to quickly explain, while we are in this pre-login function, why we just went ahead and got the first element in the array referred to by the pointer returned by getPlayerSessions. Because you could argue that you don't know if there was even a value added to this player sessions array. And the reason why that I kind of just assume that is normally with the describe player sessions method, if you pass in a valid player session ID, then the method will normally not succeed. So in that case, this line, if describe player sessions outcome dot is success, would evaluate the false, and we wouldn't step inside this block of code. So generally, unless there's some bizarre scenario, if you pass in a valid player session ID, meaning there is a player session that exists that is identified by that ID, then the result returned from a call to describe player sessions will contain an array containing one player session object. If you want to be extra safe, now that we have this get player sessions count method, you can always add a check to see if there's actually one element in this array, but I am not going to do that. With all of that said, now let's go back down to the handle game session update method and continue where we left off. So after calling describe player sessions and getting the result, let's check how many player sessions are in the result that was returned by writing int count equal describe player sessions result dot get player sessions count parentheses. And if there are 0 sessions, then that should symbolize that either the beginning of the game session or the latest backfill request is quote-unquote complete in the server's eyes, because we went through the whole process of matching up players, whether it was at the beginning or in the middle of the game. And now none of the player sessions of the new players that we expect are in reserve status, meaning that we are no longer expecting new players to join. So in this case, write if in parentheses count equal 0, then in a pair of squiggly brackets set update game session state reason equal e update reason backfill completed. And let's reset the waiting for players to join and time spent waiting for players to join member variables by writing waiting for players to join equal false and time spent waiting for players to join equals 0. But if there are still reserved player sessions in this game session, then we are technically still waiting for new players to join. So we will just count that as time spent waiting for players. So type out underneath this if count equals 0 statement block, which I forgot a closing squiggly bracket for, sorry about that. So underneath that if statement, type out else, and then in squiggly brackets, just increment time spent waiting for players to join by 1 by using the ++ operator. And also one small change in the case where we have waited at least 60 seconds for players to join the game. So scroll down a little bit, so it should be in this very last else block here. So instead of setting update game session state.reason equal e update reason backfill timed out, I actually changed my mind. I want this to be e update reason backfill completed instead. Because I actually do want to preserve 4 of the custom values in the e update reason enum type for the for the on update game session handler function. And like I just said before, even if we end up waiting for the player sessions to time out by default, the same argument that we just applied before still applies here, whether we are waiting for new players to join from the start of the game session or in the middle from a successful backfill request. We are now no longer waiting for new players, even in this case. Alright, now moving on to the next case for this function. So if it isn't the very start of the game session or we aren't waiting for players, then let's check if our latest backfill request just succeeded by typing after this very last closing squiggly bracket before the closing squiggly bracket for the function else if, and then in parentheses update game session state dot reason double equals e update reason, double colon matchmaking data updated, and then a pair of squiggly brackets. And in here, let's do a few things. Let's clear out the latest backfill ticket ID field by typing latest backfill ticket ID equals a blank pair of double quotes, so nothing inside of them, because in this case the onUpdate game session handler function was invoked because the current backfill request for this match succeeded, meaning we were able to match new players to this match. So as a result, there is no backfill request anymore for this match in progress, since one just finished successfully. And then let's set expected players equal to update game session state player ID to player, because now the players that we expect to be in the game came from the matchmaker data that we got in the game session object from the last time the onUpdate game session function was invoked by GameLift. And lastly, we should be waiting for players to join now, because that matchmaker data should have newly matched players. So type out waiting for players to join and set that equal to true. So the next time this handle game session update function gets called, it will start executing the if waiting for players to join block of code above that we just wrote. And I just want to note, in case I did not note it earlier, that after this, if we go back up, after this if start game session state.status if block is executed, the next time the handle game session update method is called, it will go into the else if waiting for players to join block of code, similarly to, once again, if a backfill request succeeds and we go into this else if block of code, the next time the handle game session update method gets called, it will also go up into this else if waiting for players to join block of code. Now let's move on to the last case for this function, which is when a backfill request is not in progress because 1, it failed, or 2, we just finished waiting for players to join the game. So underneath this else if block, type out else if, and then in parentheses pass in update game session state reason double equals e update reason double colon backfill canceled, and then double pipes to signify the logical or operator, or update game session state dot reason double equals e update reason double colon completed. And then on the next line, to make this a little more readable, double pipe again, so or update game session state dot reason equals e update reason double colon backfill underscore failed, and then finally one last double pipe, so or update game session state dot reason double equals e update reason double colon backfill underscore timed underscore timed out, and then a pair of opening and closing squiggly brackets. Now let's move on, so if update game session state dot reason equals any of these e update reason enum values, then we know that there is no backfill request going on currently, because one, either the onUpdate game session handler function was invoked for a reason that the backfill request did not succeed for one of 3 reasons, including backfill canceled, backfill failed, and backfill timed out. Or there is no backfill request going on because we just finished waiting for players to join the match, hence the customly made backfill completed state. So because we know there is currently no backfill request going on, let's go ahead and clear the latest backfill ticket ID member variable by writing latest backfill ticket ID equals a blank string, which is just a pair of double quotes with nothing inside of them. And I also want to point out, in this tutorial, the server will not make a backfill request when one is currently going on, and that is exactly what this else if block of code is for, initiating a new backfill request if needed. And to do that, we first get all the player objects from the expected players map associated with the players that are currently in the game. And the expected players map will either point to the start game session state or the update game session state player map, and whichever one of those maps is used, because remember that when handle game session state is called, it can reach this block of code without successfully completing a backfill request. So in that case, expected players would point to the player map in the start game session state. But once there are completed backfill requests, successfully completed backfill requests for this match, expected players will point to the player map in the update game session state, because as we iterate through the players who are currently in the game, we get the associated player object from the expected players map, and theoretically there should not be a player in the server that is not a part of the latest matchmaker data associated with this game session, according to our logic. So let's get all the player states in the game currently by writing t array and then in carets a player state star and then player states, and then set that equal to get world and then parentheses arrow get game state parentheses arrow player array. And then let's make a local tmap variable for the players that could potentially be in a new backfill request that are currently in the match right now. So type out tmap, and then in carets the keys in this map will be of type fstring, and the values will be of type AWS :GameLift :server :model :player, and the variable will be called connected players. And let's iterate through all the player states currently in the game by typing for and then in parentheses a player state pointer player state player states and then a pair of squiggly brackets. And just to be safe, let's do a null pointer check on the player state that we're currently iterating on by writing if in parentheses player state not equal null ptr and then a pair of squiggly brackets. And then let's cast the player state pointer to a GameLift tutorial player state pointer by typing a GameLift tutorial player state pointer GameLift tutorial player state, and set that equal to cast and then in carets a GameLift tutorial player state, and then in parentheses pass in the player state to this function. And let's do another null pointer check on that by typing if in parentheses GameLift tutorial player state not equal null ptr and then a pair of squiggly brackets. Then let's use the player states matchmaking player ID to look up the associated AWS GameLift server model player object in the expected players map. So type out auto player obj equals expected players dot find, and then in parentheses pass in GameLift tutorial player state arrow matchmaking player ID. Then let's check if that's a null pointer by writing if in parentheses player obj not equal null ptr and then in squiggly brackets. If it isn't, then let's add that player object to the connected players map that could potentially be passed to a call to create backfill request by typing connected players dot add and then in parentheses for the key passing GameLift tutorial player state arrow matchmaking player ID, and then for the value pass in star player obj. Now let's check if we quote-unquote need to make a backfill request, meaning that there are currently less than 4 players connected to the server. But before we do that, let's check if the game is empty, meaning no one's connected to the server. So at this point, there are no current backfill requests going on. We are now waiting for players to join, so we could make a backfill request for this match. But for this tutorial, if it does come to that point where there are now no players in the match, once we've reached this else if block of code, then let's just end the game. So after this for loop, type out if in parentheses connected players dot num parentheses equal 0, and then in squiggly brackets just call the end game function. However, if there are players connected to the server at this point, but there are less than 4, then let's make a new backfill request for this match, because the max amount of players that matches in our rule set can contain is 4. So there's no point in making a backfill request in the case that there are 4 players in the match. So type out underneath this if statement, else if in parentheses connected players dot num parentheses less than 4, and then a pair of opening and closing squiggly brackets. So let's get the game session ID by calling get game session ID. So type out auto game session ID outcome equals AWS double colon GameLift double colon server double colon get game session ID parentheses, and check if that function call succeeded by typing if in parentheses game session ID outcome that is success parentheses, and then add another pair of squiggly brackets. And in here, let's actually get the game session ID by writing f string game session ID equals f string, and then in parentheses passing game session ID outcome dot get result parentheses. And then let's get the matchmaking configuration ARN by typing f string matchmaking configuration ARN equals start game session state dot matchmaking configuration ARN. And then let's call create backfill request and set our latest backfill ticket ID member variable to the return result by typing the latest backfill ticket ID equals create backfill request, and then in parentheses pass in the game session ID, the matchmaking configuration ARN, as well as the connected players. Now we will know if the backfill request was created successfully if the length of the ticket ID returned is greater than 0. So type out if in parentheses latest backfill ticket ID dot len parentheses greater than 0, and then in squiggly brackets so that if we know that there's currently a backfill request going on, then let's set the update game session state reason member variable. So type out game session state dot reason, and we'll set it equal to e update reason double colon backfill underscore initiated, so that the next time this handle game session state function is called, the outermost else if block of code that this code that we just wrote was contained in won't be reached. In fact, none of the outermost if else if conditions will evaluate to true until the onUpdate game session handler function is invoked. But at that point, the backfill request will be finished, so we will either be waiting for new players again in the case of success, or back in the else if block of code in the case of failure. Also notice that in this outer else if block that we are in, that we don't have many else statements. That's because if something goes wrong when we are in here, the next time the handle game session update function gets called, we will just end up back in here. And to finally finish this function, let's wrap all the code inside with the hashtag if with underscore GameLift and hashtag end if compiler directives. And then before we compile this project again in the development server configuration for the Win64 solution platform, I just want to talk about a few things that maybe some people were wondering about. So even though we decided to end the game if we found no players in the server right after a backfill request finishes, the server can still have at one point no one in the game. For example, if you start a backfill request and while waiting for the backfill request to finish, the current players in the game just leave, but that backfill request will still be out there in our tutorial because that's how we wrote the logic to handle that. And the request could still successfully be fulfilled and up to 2 new players could join the match. Also, while waiting for players, maybe we get really unlucky. For instance, at the start of a game session and no one joins the game, then we wait until the player sessions time out and then we end the game. And that leads to my the next thing that I want to address. So as for why I decided to make a time spent waiting for players to join variable, is that although it seems redundant in the sense that there will always be a point where the game session has no reserved player sessions using this tutorial's logic, I wanted to include the logic to check for the time spent waiting for players to join, because 60 seconds by default is quite a bit of time, and accidents or slow connection speed may occur. So you could, if you wanted to, change this value from comparing it to 60 to something lower, for example like 30 or 40. But then if you did that, then in this else block down here, I would recommend in addition to what we already do, which is setting update game session state.reason equal to e-update reason backfill completed, as well as resetting a couple of member variables. You should find any player sessions in the match in reserve status still, because after, let's say, 30 seconds of waiting for players to join, that is still technically a possibility. There could be reserved player sessions. So you would want to call the describe player sessions method again with a game session ID and a reserved player session status filter, exactly like how we did it above here. And then just call terminate player session on all of those player session IDs of player sessions in reserve status. And lastly, let's just scroll up to the init new player function really quickly, because because some of you guys might be wondering, why didn't we use the expected players member variable here or here, basically, instead of update game session state.player ID to player and start game session state.player ID to player. And the reason is because we set expected players in the handle game session update function that runs every second, but the on start game session or on update game session handler functions could be invoked by GameLift, and players end up joining the match right away, and hence this init new player function gets invoked before the handle game session update function gets called. So we have to check the start game session state and update game session state member variables in this function just to be safe. But the reason why I decided to make an expected players member variable at all then is that in the handle game session update method, it saves us a little code to write. So instead of checking whether to use the update game session state or start game session state player map, I just defer to this expected players variable instead. With all that said, let's go ahead and compile our project again. Make sure you have development server selected for the solution configuration up here, Win64 for the solution platform, and then right click your project in the solution explorer and select build. And actually, I forgot that we have to add some more code to deal with one more scenario. That scenario is when a player leaves a match and there's currently a backfill request. So in this case, we should stop that backfill request so that the next time the handle game session update method gets called, the update game session state.reason should be backfill canceled. And then once that happens, then hopefully the backfill request gets replaced with a new backfill request, because the original backfill request most likely had the player that just left. So we should immediately stop that backfill request, because when that player who just left starts a new matchmaking request, the backfill request that currently is in process will get canceled, because in GameLift there can't be more than one active matchmaking request with the same player ID in their array of players. And ultimately the older ticket gets canceled in this case, and the newer matchmaking request continues. And the weird thing about this, and I think maybe the GameLift team should look at this if possible, is that in this case that I just mentioned, where if there are multiple tickets in circulation with matchmaking with the same player ID, and then the older ticket gets canceled, is that unlike when you call stop match backfill through the server SDK, when a backfill request gets canceled this way, the onUpdate game session handler function does not get invoked. So keep that in mind. The onUpdate game session handler function does not get invoked for when matchmaking requests get canceled. When backfill requests get canceled due to the existence of a newer matchmaking request with a player ID that the backfill request had. So hope that makes sense. So I want to scroll up to the suspend backfill function, or sorry, I want to scroll down, I guess, to the suspend backfill function, because we have a lot of logic to stop backfill in there. So I'm just gonna copy everything inside this hashtag if with GameLift and hashtag endif compile directive, and then I'm gonna scroll to the logout function, because remember that the logout function gets called every time a player leaves the match. So I think what we should do is in here, so I think before we remove the player session, I think we should stop the backfill request. So I'm gonna press enter inside this hashtag if with underscore GameLift hashtag endif compile directives, and I'm just gonna paste that code, but we're gonna make a few changes here. So let me just fix some formatting right here. But so a couple things here. Unlike suspend backfill, we won't try to stop the backfill request in multiple attempts. So we'll only do it in one attempt, right? So if something goes wrong while trying to fail to stop while calling stop backfill request, then we won't try again like after 1 second. So let's get rid of the this else block here that calls set timer on the suspend backfill function. So get rid of that, and also this if statement here. So if not stop backfill request. I don't want to get rid of it completely. I do want to get rid of what's in the body currently. So again, I don't want to call set timer. Let me get rid of these opening and closing squiggly brackets, and let me get rid of the if statement, including the parentheses, and then let me get rid of this exclamation point, and then at the end I'm going to add a semicolon. So literally all this is going to be is if a backfill ticket currently exists while a player is leaving the match, then we'll try to get the game session ID, matchmaking configuration ARN, and we'll just call stop backfill request on that ticket ID that we currently have stored in the game mode class, and hopefully that will lead to the cancellation of the backfill request. Alright, and in addition to this, this is actually very last minute, so I apologize for the change that we're about to do, but go to the Lambda dashboard in your web browser of choice, specifically the function section, and we're not making a new function, don't worry, but we have to modify an existing function. So in my case, I have a function called track events. That's what I named in an earlier part of the tutorial, but basically this should be the Lambda function that's currently subscribed to the SNS topic that is set as the notification target for flex match notifications in your matchmaker configuration settings. So let's scroll down here, and inside this inline code editor, let's press Ctrl+ a few times. So why am I in here making this completely last minute change? So in the absolute edge case where there's a backfill request involving player sessions in the completed or timed out state, and this may even apply, and yeah, I believe that will be the case, and maybe this applies to player sessions in the reserve state, but I can only confirm for when there's a backfill request with player sessions in the timed out or completed state, and that backfill request still gets filled. So let's say we have 3 players, let's say we have 4 players in a match, 1 player leaves, so a new backfill request gets made with those 3 remaining players, and then another player leaves. But let's say, even though we just coded logic to cancel the current backfill request, and hopefully next time handle game session update method gets called, a new backfill request will be made with the remaining players. The issue though is that what if in the rare case, what if we fail to stop that matchmaking request? So ultimately there's still a backfill request for 3 players even though there's currently 2. So one of those player sessions is in completed status now. So what ultimately happens is when a message is sent to FlexMatch, when FlexMatch sends a message to the SNS topic that ultimately gets relayed to this track events function that is subscribed to the topic. When we iterate through the tickets in that message, right? When we iterate through the tickets in that message of type matchmaking succeeded, because ultimately, let's say that backfill request gets fulfilled, the backfill request containing 3 players, even though there's in actuality 2 players in the game. What ultimately happens is when you iterate through all the players in that backfill ticket, it will still contain that player whose session is currently not active. It will contain it. The problem is it will no longer contain a player session, the problem is that the player will no longer contain a player session ID. And ultimately, right now what goes on is you'll have this player item here, and you're setting this player session ID attribute equal to the value of a property that doesn't exist. So player.player session ID in this very, very extreme edge case will be null. It'll be blank. And as a result, when we call DynamoDB batch write item, you'll get an error because you can't have any attributes in the items that you're writing to a table in DynamoDB be blank. It just won't happen. So we have to do an if check. It's ironic because I added a lot of if checks throughout this tutorial, but this is actually the one time where you kind of need an if check to deal with a kind of rare situation. So let's just write out in the line above where we set player item.m.player session ID equal to squiggly brackets s:\player.player session ID. Let's just write if in parentheses, and then all we're going to do is player.player session ID. Just going to check, okay, is this a valid value? And then type out a pair of squiggly brackets, and then the line where we set player session ID in the player item, just cut that line, so Control X, and paste that inside that if statement we just made. And that is pretty much it. That should handle that edge case I was just talking about. So now when FlexMatch sends an event message to our notification SNS target, the message will still be exactly the same. It's just that we won't get an error when writing items to the matchmaking tickets table in DynamoDB. So go ahead and click the save button to save your changes. And don't worry if you're paranoid, even though this is just a really small change. The Lambda code inside the GitHub repository linked in the description below will have everything, the most up-to-date Lambda code. So just trust in the code in the GitHub repository. And also, this won't affect our functionality from before, because we're not really doing anything different, right? We're just checking if the player session ID exists, because normally we do get player session ID values in almost all the players involved in all the tickets involved in ticket of messages of type matchmaking succeeded. But in the case of backfill, we can no longer assume that this player session ID and all the player objects will necessarily be populated. And with that said, let's go back to Visual Studio and build our project once again for the development server configuration for the Win64 platform. So right click your project in Solution Explorer and select Build. And once your project is finished compiling, before we package the server again, let's go to the project directory in File Explorer. So because we made some slight modifications to the GameLift Server SDK plugin, we have to go ahead and delete the GameLift Server SDK folder in the original or in the last server build, because we want that server SDK to get regenerated when we package the project. So go to the folder where your package server build was, or the old one is. So mine is in a folder called Windows Server, so I'm just gonna go to the Windows Server folder, and then the plugin should be located in the folder named after your project. So in my case it's called GameLift Tutorial, and then let's take this plugins folder and just go ahead and delete it. Alright, now let's go back to the Unreal Engine editor so that we can repackage our server. So go to File on the top left corner of the page and go to Package Project, and make sure for the build target that you have GameLift Tutorial server selected. So right now if you have GameLift Tutorial selected, then just go ahead and select GameLift Tutorial server, and then go back to File and then go to Package Project again. Make sure for the build configuration, in this tutorial I'm going to have development selected, and then once you have the configuration checked as well as the target, go to Windows and then select Windows 64-bit. And then for the folder for where you want to package the project to, I'm just going to stick with the default project directory. So once you have a folder selected, just click on select folder. And then on the bottom right here, click on the show output log so that you can see the packaging logs. And after the server has finished packaging, I just want to show quickly in File Explorer in that window we were just in that the plugins folder was indeed rebuilt and remade, and inside of here we once again have the GameLift server SDK. Now that the Windows server has finished packaging, I do want to point out, because we only made changes in the GameLift server SDK and in the game mode class, specifically the GameLift tutorial game mode class, since the last time we packaged our project, we should not have to repackage the client, because the changes we made to the project should have only affected the server, not the client. So with that said, let's go ahead and upload our new server build to GameLift. So let's open up command prompt. Make sure that once this is open that your AWS CLI is configured before calling any AWS CLI function. So to upload the build to GameLift, type out AWS GameLift upload-build. That's the name of the command, and then this command will take in some parameters. So the first one will be --name, and in this tutorial I've just named the builds after the project. So in my case it will be GameLift tutorial, and then the next parameter will be --build and --version. This is how we differentiate between multiple server builds of the same project. So the last server build, the version was 1.0.1, so for this one I'm going to use 1.0.2, and then the next parameter will be --build-root, and then the value for this parameter will be the path to the directory containing your server build. So I'm going to pass for this parameter the value in quotes, in double quotes, because the path for my server build directory has a space in it. So the path is going to be in quotes c:/users/Chris/documents/unreal/GameLift tutorial/Windows server. And then the next parameter is going to be --operating system, and this will be, the value for this will be Windows_2012, since this is a Windows server build. And then the last parameter that we're going to pass to this function is --region, and the value for this will be the code of the region that you're operating in. So for me it's US-East-1, and don't worry, we will have this command in the description below. So once you have this all written out, just go ahead and run the AWS GameLift upload build command with these parameters by pressing enter. Once the new server build has been uploaded to GameLift, let's go to the GameLift dashboard in the web browser of your choice, and once you're on the GameLift dashboard, you should see your new fleet here under where it says builds in this list of builds. So let's go ahead and create a new fleet for this build. So to do that, click on the name of the build. So I know this is the last build I uploaded because the version is 1.0.2, so just click on the name of the build, and then from here click on actions, and then select the create fleet from build option. And as for the name of the fleet, let's go ahead and follow that naming convention that we used for the last fleet that we made. So starting with the name of the build, in our case it's GameLift tutorial, which is also the name of the project, space the instance type used for this fleet, and since we're sticking with the free tier, the instance type will be c5.large, so let's type out c5.large, space the operating system of this of the server processes in this, or the operating system of the instances in this fleet, so that's going to be Windows, and then the fleet type, which is going to be Spot, and then the word fleet, and then the build version. So in our case it's 1.0.2, and like I just mentioned, this will be a Spot fleet, so by where it says fleet type, go ahead and change it from on demand to Spot, And the reason we're using spot fleets again is that spot fleets are significantly cheaper than on-demand fleets. Now let's scroll down to the process management section, specifically under where it says server process allocation. And in here, this is where we are going to define the server processes that will run on each EC2 instance in our fleet. So for the launch path, this will basically be the path to the server executable relative to our Windows server folder, or wherever folder your package server build was packaged to. So for this, I like to go to File Explorer, specifically where our project directory is located, specifically the Windows Server folder, and then from here go to the server executable, not this one, but the one in the binaries folder in this directory. So go to the folder named after your project. In my case, it's GameLiftTutorial, then the binaries folder, then the Win64 folder, and then in File Explorer here at the top, in this little text box, that contains the path of the directory that you're currently located in. Copy everything up to but not including the path of the Windows Server directory, or wherever your server build is packaged to. So copy this part, the GameLiftTutorial/binary/Win64, paste it in here in the launch path, because this is where the server executable is located, and then type out / and then the name of the server executable with the file extension. So GameLiftTutorial server.exe. Make sure you have the full name of the executable, including the .exe extension. And then for the launch parameters, it's going to be the exact same thing as the parameters in the server process in the last fleet. So -port equals 7777, because we are explicitly defining which port that the server process will run on. And then the next parameter will be -password equal dummy, because we need to be able to pass the lambda authorizer when at the end of the game, if the server process reaches the end of the game logic, then it's going to call the record match result API method, and it needs to pass in the right value for the lambda authorizer in order to invoke the lambda function. And then for the number of concurrent processes, keep this at 1, because in this tutorial we want to only run one server process on a specific port at a time. And then click on the green check mark on the right of this row inside this table to save your changes. And unlike the last fleet we made, let's add a few more server processes for this instance. So let's click the add configuration button 4 more times to add 4 more server processes, and the launch path for each of these server processes will be the exact same one as the first process that we defined, or it will be the exact same path as that of the first server process we defined. So just Control C, copy that value, and just paste that into these text boxes. And for the launch parameters, it's going to be exactly the same again as the first server processes launch parameters. So type out -port equal, but this time it won't be 7777, because remember I just said we don't want to run multiple processes on a specific port at a time. So type out 7778 to make sure that the value is different from the port parameter of the other server processes, but the password will still be the same. So type out -password equal dummy. And then let's just copy this value to make it easier and just paste it in the rest of these server processes launch parameters values. And concurrent processes, again, keep that at 1, because like I just said, we only want one server process running on one port at a time. But then for these bottom 3 server processes, let's change the port parameter value for each of them to something unique within these server processes, these 5 server processes. So notice how I'm changing them to a unique value, preferably within a contiguous range. It'll just make it easier for when we open up these ports later down in the fleet details. And then once you're done with that, just click on these green check marks on the right side to save those changes. And like I just said, we actually have to open these ports now that these server processes are listing on for incoming player connections. So scroll down to where it says EC2 port settings, and then click on the button underneath the table that says add port settings. And then for the port range, so specify the range of ports that we are using again for the server processes. So in our case, it's going to be 7777-7781. And basically what this means is that all ports within this range, inclusive of both the start and end range, will be used for this setting. So let's change the protocol from TCP to UDP, and for the IP address range, type out 0.0.0.0/0 to indicate that we are allowing anyone to try to connect to anything running on these ports. So click on the green check mark to save your changes. And as for the protection policy, remember again in this tutorial, keep the protection policy at its default value of no protection. And then once you have all that done, go ahead and create the fleet by clicking on the initialize fleet button. And once the fleet is created, we now have to wait for the fleet to enter the active status. So go to the events tab and periodically just go ahead and click on the refresh button to see when we get an event of code fleet scaling active, I believe. I could be wrong about that, but doesn't matter. The activation process of a fleet takes approximately 20 minutes anyway, so go ahead and pause the video and come back in roughly that time. Okay, now that this fleet is active, and just to confirm, you can always click on the refresh button to see if the latest event is of type code fleet scaling event, and then of course refresh the page because this UI is not reactive or reflective, so the status won't change to active if the fleet is actually active. But at this point, one more thing we have to do before testing out the server by running 4 clients. We have to change the fleet destination in our queue associated with our matchmaker to point to this new fleet that we just made. So click on where it says fleets and then go to where it says queues, and then from here click on the name of our queue, and then from here click on the actions button and then select the edit queue option, and then from here under where it says destinations, you'll see a table with a bunch of fleets or aliases. Well, in our case we only have one fleet because that's just what we're doing in our tutorial. So in the only row in this table, just click on the pencil icon on the right to edit this fleet destination, and then under where it says fleet or alias name, just go ahead and click on this drop down menu and select the new fleet that we just made. And it should be easy to find because to the right of all of these fleet IDs, you should see in parentheses the name of the fleet. So the last fleet we just made was GameLiftTutorial C5.large Windows Spot Fleet 1.0.2. So go ahead and click on that. And then to save your changes, just go ahead and click on the green check mark button and then click on the submit button. Okay, now let's go ahead and finally test our server, the moment of truth, to see if the backfill that we just implemented works. So go to File Explorer, specifically where your project is located, and let's run the client that we actually used for the last fleet, because like I just said earlier, all the code that we mentioned since the last build was all server related, so stuff in the game mode class as well as in the GameLift server SDK. So go to where your last client build was packaged to. So in my case, it was in a folder called Windows No Editor. And then in here, I'm not going to double click the application to open it up right away because it's still going to use these size parameters from last time. And with those size parameters, we can only fit in 2 clients on the window at once. And I want to try to fit in 4 on the window at once to give you guys a better idea of what's going on. So let's in File Explorer, in this text box that has the path of the directory that we're currently in, just replace the text inside with GameLiftTutorial.exe, so the name of the application including the file extension, and then space ResX, and we'll set this equal to 500, and then ResY, we'll also set that to 500, and then we'll pass in 2 parameters in addition to those ResX and ResY values. So for WinX, we'll set that equal to 500 as well, and lastly for WinY, we'll also set that to 500, and then just press enter. So what that's going to do is it's going to launch our client in a window of approximately 500 by 500. Now just a warning, you may have to adjust those parameter values that I just set in that command, and also don't worry, that command will be in the description below as well. But I am on a 1920 by 1080p monitor and Windows resolution, so that's why those parameters will work for me when trying to fit in 4 of these little windows on the same screen. But just to note, go ahead and close this window. So I don't know if I mentioned this last time, but those parameters will only be remembered by, I guess, Windows when you run this application the next time, only after closing a window of that size. So you have the application running 500 by 500 Windows size, then you close it, then the next time you open it, all the future clients that you open up will also be of size 500 by 500, unless you of course change the size parameters and then close it again. So let's double click this now 4 times so that we can get 4 clients. So again, I'm just going to launch the GameLift tutorial client executable about approximately 4 times, and it's going to be kind of weird to fit all of these on the screen at once, but I'm going to try my best. So, and let's just launch the executable one more time, and let's try to fit this on the screen as well. And let me just minimize this browser window as well as our running instance of Visual Studio, so that, and maybe Unreal Engine as well if you're running that, so that you guys can better see what's going on. So just a note, since the last time I tested the client and server together, I made 2 new accounts because now I want to test 4 clients at once. So I did that off screen. So if you guys only have 2 accounts, go ahead and of course just sign up. You can also sign up in one of these client windows directly, and then that will also work. That'll automatically sign you in, and then you'll be able to join a game right after signing up. Or of course you can make a new account by using Google Sign as well, but I'm just going to go ahead and log into my 4 accounts. So I'm just going to log into my FlopRam account first, and then I have, of course, maybe I mistyped my password. That tends to happen with me sometimes. So okay, there we go. And then again, I have 1 account that I use to make with Google Sign-In, so let me do that real quick. So again, let me go into that account, and then in my next account, it's just a random account I made, so I'm going to sign in with that, and then for my last account, let's sign into that as well. Okay, what we are going to do first is we are going to try to get 2 clients in a match first, and then hopefully we can backfill that match with the other 2 clients. So these 2 clients on the left here, I'm going to click the join game button on both those clients, so that it'll start a matchmaking request on each client, and then hopefully these 2 players can get into a match. Also, just a note, while you're in the main menu map, you can always click or double click to lose focus and move to another window. But when you're in one of these when you're in one of these game windows, you have to alt tab to switch between the windows. Alright, we have 2 players in a match. Let's go back to the clients that haven't joined the game yet, and let's press join game on both of these clients so that we can try to get these guys to backfill the remaining match. And wow, that was really quick. So seems that the backfill request was indeed successful. So we were able to get we were able to get both of those players into the exact same match. Let's say I actually leave now with this player. So I'm going to press escape. So as you can see on pretty much almost all of those clients, and that player just left. So we should have a backfill request going on now with 3 players, the 3 players still in the match. So if I click join game on this client that just left, we should be able to get right back into the match. So that makes absolute sense. Now let me go to the 2 clients, 2 other clients, and what I'm going to try to do is I'm actually going to quit out of 2 clients this time. So let's press escape again, and then let's go to maybe this guy here. I'm going to press escape on that guy, and there's now 2 players in the match. Let's see if our logic works here. So if we try to start a new matchmaking request on both of these clients that currently aren't in a game, so let me just click join game on both those clients, we should be able to get back into the match, and that is indeed the case. So that looks pretty good here. I'm going to do something really crazy now. I'm going to have 3 players leave the game now. So I'm going to escape out of this guy. Let me go to another client. Let me escape out of this guy. This guy, let me escape out of him too. So now we have one player in the match. So the question is, can this one player in this match get backfill with 3 new players? Now, let's do it. If you want to backfill with all 3 of those players, you gotta click the join game on really fast. So let me click on all 3 of those clients. So let me just click join game on all of these guys really fast. Oh, see, I didn't do it fast enough. Because I didn't do it fast enough, you'll notice that so what happened here was actually 2 backfill requests were made and completed very quickly. So in that case, I wasn't able to do it, but you could theoretically have gotten 3 players to rejoin this match. But what we instead did was, first we did 1 backfill request to get 1 player in the match first, and then ultimately we created a new backfill request to get the 2 other players into this match. So now we have 4 players again, and also we're approaching that 60 seconds until the game is over mark. So at this point, suspend backfill should be called, so there's going to be no chance of a backfill request for this match. So let's say I leave the client, let me make the client leave the game on this end, right? And if I try to join back the game, try to backfill that game, it's not going to be possible, right? Because there's no backfill request going on anymore. Once 60 seconds until the game is over is reached, not only are current backfill requests canceled if one exists, but also the handle game session update timer handle gets cleared. So for example, if I press escape here and if I click join game on this client, these 2 clients now are going to get into their own match and not going to be able to backfill that match. So as you can see, those 2 clients were indeed able to get into their own match. So I find that quite interesting, and let's actually just quit out these 2 clients in this new game session, because I want to go actually to the GameLift dashboard as well as the DynamoDB dashboard, and maybe even look at some CloudWatch logs to kind of explain the flow of exactly what happened. So we saw the Cowboys lost and the Aliens won, and this guy's player stats got reflected, and this client's player stats got updated too. And believe it or not, even though these 2 client windows, even though their player stats weren't updated yet, because we would have to reload the main menu widget to do so, since we're not periodically calling get player data in these 2 windows. But we're gonna actually see in the DynamoDB table that actually, believe it or not, most likely these 2 guys' player stats actually got updated, and I'll explain that why. So let's go to the web browser of your choice and make sure you have the GameLift dashboard, the DynamoDB dashboard, as well as the CloudWatch dashboard open. Well, let's start with the GameLift dashboard, specifically the fleets page. So if you're still on the queues page, just click on where it says queues and then go to where it says fleets. And then from here, just select the new fleet that you just made. And then from here, go to the game sessions tab and ignore this bottommost game session that was made and terminated. This was just for me testing just off screen. So let's focus on these 2 game sessions above that one, because these are the 2 game sessions that we just saw that when I was testing the game. So if you notice that the latest game session only lasted 16 seconds, it was really short, right? Because if you remember, I was testing whether or not we could backfill a match when there was less than 60 seconds remaining in the match. The answer was no, right? So when I got those 2 players, those 2 clients who were in a match to start a matchmaking request, they got into their own match, which is normal because that other game session couldn't be backfilled. And then I left right away with those 2 players. That's why this game session only lasted 16 seconds. Now, if we click on it, you'll notice that there's only 2 player sessions in it, because there were only 2 players in that game at one moment in time. So let's go back and let's actually go to that other player session, because if we click on this one, you're gonna notice a lot more player sessions. But you might be wondering, how is this possible, right? Because there were only 4 players in the match at one point in time max, and they were the same 4 players, right? But that's the key, right? So you still make a unique player session object for when a player rejoins a game or joins a game in general. Notice, like, you see all these player ID values here. It's kind of hard to tell, but these are all like if you took all of these player ID values, there wouldn't be more than 4 player IDs. And I'm trying to scroll down here, but so even though there are multiple player sessions, in the end, if we look at the list of player IDs, there were still only at most 4 players. So I just wanted to sort the player ID by clicking on this, so that's kind of better to see that there are 4 unique player IDs here. I know it's kind of hard to see, maybe just to expand this section a little bit so it's a little easier to see, but I just want to make that note for anyone who may be confused. Hey, why are there a bunch of player sessions when there were only 4 players in this match? That's because it's player sessions, not players. So players are going to be identified by player IDs, but their session, their time in the game, will be identified by the actual session. Hence why, if you notice, the total time for a lot of these player sessions didn't last the whole extent of the game. In fact, only one of these players, I believe, I never quit out of the game, and that's why the total time for one of these game sessions, for one of these player sessions, took up the entire length of the game session. And notice how this is the only player session object for this specific player ID. Okay, now let's go to the DynamoDB dashboard, specifically the table section, and let's start with the player section, and specifically in the items tab, so that we can see all the items in this table. So I currently have 4 players, right, just to make it easier for testing. And as you'll notice right away that for 2 of these players, the number of wins and losses, if I minimize this browser window, don't correspond with the wins and losses for 2 of these clients, specifically this guy and this guy. So this client was on the losing team clearly in that last game, or in the second to last game session that was made, and this guy was on the winning team on that second to last game session. Because if we go back to DynamoDB, we have a guy with 12 losses and 10 wins, whereas what you saw in the main menu map of one of those clients was that he had 11 losses and 10 wins. And then we also had a guy with 15 losses and 6 wins on that client, but on here in DynamoDB, that guy actually has 7 wins. And again, we're not seeing the changes because those clients who just left the game, or who ended up leaving that game session towards the end of the game session, I think maybe around like 40 or 30 seconds before the game ended. Those players, even though they ended up joining another game, they left that game in time before the pick a winning team handler function timer function was invoked. Remember, pick a winning team, so a winning team will only be chosen if the game actually goes its full duration. And the only way a game will go its full duration is if at one point there isn't 0 players currently in the game before there are 60 or less seconds left in the game. So that's why we don't see that's why, so if I go to the match results table, right, for example, so I know there's going to be a lot of entries here. I'm going to be the first to admit, so I did a lot of testing off tutorial, but let me just look at the latest entry here, because I believe these entries are sorted by default by when they were inserted in, I guess, descending time order. So I'm going to look at this latest entry here. So if we look at the losing team, it was aliens, and if we look at the winning team, it was cowboys. So I do remember that does seem to be right. And also, luckily, we have the game session ID, right? So if we just look at the game session ID, we'll look at these last few values, AC12B, and then we'll go back to the GameLift dashboard, and okay, so this is not the match result for this specific game session, so we actually have to keep looking. Let me look. So this is gonna be tough, so I'm gonna have to find this. I believe I can add a filter, so I can do game session ID, right? Game session ID, or sorry, no, it's not even game session ID. The attribute is called filter, and let me just get the game session ID from the GameLift dashboard, and then just paste it here, and then we'll do start search. Okay, so we have the entry, and also just to confirm that there wasn't a game session, that there wasn't a match recorded for that one match that literally lasted 16 seconds. Let me just do a search on this in DynamoDB, just to show that there was no match result recorded for that game session. So let's go back to the game session that actually lasted the full duration of a game session. So let me get that game session ID, and let me go back to DynamoDB and just paste that value in there. Click on Start Search. Okay, so let's see the match result that was recorded in DynamoDB. So let me click on this item in the table from the search results. Let's look at the losing team and winning team. So the winning team was actually Aliens, and the losing team was Cowboys. And if memory does serve me correct, if you go back in the video, I believe that was the case. Again, so Aliens team had 2 players, Cowboys team also had 2 players. Now you may be confused because by the time the game ended and by the time on the screen for the players who were still in the game, when it said the Cowboys lost and the Aliens won, two of these players here weren't in the game. So why is it that they were still included in the match result recorded to DynamoDB? The reason is that these players from these teams rely on the latest matchmaker data from the game session object. Now, the matchmaker data in a game session only gets updated in 2 cases. Either one, the game session just started, so match was just made, and hopefully it gets hosted on a game session, and then that game session will, as a result, have that matchmaker data. So the players who are originally supposed to be in the game at the very start. Then the matchmaker data will change every time a backfill request gets fulfilled successfully. So if you have a backfill request and you're able to find other players to pair up with that backfill request to successfully update that match with new players. So essentially the last time a backfill request was completed for that second to last game session that lasted its whole 4-minute duration, it was backfilled with a total of 4 players. So in the end, after that backfill request succeeded, there was 4 players that were supposed to be in that match. So as a result, that was the latest matchmaker data, because after that point, backfill requests were suspended by the suspend backfill function, and then the handle game session update function was also stopped so that a new backfill request couldn't be made. So ultimately, by the end of the game, these 4 players were the players in the latest matchmaker data for that game session, and hence why they were all included in the match result recorded to DynamoDB, because this Lambda function relies on the game session data returned by the describe game sessions method. And I know that I said earlier that I wanted you guys to open up the CloudWatch dashboard so that we can look at the logs for the track events Lambda function. This is the function that is subscribed to the SMS notification target for our matchmaker. So when events with regards to matchmaking requests get sent by FlexMatch to our notification target, our Lambda function gets invoked. And since we had that log message, our console log statement in there, we also print out logs, specifically the actual message sent by FlexMatch/GameLift. Now, again, I know I said we were going to trace the logs, but I was just doing that just now. I was trying to record me tracing the logs, and it was getting a little too complicated, and I didn't think it was going to be easy to follow. So I decided not to trace the logs with you guys in this tutorial, but I definitely encourage you guys to do it on your own, because it is kind of interesting trying to piece together what exactly happened. But also keep in mind when you are looking at these logs that they might not be in order. That's 1. And 2, this is very, very rare, but I have seen it happen. Sometimes logs might be missing. So again, just keep those few things in mind when looking at these CloudWatch logs. Okay, now let's minimize this browser window and let's go ahead and test our clients, because I want to test one more case. So first, I know you guys haven't seen it in this tutorial series so far, but it is possible to get 4 players in a match within like first try, I guess we can call it. Like basically you can have 4 players get paired up in a match all at once. So starting from individual requests. So if I click join game on each of these clients, really quickly, there is a chance that they will all end up in the same match together at the start of a game session. So let's try to do that. Click these buttons really fast. Okay, so took a while, but they're all looking for a match now, and hopefully, if we're lucky, if our rule set allows for it, they'll get into a match. Okay, so we weren't that lucky here. They didn't all get in a match at the same time, so sometimes that's going to happen, right? Our rule set isn't going to prioritize all of these players getting into a match. So let me try again. Let me try to, I'm going to press escape on all of these clients here, and I'm going to try to do that again. So click on the join game button really fast on all 4 of these clients. So I'm going to start again. Let's do this. Can we all get in a match? It's going to be really difficult. Oh, and we were not able to get into a match. Okay, so let me try one more time here. I know it's going to be really hard because it's not easy. Again, you got to be really fast when doing this. So let me try again. Click. Can we get all 4 of these in a match? Doesn't look like I was able to get all 4 of these in a match. Okay, this is okay though. I was able to get the next best thing. I was able to get the other 2 players to backfill this match currently really quickly. So okay, so we have 4 players in the match. That'll do. But again, keep in mind that you are able to get 4 players in a match based on, again, let's say if 4 individuals started a matchmaking request on their own, like literally around the same time, then these 4 players, they have a chance, again, if the rule set allows for it, to join the same match. But the test I wanted to test is, okay, let's say if 3 of these players left, right? So maybe we could get the next best thing. I'm going to press escape on 3 of these clients. So right now there should be a backfill request now, including this one player, this one sole player. So the question is, can I backfill a request to make this match full? And I believe the answer is yes. So let me, again, we gotta do this really quickly. So you gotta click join game on these 3 clients really fast. No, see, I didn't do it fast enough. Okay, so, and now these other 2 guys got into their own game session, so that's not gonna be good either. But let me press escape here. This is a terrible test, but trust me guys, it is possible. You just gotta be really fast. So right now, let's see if we can backfill the other match with these 2 players. So I'm gonna try that right now. Okay, so we're able to still backfill the match. Again guys, it is possible, but it's just one of those things to keep in mind. Like backfill and creating matches with a certain amount of players, it's very it can be very random at times, like non-deterministic, because your rule set is basically going to determine, okay, do we backfill this, or do we prioritize backfilling this request using these new players that are looking for a match, or do we prioritize putting these new players looking for a match into their own match? And that's the question. Also keep in mind that we only have 5 server processes on one active instance running right now. So theoretically, we can only have 20 players max in games at a time, because each match can have 4 players at most. So if you have more than 20 players looking for a match, then some of those players will be able to be successfully placed into a match by flex match, but they won't connect to the server because one isn't available. So you may notice in these kinds of scenarios that clients in the main menu map will have the text saying currently searching for a game in the middle of the screen for more than 1 minute. Even though the currently defined amount of time before a matchmaker request, including backfill requests, by the way, timeout if they don't lead to an event update of type potential match created. But even if a ticket reaches the potential match created stage, that doesn't guarantee the ticket to reach matchmaking succeeded status if all the available server processes are currently in use. So tickets in this case may seem that they are frozen because they could be in potential match created stage for a long time. And when they time out in that stage, I don't believe a message gets sent to the SNS topic, but I could be wrong. And this is why GameLift made a useful auto-scaling solution to combat this issue, to ensure that you always have enough available server processes. And we will hopefully go over this in a future part of the tutorial. But yeah, also I kind of addressed the fact that backfill may not always happen in certain scenarios. So let's, I guess, just wait for this game session to finish. Let the counter go down all the way down to 0, and then a winning team will be chosen at random, and then we'll just check in DynamoDB if the match result was indeed recorded for this match. I believe before we started this match there were 33 results in that table, and the results in those tables don't disappear. So if everything worked, there should only be 34 results, because again, those other game sessions where we made but left really quickly, those shouldn't lead to match results being recorded, because they didn't go the full duration. Because again, once those players left the game, the game session should have terminated, because it should have realized, okay, there's no one in this game anymore. Okay, let's go to the DynamoDB dashboard, specifically the match results table, which we are currently looking. Let's get rid of this filter, and let's just refresh the amount of items in here. So how do I get rid of this filter? Scan, cancel changes, I guess. I don't want this filter anymore, so can I just do this? Can I refresh now? Oh, start search. So to get rid of a filter, you gotta actually search again. That's kind of weird. Okay, so we have 34 items. Like I said, that's the exact number we expected. Now let's actually look at the specific match result that we're concerned with. So let's go to the GameLift console, specifically the fleet with all the game sessions. So as you can see, a lot of game sessions were made here because we were trying to do that backfill, and sometimes we wouldn't be able to backfill, which is normal, right? Because it always depends on the rule set. But let's look at the latest game session that lasted for more than 4 minutes, because that one actually led to the picking of a winning team. And then let's get the game session ARN, copy that value. Let's go back to DynamoDB. Let's add that filter again for the attribute set to ID, and then for the value, just paste in that game session ID and press start search. Of course, we have a match result for that game session. And let's look at the losing team. So yeah, that was the Cowboys, and the winning team was the Aliens. That does indeed look correct. And I just want to reiterate, even though I've said it so many times now, it is possible to backfill a match with one player, with 3 new players, with one single backfill request, not 2. And it is possible to create a new match initially with 4 players without a backfill request. I just couldn't do it in this video because my hands were too slow at clicking buttons, and my guess is that the rule set just didn't like me today. But with all of that finally said, that is pretty much it. Guys and gals, that concludes all the major long hours of coding that we have to do for this tutorial project. Remember, all the code will be in the description, or all the code will be in a GitHub repository linked in the description below. Congratulations on sticking to the tutorial series all the way through and making it this far. Really appreciate you guys so much for watching and leaving feedback. Note that this isn't going to be the last part of the tutorial series. We still have other non-coding related things that we have to go over, such as remotely connecting to our Windows EC2 instance that is hosting our server processes. We also have to go over making a Linux server, because Linux on GameLift is cheaper than Windows. We have to go over auto scaling and pricing, and if we have time, we can also work on an Android client to show cross-compatibility between clients being possible. Basically, can we have an Android client and a Windows client in the Windows or Linux server process hosted on Amazon Web Services. But before I sign off, I just want to give an extra thank you to a lot of people, starting with our patrons on Patreon. I'm just going to name off all the names of the patrons that we currently have. So special thanks to Ahmad Rashad, Morgan, Heidemann, Elise, Diego, Eduardo Camacho, Adrian Vergara, BioBlaze Payne, Demas, Evan957, Lucas Moskin, Rick Morgan, Twin Assassin, Garf Snacks, Keith Perry, and Solar Tricks. Again, those names that I just read off are our current patrons, but I also want to, of course, acknowledge our past patrons, as well as all the various people who have donated to us on PayPal. Also, I want to thank all the people who tuned into our streams when we were working on making these tutorials, because when you guys watch us, that helps us. And I specifically want to thank these stream viewers for spending a lot of time watching us. So I want to thank Amelis, Pivotman, Beast, Baraka, Mikkel, Leo, Shane, Kaisaki, and anyone else who watched us live working on the tutorial project. And lastly, I just want to thank everyone in our Discord for contributing to amazing discussions, feedback, and support. Please join our Discord if you are not currently in it. Links will be in the description below. Thank you to the AWS staff who have been super supportive throughout this process. Thank you to everyone on the AWS Game Tech forums, specifically of course Pip, because I think, to be honest, he's probably answered the majority of my questions. But thank you to everyone in the community, because I've seen forum posts that weren't answered by Pip, but they still helped me tremendously, and even to the people who asked the questions too. And of course, thank you to the entire GameLift team for making and creating such a great product. And now that is pretty much it. Of course, if you have enjoyed this tutorial series, please subscribe to the channel, leave a like on the video, consider supporting us on Patreon or through PayPal, and hope you guys have a spectacular day.